So good morning, everybody. We are live now. Welcome to the Synthetic Landscape Lab juries that will take place today and tomorrow. These are the end of winter term juries, and we will see today a series of courses that range from second to fifth year design studio, as well as a theory studio. So we will, some of the studio use virtual reality, other explore 3D scanning technique to develop a synthetic landscape. So maybe if the faculty would like to introduce briefly the course, maybe the first one is BitBioBot with Marco Poletto, Maria Kapskova, and Irini Tsumoko. Marco, Maria, if you would like to introduce the course briefly.
Yeah, no, I can just spend a few words. The course this year was really an experiment, in fact, and we set to engage with the students in the virtual environment of Mozilla Hubs since the beginning of the program. So we tried as much as we could to conduct our tutorial as well while immersed in the projects that the students were developing, and the projects were of course very much concerned with the state of affair of our planet, and effectively the concept of synthetic landscape was used to highlight some of the conditions that characterize what we call the urban sphere, or the extent to which the infrastructure of our society is transforming and merging into the systems of the biosphere. And the result are a series of virtual rooms, as we call them, which are very much designed at the scale of the regional landscape, using data from satellite sources, as well as an array of digital simulations, some of which also employed AI machine learning algorithms. So it's really a quite exciting new way of understanding the landscape and immersing into it. And I can't wait to see the final result. I think the first presentation will be, in fact, one of these immersions. So I welcome all of you, and of course also thank Maria, Irini, and all the students for the not only the hard work, but also the bravery in exploring a format that we never tried before, and that obviously came with a series of challenges, but I think also with a lot of new discoveries along the way.
Then we have the second year studio that was led by Anna-Rita Papeschi with Lisa Brunner and Matthias Berner, titled ForestHUTS. Anna-Rita, would you like to briefly introduce the course?
Yeah, sure. With the second year students, we have been looking into, we have basically started our work with 3D scanning techniques. So all the students have been working on a site which is close to Innsbruck, which is the Burggreen Tower, and of trees, plants, and that are supposedly some sort of platform.
Did we?
I think we lost.
I apologize. My connection is not the best. Yes, I am back. Can you hear me?
Yes, I can hear you. We had some technical issues.
Yeah, sorry. I will my brief introduction. So we will see basically like 5 projects split from today and tomorrow. And I actually have to say I'm very proud of the work of the students. I found it very creative, and for particular to be, practically speaking, their first attempt to develop like a conceptual design, and a very, very promising work.
So thank you, Anna-Rita. And then we will have the theory course on synthetic landscape led by Teresa Greskova. Teresa, would you like to introduce briefly what we did? You're muted.
Hello, everyone. Regarding a theory course in the Synthetic Landscape Lab, we have went into a quite interesting journey, dividing a theory or developing a theory of Synthetic Landscape Lab, dividing it into series of different keywords. And therefore, each student has been investigating one of those keywords in order to create together some kind of puzzle of definition of what a synthetic landscape is.
Thank you. And finally, we will have also 3 to 4 pre-diploma students that are the one presenting their brief to then start their thesis work next term with myself as well as Maria Kapskova as supervisor. I thank the guest that we have today, Professor Liz Werner from TU Berlin. Hi, Liz. Nice to see you. Good morning. And then we have, good morning, Matilde Marengo, head of school at the IAC in Barcelona. Hi, Matilde.
Good morning. Hi, everyone. Thanks for having me.
Nice to see you. And Melissa, we had a problem with this camera, but as we discussed in the pre-coffee, we had already a very good conversation, as usual, good comment. Dr. Melissa Sterry, which is founder of Bionic City. Hi, Melissa.
Hello.
Hello. We also have with us Steven Siegel and Corbinian Erziken that are a PhD student in the lab and will contribute to the comment and also to the recording of the virtual room. Thanks, Corbinian. Stefan, hi to see you. Good morning.
Thank you. Hi.
Okay, perfect. Then we can start. How do we start? Maria, do you want to keep the time and the lead of the student sequence?
Thank you. So we start with our first master student with the VR room. Thole, you will go first. And we kindly invite you all to join us in the VR room. We also will be sharing our screen here in Zoom, so you can follow also via Zoom our trip through the VR rooms. But you can also access the room directly. Thole will post the link to the room right now here in the chat. Thole, could you please send it here? So in order to access the room, I sent you a short instruction, but basically you just need to click the room. Please enter with Google or with the Google Chrome or Mozilla directly into the room. Safari or Internet Explorer will work not that well. So you can just access, load all the objects in the room, and we can go there together.
I guess Marco is already there.
Yeah, Marco.
We will have a VR session at the beginning of each session as a sort of warm-up. So we hope to see you all there, and then we meet again here in 20 minutes after the comment with Thole for the next project.
Yeah, if you are entering the VR room, I would kindly ask you to mute yourself here, so you don't double the voice.
See you there. Ciao.
Carbini and Stefan, I would kindly ask you to share this screen.
Okay, could you allow me to share the screen?
A second.
Wow, now I'm busy choosing an avatar.
Claudia, could you please allow the screen sharing?
Yes, you can share now. I was already in the room, sorry.
Okay, to rewind the first two steps, This project is placed in the. I can hear myself somewhere. This is disturbing. I started working in the Amazon forest and wanted to deal with the deforestation at specific sites, and I've chosen this one. Which is near São Félix, Xingu in Para. And by starting to work on this, I tried to understand the mechanisms ongoing with the deforestation, and firstly found the connection between the forest line and specific heights and the direction the cutting is going, which is uphill. So from this on, we can go to the next waypoint where I can continue more. So we can now fly to the waypoint 3, which is exactly over waypoint 2. Okay, this level explains more deeply the process of cutting. What you can see is the development of changing biomass. More and more forest is being destroyed and transported away, which leads to a change of biomass levels. This floor highlights the areas in which the biomass is decreasing most at the moment, indicating by the vector length you can see. Before going on, look through the previous floors as we will now move from data extraction to data manipulation. Compare each level with the one below, and afterwards fly up to the next floor. If you can look up and around, you will see waypoint 4, where we'll read up again. Okay. You now moved through the first floor of the lab that works with the data extracted instead of just showing it. Out of the lower level, it generates points indicating how much biomass is present at the site directly below. At the moment, you are at one of the highest biomass levels of the whole site, which is roughly 180 tons. In this kind of area, biomass is produced excessively, resulting in a layer of dead biomass being decomposed on the ground. This takes up to 10% of the positive mass you're seeing. When looking to the site, you can spot a scale indicating the tons of biomass, but as well see that it's going into the negative. This is because of it being destroyed, providing an amount of CO2 emissions directly connected to it. As time will progress, this flow would move downwards through the lab, increasing the amount of released CO2. To prevent this process, the lab is working on a solution that works on every different mentioned problem, changing the landscape itself with machine learning algorithms. The layers below work as input to transform biomass and settlement techniques, but another input is needed to change the transport mechanism. To do that, the lab is combining satellite data from the site with data of the Amazon Delta in order to use a natural generated transport system instead of the existing one. From here, the lab transforms all inputs into a new digital generated landscape. To take a look, go upwards, follow the lift directly over the waypoint, through to the next floor, and keep on going upwards to waypoint 5 to get an overview. The transformed landscape uses the river delta as a natural alternative transport system, going through a forest plateau towards the valley, not aligned to elevation as before. By transforming these settlements from city to sub-cities that are placed at the highest amount of biomass, the interaction between them can now move parts of the dead biomass, which is not needed, to areas where the forest has been destroyed prior. By using it as a fertilizer, the ground will not dry out and can regrow vegetation, resulting in farmland not needing to move every 2 years or even enable to regrow lost forests over time. The lab works out a more visual end proposal using again the data and methods from lower floors. The outcome can be seen above us. You can again follow the lift, but before moving on top, take a look at the biomass data points below the surface, then go with the direction of the lift through it. Waypoint 6 is visible from here. We meet there, but on top of the surface. Okay, for those who did not work with virtual reality rooms as hub before, you can toggle the flight mode in order to fly again when stuck to a surface. So you can move to through the surface on top. On the computer, it's toggled with the G with G. Okay, but I think most of you are on top. So what you're seeing is the highest room of the lab showing the final result. From this hill, you can see the abstract showing of biomass being transported down towards the valley. If you follow it, you will end up at the last step of the lab presentation. But before doing that, go in the opposite direction or fly up so you can spot the areas where the biomass comes from and the sub-cities shall be. If you want, deactivate flight mode and chase the biomass to where it will be used as a fertilizer. There we'll end the lab tour and hope for some feedback and discussion.
Okay, thank you very much, Thole. Where should we stay for the discussion?
You can follow the biomass animation to the endpoints. They all do end up at the valley.
Okay, found you.
Maybe like a roller coaster. They're fun. They're fun. I like this top layer. It's really a bit like a fun fair.
Claudia, Marco, you should mute one of the computers.
No, it's that Marco has got both the audio open, the one of
Yeah, sorry.
we are in different rooms, but I guess yes, both is
they hear me through
the headphone, the headset, then the one of the computer. So we're hearing from both sides.
Sorry, it's my fault.
No, just.
So thank you all for listening. I hope you enjoyed the tour and as well with the disturbance in between. Yeah, but I hope for some discussion as well. Thanks a lot.
Thank you very much, Thole. Marco, we would need to invite you closer to your computer so we hear you better in Zoom.
Yeah.
And
we do it in Zoom, the comments.
Yeah, thank you so much for the presentation.
Maybe we do it in Zoom, the comments.
Yeah, I know it was a bit difficult to follow at the beginning, and thank you everyone for figuring out how to do that. I hope we could discuss the project now. And
These are so great.
Yeah, I would like to invite everybody to comment.
I think we reached the capacity of Mozilla in terms of people.
Yeah, I didn't know that we are going to be so much people. I think there's a setting for that, but...
Yeah, I think it goes up to 25 or something, and then it starts to struggle. But hey, you know, this is a first experiment, and from my point of view, it was an extremely successful project. I don't know, what do you think, Maria, as well, and as Irini? The progress was fantastic. I mean, to be fairly honest, Thole, you were very engaged from day one, and I think, you know, I still remember your first rooms. You tried 3-4 different combinations, and, you know, really struggling with the software, but also with, you know, making sense of it. And I think in this final rendition of your project, you know, things finally came together in a sense. There is first of all, a clear sense of aesthetic throughout the project, which means that you can actually experience navigating this space as a whole. It actually really has the feeling that we are you know, visiting your project, and has, you know, really authorship to it in a sense. And on the other end, also, I think you managed to actually coordinate and you know, the data, the information that you extracted and mapped patiently in a way that is meaningful. So it's not just like a kind of graphic experiment of you know, of a VR construction, but there is a real information here which is plotted consistently with geographical consistency and precision, so that we can actually correlate data from different sources in a way that is not just spatially you know, enjoyable when you immerse yourself, but it is actually meaningful in a sense of being able to understand what is going on in that landscape. And then, you know, as we come up, I kind of really enjoyed also the sequence of images that become surfaces. So in a way, you know, these are kind of a new landscape that you are constructing, which are very much extrapolation of the data, but then also bring a whole new perspective in it. Again, I mean, maybe these images, in a way, they are quite minimalistic in their approach. They look very much you know, as satellite images, but of course we know that they came from you know, pretty sophisticated simulations where you have also mastered machine learning techniques and deploy them into transforming existing satellite images through data, and you know, essentially creating scenarios of the future that are on one side based on this data, but on the other hand also very much speculative in terms of how we may be able to restore these ecosystems which have been damaged by years of deforestations. And so I think in my mind, you know, these come together in this top part of your virtual room, where in a way that is also kind of fun. And I sort of like that, you know, that you wanted to play with this you know, roller coaster bubble. I don't know, you call them biomass, I'm not so sure, but you know, I think in a way I like to read this space also quite literally in a way, and you know, as a space that has the potential to be kind of enjoyable and fun, and in a way, again, tries to create a new correlation between the world of data and you know, how do we perceive them once we are immersed into them and into the spatial and material you know, products that these data kind of underpin. So in that sense, I think it's very successful. Of course, there is a lot more speculation, I think, that can be done, which I don't think you have necessarily brought to your narrative. Your narrative is very matter-of-factly, which I appreciate in a sense. I prefer that you stick to the data rather than saying things that you're not sure about or you don't feel. So in that sense, that's good. But on the other hand, I'm sure that in the weeks to come, you know, we can all look back at this and begin to also dream further in terms of how this space could really begin to exist or inhabit, you know, these are kind of new ground that exists between, you know, real landscapes, the sort of machinic vision we get of them through satellite, and the kind of rematerialization that we are now be able to share and experience in this kind of VR rendition. So again, I think we're just beginning this journey, and I think in that sense I will commend you, because you went very far in it, again, given the circumstances. So yeah, it's a congratulation for me.
Thank you very much.
Yeah, I would just join the comments of Marco. I absolutely enjoy the project and enjoy the whole process of the development. I think you're very consistent, very coherent, doing step by step and giving a lot of effort to this project, and it's very much appreciated. And I really like how you use this virtual reality space without kind of creating the prototype of reality, but probably investigating reality from the idea of data, no? Looking to this forest, not through the physicality of forest and trying to remodel the trees, but more perceiving it as a set of data, as a set of particles, as a biomass distributed all around the space, no? And measuring the space through these bits or particles, no, that you are recreating. And I think that really gives a different understanding of the landscape. And so I really find it very successful in the project. Maybe, I don't know, I think you heard our comments already half a year in a row. Let's invite the rest of the team just to talk and give us your impression.
I would say, I think graphically it's extremely strong work. I think the production standard's very high. Even though I'm looking at it in 2D, it's very clear that this would work really well if I was using a VR headset. I think, as Marco pointed out, aesthetically, there's a very strong style, and it's actually very elegant, and it's very foundational, and that you can see this style being applied to other projects and developed. And yeah, I mean, it's what it's really showing here is that it's working very well, like as a three-dimensional virtual reality infographic. So it's showing the flows within the landscape very well. I think if you're to build on this, what isn't as clear, and obviously this I imagine is a product of the fact that obviously you're on a journey with this technology, and you're really, as it were, pushing the parameters, you're familiarizing yourself with what you can do with this. But what isn't necessarily coming across is the transition in the landscape over time. Now, that might be because, of course, there are many different levels to this. We've got different scales. We can go in close, we can come out far. And, it might be that there is just a huge amount of data here. And so it's not necessarily at the moment showing that transition over time, and instead showing, if you like, the matter flow. But I'd maybe have a think about that. Certainly, I think creatively that is something that you could build on. And when taking the project to completion, actually think about, well, not just how do I show those flows in the landscape, but how do I use this technology to try and iterate how that landscape would actually physically change over time. And I think if you were able to do that, that is something that would attract a lot of attention, because that is one of the gaps, as it were, that isn't really being particularly well iterated at the moment. I mean, if we were to look, for example, at satellite imaging, what tends to happen there is that, the data is pulled down from the SATCOMs over a periodic time. However, often, obviously, the satellite fleet is passing by, and that data is then built up so that you've got what are effectively a series of images that can be, as it were, the dots can be joined, and so that those flow, but they're not operating with the level of sophistication that is possible with this. And so I would think about just how visually you might achieve that, because I think that if you could do that, that would be something that would really really have a lot of interest because of the fact that its applications would be quite wide. You know, there are lots of different communities of stakeholders that might use that. But generally speaking, I think, as I said, production-wise, this is a brilliant project. Stylistically, it is excellent work. And I think you've done a huge amount of, you know, really good quality work in the time that you've had.
Okay, thanks a lot for the input.
Hi there. Thank you very much, Thole, for sharing your work and research with us. Extremely interesting, and I'm very happy that this situation is pushing some of the boundaries of synthetic landscapes that we've had so far. Now, I have a few technical questions. I mean, given that it's fairly clear that it's extremely good work and aesthetically pleasing and so on, I have several technical questions. A is, where did you get your data from? I mean, like, we're basically talking about sort of disparate data sets. And I was wondering, did you import data sets purely from open source sources, or like the weather and geographic departments of your university, or where does it come from? Because I think the data, as well as the design or the space that you created, and also the navigation in there, as well as the behavior of the agents, is a construct. So the question is, what are the components, and in which kind of form do you interface them into that virtual environment?
So in the most cases, I'm using open source data, but for the basic levels, I've been using the satellite images combined with some theory data I found online.
Theory data? What do you mean by theory data?
For example, with the biomass, I've been told about the level of 180 tons. I found online some articles. I can add up the sources later on and maybe send them, and link the data I was extracting out of the images to the level of to this amount of data. So this would add up.
Yeah.
For example, when the biomass from 0 tons to 180 tons, I'm using scripts to line up this altogether, that the amounts would add up. Yeah, I do have a source document, but it's not completely filled, but I can add them up while the next presentations, in order for you to get the websites where I got most of the information from. But a big part is working with gradient-based grasshopper scripts and extracting data from images and different kinds of.
Okay, that's great. Thank you very much. I would be super happy to have a bit of a diagram or a list of these sort of things. I'm asking that question because I'm interested, of course, in how you did this, but secondly, it follows some sort of evolution of synthetic landscapes or data integration to understand what's going on. And you may know, I popped actually 2 recent papers in the chat, but you may also want to dig into the past a little bit. One of the first projects was by somebody called Lathrop and Hamburg. They looked at buffalo. And if you look at the primer by Michael Batty from 1997, you will find some information on how to also create like logic diagrams. So I'm extremely interested in understanding or in seeing the architecture of that project in a sort of logic diagram and data input diagram. So what's the input? How do you compute it? What are the kind of, what if relationships in order to understand a little bit the structure and where the behavior of the landscape agents comes from. So I find this extremely interesting work, and I think it's a first sort of suggestion to to a great field of research in architecture and data. So I think this is great, and I would like to push that. So thank you very much, Thole, for your work.
Thanks for the feedback. I will work a little more on my documentation, where I could maybe input some of the things we're talking about, and yeah, maybe we can get a better insight than just from this point. And
I mean, if I can just jump in quickly, I think
yes.
This is a really good point that Liz is making, and in a sense, like the waypoint you have created and the journey we made through the waypoint. It's almost already like a sort of spatial materialization of these diagrams, no? Because essentially we were following the kind of manipulation, if you want, of data and correlation of data from one set to the other. Maybe what it needs to be done is just, that at every waypoint there is a little diagram or a little window integrated in it that kind of describes in a kind of more specific terms, the kind of equation or the kind of extrapolation that is taking place at each step. So in a way, we kind of have this diagram embedded into the space, into the kind of journey that we are doing through the project. I think it will be really exciting, because essentially then you don't actually anymore have a separation between the logical architecture and the spatial one, but eventually we can perhaps experience the logical architecture of the project as a journey through this kind of synthetic landscape of yours, right?
I think these are really good points. Thanks, Liz, also for the paper. I was having a look at them, and I think congratulations on the project. I think what is very good, as it was pointed out, and is also very important for the Synthetic Landscape Lab, is in this case the development of an original visual language. That is always a key point for us. I think the next step will be really to try and understand how these parameters become operational, as Liz was pointing out as well. How is this becoming an instrument that allow us to work with planning or master planning or transformation or urban and landscape territory in a different manner. So that's probably something that at the moment still needs some refinement, although I think the project is really accomplished on other level, and especially on the visual language achievement. But still, how do we interact? What are the entry points is maybe something that need to be studied a little bit more, and try to understand how we can transform these in an operational tool.
If I can jump in on that. Thanks, Thole. I think the project is amazing. I'm a little bit bummed that I kept getting kicked out, but I'll try and enter later when there are maybe less people. And I think on an operational point of view, I think the project actually presents a huge opportunity, because, well, you've chosen the Amazon, but what you have is an opportunity to work with inaccessible landscapes, whether it be because you can't physically access them due to sort of the difficulties of the territory, or whether they be, for example, toxic landscapes. So we can't access them because they present a risk to sort of our person or ourselves as persons. And I think not only that, you present an accessibility or a possibility to access, but you present the possibility to design this post landscape, particularly when we're talking about maybe Chernobyl, where nature has taken over in some way. You offer the opportunity to sort of design this synthetic landscape, which becomes not just nature taking over, but in some way a controlled landscape that is even is enhanced in its performance through its control, through this synthetic aspect. And in this sense, I think it's a really exciting opportunity. It's a really exciting initial step. I think that, as Melissa said, for me, it would be really important to show the evolution over time. So you have kind of like the end image of what happens if your system sort of comes together. But when working with landscape, I think it's really important to sort of, time becomes a really essential factor. And I think another opportunity that would be interesting to think about is because of the fact that you offer this different perspective, or you offer the possibility to sort of visualize or, engage with a territory which is at a different scale with respect to our human scale, it might be interesting to also look at further connections. So beyond this landscape or beyond the deforestation, what is this deforestation connected to? And I say that because in the beginning, Marco was saying that you were looking at how the synthetic landscape can be used to characterize the urban sphere in some way. So it might be interesting to make a connection with the urban sphere through the consumption that is depleting to some extent this landscape, making maybe impact associations, which I think in a tool like this you could engage with, and look at how, we can design the synthetic landscape not only of this portion of the territory, but maybe its association with where it's being consumed to some extent. But congratulations, I think it's a really amazing development, particularly for the time that you've had available. So well done.
Thank you a lot.
Thank you very much for the comments. That's great to have the discussion, but we have much more cool stuff to see. So I propose to move to the next presentation of the theory course, and students who will present now, the Fidelius and Sabrina. Guys, I invite you to share your screen and start the presentation. We try to be sharper now. Sorry for timing. Okay. You have...
Yeah.
Yeah, we are there. So, hi, we're Fidelius and Sabrina, and we participated in the lecture for landscape. So from the synthetic landscape matrix, we have chosen the two keywords spot and contamination. And in the following presentation, we will take a closer look at them and start to build a connection towards synthetic landscapes. First of all, we would like to propose that contamination and BOT are not as separated as we think they are. Are they? So we would like to start with the keyword contamination. If you search for a definition of contamination, it is almost always the same. That contamination can be defined as a process of making something dirty or poisonous, or the state of containing unwanted or dangerous substances. Contamination has a quite negative image. Examples of contamination in that relation can be the coronavirus, plastic pile-ups, food contaminants, or environmental pollution. But we try to be more neutral and open-minded and looked at contamination from a more material view. So if you look at the general process of contamination, we define that contamination is the combination of a resource and a contaminant that can be natural or unnatural. The result is contamination. Examples for a resource could be air, water, soil, or even nutrition, and we discovered that the main components for each resource are over a longer period of time the same ones. This means that the resource can be described as a kind of constant. If we look at the contaminant, a contaminant can be from a chemical, physical, radiological, as well as from a biological origin and can connect to the resources. So the contaminant can appear in different conditions and can be described as a kind of variable. The variable has always a trigger that can be from a natural or a man-made origin. For example, the contaminant sulfur dioxide can come from a volcano or a lignite power plant, where the amount of human activity is often much more bigger. By looking at the example of air, the material process of contamination consists of the components of air and the component of the contaminant sulfur dioxide. The final result is a new substance ratio of air. The dimension of contamination is mostly not visible for the human eye. The human eye can only recognize objects with more than 20 microns, while the components of the contaminants are mostly smaller, like spores with a size of 0.3 to 30 microns. To sum up the meaning of contamination for us, the process of contamination is based on material intelligence, where two substances are automatically merged together. For the human eye, the process is mostly invisible. The process itself consists of a constant, a resource, to which a variable, a contaminant, is added. The variable always has a trigger that can be from a natural or a man-made origin. The final result is a new substance ratio.
So now we come to our second keyword, the bot. And if you search for a definition of a bot, you get something like this: a computer program that works automatically, especially one that searches for and finds information on the internet. And today, bots are often used in communication services, data scripting, chatting, and they can even play chess against us. So we asked us how a bot can be seen from a more technological view. So let's take a look into the history of a bot, starting with the humans as the very first machines. At the time, we developed our ideas with our brain and executed with our body. So the principle of all machines can be defined as a tool to make work easier for us. Therefore, the process of a bot can be described as a technological process between a mechanism, a material, and a manual process like a physical interaction, which together makes the machine. And the relationship between the mechanism and the mind moved on in time, making their appearance more complex and necessary. And at the beginning, machines were quite big, like the bomb machine by Alan Turing, which only had a minimum of the computing power of a modern PC. With the invention of the program Microsoft by Bill Gates, the process of a tool has shifted from the early beginnings in the real world, if you like to call it, into the digital world itself. So the general process of a bot consists of a program and a command, and both are man-made. And as time goes on, the bot always consists of a software, which is a database and an application for programming interface, which interacts with other programs. So we use the term constant as the fundament of the bot because it consists always of the same compounds. And in comparison, the command is written in a programming language to communicate with the bot. And the bot itself uses a specific code to then execute the commands. Here we use the term variable because it can differ from the language and the commands. So the technological process of the bot consists of the software, which can be a database and an application for programming interface, and the code, for example, a programming language to form a new composition of ratio. And if we now compare the scale of a human to a bot, the bot is almost incomparable to us in the way it functions, as well as in size by using microtechnology. So to sum up the process of a bot, it is based on digital intelligence, where two technologies are merged together. And here the scale is in no relation to the human eye. The process itself consists of a constant, like a program or software, to which a variable, for example, a command, is added. And then the variable has a trigger, which is man-made, and the final result will be a composition of ratio, a new composition of ratio. So in the next step, we have looked at parallels between contamination and the bot. And this diagram shows the conclusion of our first step. As mentioned, both processes consist of a constant, for example, a resource, a mechanism, or a program, and a variable, for example, a contaminant, a physical interaction, or a command. And this results in a new substance of ratio or a new composition of ratio. And here the variable always needs a natural or a man-made trigger. And at the end, both processes are based on a material and digital intelligence and are mostly invisible for the human eye.
In the next step, we want to look at our keywords contamination and bot in relation to synthetic landscapes. Bot and contamination are now to be considered by the Biosphere 2 project. Biosphere 2 is a building complex in Arizona from 1991 with the aim of creating a self-sustaining ecosystem independent of the outside world and to prove that life is possible in an artificial ecosystem in the long term. In relation to contamination, the Biosphere 2 has 5 self-organized biomes which interact with each other: the rainforest, the ocean, the marsh, the savanna, and the desert, which enable resistance to natural contamination by, for example, absorbing CO2, producing oxygen, and filtering water. The rainforest biome was created to simulate several tropical habitats of the rainforest. The ocean biome is intended to be a completely closed system and was designed to simulate a Caribbean reef, while the marsh consists of 2 large wetlands. The savanna biome was developed with the aim of creating a transition zone between the desert and the rainforest, and the desert was designed to simulate a dry ecosystem. Furthermore, a human habitat exists with an intensive agriculture. To sum it up, the process of contamination in the Biosphere 2 project consists of 5 biomes and natural contaminants like CO2, water pollutants, microbes in salts, and pesticides. Therefore, the final result is a kind of natural process. In relation to the BOT, here's a floor plan of the Biosphere 2 with details for the exhaust fan and the air intake filter to regulate the pressure balance inside the building. Furthermore, in order to integrate the technologies into the Biosphere 2, a so-called technosphere was built underground to house electrical wiring, plumbing, and mechanical system, among other things. Also, the artificial water cycle and nutrient enrichment was managed with the help of natural processes. The picture shows a leachate system which allows water to be collected and converted. The data acquisition and monitoring system is a computerized program designed to support maintenance schedules and to keep records of repairs and servicing with the help of artificial intelligence. To sum it up, the process of the BOT in the Biosphere 2 consists of a machine with construction plan and a technosphere, as well as a BOT with monitoring systems and data acquisition. The final result is a new combination of technological and digital systems. In the end, if we look at the process of contamination and BOT in relation to the Biosphere 2 project, it becomes clear that the natural process of contamination and the digital and technological system of the BOT helps us to create a combination of a natural and a man-made system in relation to synthetic landscapes.
So in the next step, we looked at current studies, and we have decided to take the article Cities as Biological Computers from 2016. And the aim here is to enable a co-evolution between the biosphere and our natural environment, and the urban sphere as a man-made infrastructure with the support of biotechnology. As an example, the slime mold is a kind of biological computer that has no brain but can leave traces in the environment. It is light sensitive, can communicate with its environment, it expands its network by growing, and it adjusts its morphology and energy output, and it can even learn new behaviors. So by understanding and applying this behavior, we can go from being consumers to creators. And by transferring this to cities, they could interact, leading to a new kind of relationship between the urban sphere and the biosphere. So here the Fusarium machine was used to study the behavior, morphology, and staining of the slime mold in a prototypic scenario. And in the next step, we have looked at the case study Wetware Barcelona, and they used the characteristic of the slime mold to find the shortest way to reach its nutritions. Later, they have transferred this to an urban dimension. On the right side, we can see the site along the eastern coast of Barcelona with an area of 3 by 3 kilometers. By using the shortest route, the network extends further towards the ocean and treats the entire area as a single ecology. And Barcelona is giving a new appearance that exists independently of the existing infrastructure and is driven by vegetation and organic growth. However, the organic network does not fit in with the existing urban structure. But to create a new system for the future, how human and non-human ecologies must be linked together. So in the end, we can say that the slime mold is a natural system with the behavior of a bot, which is demonstrated by the project Wetware Barcelona. So as a summary of our keywords, contamination and bot, it becomes clear that the general process of contamination as a material process and the bot as a digital process have similar structures. And in relation to synthetic landscapes, one used to have the contamination and the bot as a joint process from the natural system of contamination, and they complement by digital and technological systems. But nowadays and in the future, the biological process and the bot could be seen like a single process consisting of natural systems with the behavior of a bot, creating a co-evolution between the urban and the biosphere. So to answer our initial question, if contamination and bot are separated or not, it must be answered with no. So yeah, thank you.
If I can kick this off, it's an interesting study. I think you have made some good progress. You've looked at some good case studies. one thing that's missing, one thing that's very conspicuous by its absence, is the fact that obviously the Biosphere 2 project was created with the intention of being a closed system. The idea being that humanity, as it were, the scientists working at the site could control that environment by raising and lowering things like the oxygen levels or the humidity and so forth. But of course, it didn't work like that, in the sense that a disruptive agent got into this closed system. And when you read in depth about the Biosphere 2 project, one of the biggest challenges was the fact that they realized that in fact, it wasn't actually a closed system. So for example, in one of the biomes, ants got in and they became the disruptive agent that, if you like, upended the expectations of what would happen in that system. And when you think about computer software, when you think about things like obviously Microsoft and Apple OS and so forth, that was obviously originally designed with the intent, the expectation that it would be a closed system. But then of course what happened, and if you like, the biggest issue of contention in all technology, the biggest risk by far, is that disruptive agent, which of course comes in, among other forms, bots. And so what I felt in your project as I watched your various case studies is that you didn't explore that disruption to the system. There was no interrogation of, well, what actually happens when, if you like, you design the program, be that program analog, as in the case of Biosphere 2, or software, and then something comes in, something disrupts it. And certainly from a systems point of view, which of course is what the landscape is all about, is one of the most critical issues. And it's certainly one of the richest issues. And I think if you look at that issue, if you don't just look at, the issues of the sort of the top level analogy of, well, how might natural system components compare to man-made ones, and you actually look at some of the system disruptors, you might actually reach some more fertile ground, because obviously your aim in this is to discover something that is new, that is insightful, that is going to really add to, as it were, the sum of everything created to date. And that's not really there at the moment. But certainly, I think if you look to the system disruptors, if you go back to the Biosphere 2 study, if you read about why it went wrong, if you look to other case studies that show why other closed system environments also went wrong. In fact, Eden Project have also had some issues that, again, were not expected. Look at that, read it, think about it, then think about the software, because at the moment, that's the dynamic that is missing from this case study. And I think it could be very interesting and useful to examine that territory.
Mm-hmm. Okay.
Yeah.
Hello, Fidelius and Sabrina. Thank you very much for sharing your research and your question in a way of how to combine these things. Would you mind going back a few slides so that we have some content on the screen rather than thank you? Yeah, this is good. This is great. Now, I have a few critical questions which have to do with the methodology of how you work and also the relevance of literature in your work and bibliography. To me, it's absolutely unclear where you got your knowledge from, mainly because there hasn't been a lot of mention of the literature or references that you have used in scientific research that has to do with the work that you're doing. Another thing that puzzles me a little bit is that you're talking about biological processes and natural systems. So I think there would need to be clear definitions of what you mean or where you get the definitions from. If you, for instance, look into a book by Patrick Gaddis from the beginning of the 20th century, he was a biologist who was invited to designed the urban plan for Tel Aviv in the 1920s. He is widely, intensively discussing the difference or the commonalities between biology and ecology. So I think it's to understand where you're coming from and where you want to go. It is very important, at least for me, it would be extremely important to have clear references, like how do you understand biology and where does it come from? Same with ecology. What is a system for you, and how do you define a closed system in juxtaposition to an open system? So these are all terms that have been discussed in different varieties and different disciplines, from architecture to anthropology, from economy to the social sciences, politics, and so on. And to embed your work, it would be great if you could share where the work was basically born through and bred onto. That's kind of my comment to understand the work a little bit better. In general, I think the question that you've been asking yourself is great, and I think it's extremely relevant, especially in conjunction or in combination with the synthetic landscape design studio that we're also looking at here, and it's a great underpinning of the work. So I just wanted to advise you to be a little bit more critical in terms of where do you reference your thoughts to. And a direct question, could you repeat what is your hypothesis? Like, what is the question that you asked in the beginning, including the hypothesis, and what is kind of the result or the question that you ask at the end of your research study, of your theoretical investigation?
Yeah, so I hope I understand it right, but at first we ask ourselves, like, what is contamination and what is BOT? And so we try to be like more separated in the beginning, and then we ask, like, where are like similarities? And first of all, I would say that contamination and BOT has nothing in common, because it's kind of obvious, because contamination is a natural process, like it happens in nature, and the BOT is like more a man-made system. So if I understood it clearly, like we would say at first, contamination and BOT has nothing in common. And then we would say at the end that this is not right, because they have something in common, obviously.
Yeah, so we try to examine it in the first process, like the general process, as you can see on the screen. And as we look into the different keywords, and we try to prove that they are not as separated, or they have like some processes that they are similar to. So that's what we're doing in the first step. And the second one, we try to bring both processes together and examine it on synthetic landscape on the project Biosphere 2 and the slime mold project. So yeah, that's
I find this difficult because, like, contamination, of course, is also a technological system. And the question here, sure, is who is looking at a certain process as basically valuing it as, or analyzing it as contamination. Like if you take, like, for instance, this thing that is at the moment sort of, you know, stopping the world, like the coronavirus, as humans, we would say, well, of course it's contaminating us. But, you know, the virus doesn't see it the same way. So it depends on the point of view, like, and so where in the system are you standing here? And I think this is something that you could very well underpin with definitions that you actually get from proper scientific readings, right? So I would like to push your work a little bit into a more kind of, let's say, even almost orthodox sort of scientific methodology, rather than narrating and assuming and so on. So I'm just looking at this from that point of view, because you will have to do this in your theoretical writings or in your master thesis. It's necessary. to do this. So I just encourage you, and because it's exciting, you know, what you're doing here.
Maybe to answer that, we've looked at the slime mold in like a contamination process, because contaminated like the dead wood, and it transfers this into normal substrate again. And that's like a contamination for us, but it's a contamination in a good sense. So, yeah.
I think, you know, just if I just jump in 1 second, because I mean, I really actually appreciate the conversation, guys, you brought forward. And, you know, I completely understand some of the comments you're receiving. Although, I mean, to be honest, I think we also need to see this work in a context of, you know, a very short theory course that is a kind of a, let's say, supportive of the design studios rather than, let's say, a PhD dissertation or something similar. So, I mean, we are at a different level. And, you know, obviously, but I think they are all very good advice, because even, you know, even when you're doing a short piece of research of this kind, is always good to, you know, to try to be, you know, as thorough as possible in terms of, you know, declaring your, you know, your references and your inspirations, and where the actual the terminology you use, you know, define it very clearly. But, you know, from my perspective, and at a simple level, I think that is, you know, first of all, it's very good that you took two terms, which, again, you know, I think they are used very often in design studios around the world, and you know, very often are used very superficially, and also with a very clear biases, in a very clear connotations to them, or what is good, what is bad, what is you know, and I think that you know, with this process, my understanding what you try to do was to just enlarge the perspective, begin to show that actually there is another way in which we can begin to engage these definitions. And like Liz was pointing out, you know, it's a perspective that, you know, becomes very obvious when you look at it from the point of view of a virus, or maybe of a you know, cyanobacteria, or, you know, another type of organism that actually make use of what we call contaminants or pollution as a form of nutrients, right? So, I mean, in a sense, I think you're doing that, and at the same time, you are trying to, I believe, connect certain, let's say, world or theory of digital systems that you guys are using as part of your tool set to the understanding of contamination and pollution as such, right? So for me, that's the key of the work. And maybe one of my critique is that maybe the presentation was too long in a sense, and maybe even the case studies were almost too much and too different from each other. Like, for instance, slime mold and biosphere 2. Yes, I can see the point, but at the same time, maybe it's even too much. And maybe, like, you know, the comments were pointing out very clearly, like, you know, even the biosphere 2 had already so much to it, and you know, so many kind of contradictions within itself that, you know, you could have sort of unpacked, and maybe they have, you know, they could bring extra edge, you know, to the study that you have done. But, you know, overall, I think it's in my mind, I think it's a very good piece of work and you know, which does what is supposed to do. But, you know, at the same time, I think, you know, take the comments very, very seriously, because it's really the beginning of a journey. And you guys, I think you certainly have the capacities to think and design together. And I think that will be more and more obvious in your future projects, thesis project, maybe even PhD. I don't know if you would ever want to engage into that, but, you know, it's you know, definitely, I think we are building the foundations for that here. So I think it's good to do it right from day one, right? So, but, you know, for me, it's a good piece of work, and you know, I would congratulate for that.
Thank you very much, guys. Thank you very much, everyone, for the comments. I propose to move on to the next presentation.
Okay.
Yes, we will move on. Fidelius and Sabrina, you also read the comment from Elisa in the chat. She leave you a very nice comment also on your presentation. So anyway, we're running out of time, so I invite the students who have...
Maybe Matilda had a quick comment. Matilda, you want to...
Yeah, I just had a super... Hi, I'm still here. A super quick comment. I thought it was actually your proposal was really interesting from a methodological point of view. I really enjoyed how you attempted to sort of like apply the approach of a scientific experiment to a theory process, identifying a constant and a variable to be able to break down your process. So I think one of the things that for me was maybe interesting to look at, or that you could add in, and Melissa actually spoke about this, was the factor of control. So, you know, we have a constant and a variable, and we try and understand our relationship to control. And I guess in relationship to contamination and BOT, in some way we could look at the contamination process as a loss of control, and the BOT as something that would attempt to multiply control. So, you know, on one side, it might be interesting to reflect on what happens if the BOT is contaminated, but also as the BOT as a tool to unpack the behavior of the contamination, or as the contamination a tool to design the behavior of the BOT to some extent. So I think that there's an interesting sort of perspective that could come out of a reflection, a parallel reflection in relationship to control, or maybe in relationship to what our bottom-up or top-down process is. And I would invite you, and in the framework of the course also, to then try and relate all of your work back to the concept of synthetic landscape, which I think is important for you guys, but for the group as a whole. So thanks very much.
Yeah, I agree on Matilda's comment briefly, and I think one suggestion for the future is also to try each of the students work on a specific keyword, and some students have been relating their keyword, but it would be nice to see the overall matrix and how these keywords relate to each other and start to create a definition of synthetic landscape. So not only working in isolation of one or two keywords, but really see the overall. I think it will be a good next step. So for the morning, we still have one pre-diploma and one bachelor group to see. And then, so let's start for the pre-diploma. Kilian, please.
Kilian, sorry, we cannot hear you. You are muted, so you need to begin. Start from the beginning. Unmute yourself.
Okay.
Yep. Perfect.
So now you can hear me?
Yes.
Yes, okay. So my project for the pre-diploma is mostly about the implementation of an architectural system of an intelligent mycelium microfiltration in Kamchatka. Kamchatka is a peninsula located in the southeast of Russia, and it has a very unique landscape and flora and fauna, as you can see in this picture. This picture displays a location close to my later site. It's the Achabachi Lake, and in the background you can see the Soviet volcano. And this really beautiful landscape has to be protected. So I decided to switch my site there. Because there are a lot of problems by environmental disasters in the later years. There was a huge disaster in September 2020, where nearly all sea life was killed in a depth about 10 to 15 meters along the east coast of Kamchatka. And so it was a really huge disaster. And it was mainly caused by the climate change, but also a huge impact on these disasters are this man-made pollution in Kamchatka, mainly caused by the huge military testing areas and areals and the military industry there. And so I want to deal with this problem with implementing a microfiltration system of mycelium there. Mycelium can act as a sort of cleaning system and the intelligent network to clean up the environment and the man-made pollution there. So mainly want to integrate this system into the areas of marshlands and river branches that are temporarily flooded and sometimes not flooded because most of the pollution is deposited there. So to display you this progress and how it should work in the end, I had this sort of timeline. At first, there is the start of growth of the mycelium. It needs certain conditions, such as the habitat, based on substrate, humidity, and other factors like temperature and the vegetation around. For my project, I choose the oyster mushroom and also the hedgehog mushroom. Yes, and on the second phase, there will be a phase I call the characterization. Mycelium is building an intelligent network in this phase, and it's formatting a transmission structure between the fruit bodies, and it's working by communication by electronical impulses. This part will function in my project in a sort of frame structure basing on like a piping structure that is extruded. The next phase is the phase of detection. The detection is really important. The fruit bodies are working as something like a recording network, and they detect these toxical substances from the military production and tests there in Kamchatka along these rivers. On the fourth phase, there is mainly the extraction process and the real microfiltration process, where the mycelium is starting to affect these natural systems by cleaning up and absorbing some of these toxical substances. And on the fifth phase, there is mainly the recycling process, where it will get back to the start of the project and ending up in biomass that could work as substrate for a new growth process. So to get a proof that mycelium is really can be connected in this intelligent way and is communicating by these voltage peaks, I had a look on a reference study from Andrea Damatsky and Phil Ayers. It's called Fungal Architecture, and he is recording the electronical activity in mycelium exoskeleton there. You can see it here. It's recording in 5 pairs of electrodes, and he treated it with heat from a lighter that you can see mycelium reacted by a voltage peak, as you can see here, by the treatment of heat. So the aim of this study was mainly to find out if you can functionalize a fungal substrate and grow with it a real architecture project in a monolithic way. So for my project, I did some adaptations on these experiment works, and I started to record the activity of mycelium when you treat it with certain chemical simulations and substances. Yes, so on the first, you can see my experiment setup for the first experiment. It's basing on 3 pairs of electrodes that are set up in this mycelial block, and a data logger from ECOLog, it's called. And there are some medical needles inside the mycelium measuring the voltage activity inside there. So, and on the other hand side, you can see which kind of substances I added and the way I added them. Sometimes I injected them, but also I just dropped them on the surface of the mycelium. Since it's really difficult to obtain the real substances of this military pollution, I used substances that could have a similar input to the environment as these. I used heat from a lighter as a reference compared to the Damatsky experiment, and also water as a reference, and then white spirit as a petroleum product that is really also a problem in Kamchatka, and copper sulfate, hydrogen peroxide, and also battery acid to treat the mycelium with these toxical substances. So this one, you can see my first experiment. You can see the voltage peaks caused by the lighter at first, and the next step with the white spirit, and on the third step, there's a really huge implement and impulse on the voltage graph. It's caused by the battery acid, and it goes up to 70,000 microvolt. So it really proves that mycelium is reacting by electronical spikes to certain circumstances and to the triggering with toxical substances. So on the next step, I had a look inside these process in different channels. So I added 3 pairs of electrodes inside the mycelium and again triggered it with it. And I got a really interesting result because there's really a difference between the natural voltaic spike marked here in green and the artificially arranged voltaic spikes with these toxical substances arranged by me. If you add some artificial toxical substances on each channel of the graph, there is some kind of electronical impulse. If there is a natural peak, it's just on one channel. So this is really a difference that could in the end create some sort of data set. And the next interesting point in this graph is when I add copper sulfate to the channel 1 in the blue curve, it's getting a longer voltage increase. It's mainly caused by the higher conductivity caused by this copper sulfate. That could be also a point to functionalize the substrate of mycelium through this. So on the next step, I did something like a zoom in, and it shows the injection on each point and on each channel. I injected it in channel 1, and you can see there's a huge influence to this channel, but there is also influence to the other channels in this part. So there's really a communication between the mycelium, as you can see here. There some distance between the channels, so there's really a communication between these fruit bodies. And you can differ this process into about 4 phases. In phase 1, there's just a small negative impulse. It's called the phase of detection, I would say. And on the next one, there is a huge positive impulse, mainly on the point where I injected the toxical substance. And on the third phase, there's this reaction phase where there are several negative and positive voltage peaks and spikes. And on the fourth phase, there's mainly the process of normalization again.
Kilian, I need to speed you up a bit because I know that you have still a lot of information.
Yes, so you can differ this into different phases, and it's important for me that I want to create from this data set achieved with these experiments a logic how the mycelium can grow onto my site and how it can detect these toxical substances, and on the next step absorb it and go on with the process of microfiltration. To get a closer look to the site, I decided to have a look on Kamchatka and where the pollution is that high that it is needed to get something like this system to implement it there. I decided to go on these 2 sites. There are nearly some large military stations there, and I had a closer look inside them. At first, I had a look to the first site and I analyzed conditions for mycelium growing there, but they're not really ideal. I analyzed it mainly basing on the factors of slope and also about the factor of humidity. You can see it in this mapping. So, but I wanted really to achieve it more, my system more on marshlands and also swamp areas that are temporarily flooded and not everywhere flooded. So I go on to another location and analyzed more the sea level rising, because the sea level rising is really important for this process of depositing toxical substances on the land, because when the sea level is rising, it's flooding the land. And if it goes back again, the toxical substance will stay on these temporary flooded lands. So I analyzed it, how it will go on with this sea level flooding and how Kamchatka could look like if it's temporarily flooded in the future. So depending on these results, I zoomed in my final area. I would say it's located in the southeast of Kamchatka, and it's really near to the largest military base there. And in this mapping, you can see where there's the most pollution around this area on the green gradient. And the most pollution is mainly in this marshes area here, and also around the Asabache Lake, as I showed you in the image before, that is located here, and in the bay around the sea there. So around these marshes, I want to have a closer look inside there because there's a huge spawning area for salmons. And this one is really important for the ecosystem of Kamchatka, that this spawning of the salmons is working previously. So in my opinion, it's really worth to protect this area because there's a large ecosystem and a really interesting and beautiful landscape there. So I zoomed in and got a look on the elevation there to have a clearer imagination of the area and how it looks like. And you can see really clearly the building of these small basins around the Kamchatka River and these marshes down there. So on the next step, I had a more closer look on these different surface structures around my site to understand the area better and to also get a closer look how the diversity of the area is and how the topography acts. So you can see here this furrowed mountain landscape on the one hand side, and on the other hand side, these river branches and this marshes area down there. So on the next step, I really wanted to start my design process and implement artificial structure there. For this, you can see here is the current situation. And during the next years, they will get some sort of basin stir caused by erosion and by the rising sea level. So I started with these basins and analyzing the conditions of mycelium growing there, depending on the relative slope to the surface, the humidity, and also the vegetation that are really important to grow mycelium there. And depending on these results and the points I get from there, I implemented a proximity line network there. And you can see it down there with adding the water areas. And also here's a reconstruction of this network based on the density. So in this one, you can see more clearly the part of the process of my mapping process and how this structure displayed here is starting to grow there. So this one should be a first diagram of a structure implement there, which should be a starting structure for the mycelium that can start there to grow. And from there on, it can spread by this logic I will implement by the data sets of the experiments, can spread into the polluted areas and clean them up. So on this mapping, you can see mainly where the pollution areas are, and you can see also the structure, and it's really arranged around these polluted areas, and so it's an ideal structure where the grow process of the microfiltration process of the mycelium can start. As additional function, I want to add a habitat for engaged species there, because the structure with its morphology could be an ideal structure for the Kamchatka species there, such as the salamanders. It could be very important for the spawning of the salamanders, so they could find a new habitat there, because a lot of their habitats are destroyed by these pollution of the environment. So my project could also be a sort of artificial habitat for Kamchatka's most famous animals, such as the salmon and also the Kamchatka beer that is caused by them. In this mapping, you can see the suitable areas for the animals and also suitable areas for later measuring stations that could measure these influences from the mycelium on the environment and these electronical impulses. So I want to show this process a bit more clearer on this diagram. It shows how these functions will be linked. At a space structure, there will be...
Kilian, try to conclude, because we would like also to have some comments on the project,
okay.
Particularly for you, that you still have some to work on it.
So we'll go faster. It's nearly over. So as base structure, there will be some sort of artificial pipe structure, and it can work on the one hand side as a wildlife habitat, and on the other hand side, it should be the starting structure for this mycelium microfiltration process that will be implemented laterwards. You can see in this diagram where there should be this artificial structure in white, and on the other hand side, the natural vegetation in the green gradient, and also the water areas in blue. Okay. Sorry, it's a bit. Okay. Yes, so I zoomed in a bit more to display how this structure will act on this site near the Azabachi Lake, and where there are the suitable areas for the animals, and also the suitable areas for these measurement stations for the connection and for the growing process of the mycelium again. So in this one, you can see a first preview of how this structure could look like on the site and in the landscape. And also here is the first preview of this morphology, how the structure could look like, the starting structure, but it's not really a final product yet. It should be more, or my brief is more about this implementation of an intelligent network by the mycelium and how it could grow and start this microfiltration process. Okay, so that's it.
Thank you, thank you. We can open to the comments. Before the comments, I just wanted to clarify that Kilian is a pre-diploma proposal. So in this case, he's proposing a brief and drawing that set up his thesis that he will develop in the next 6 months. So he still works to do, so comments in this direction are welcome. Thank you.
I'll kick off. I thought it was an excellent presentation. I thought, well, I think that you've taken a really important problem. You're exploring a very promising solution to that problem. Your research was wide, but it was deep. You very elegantly integrated that information coming from the various different strands, the various different disciplines. Your graphics, your iteration of the ecological transition of what you're proposing are very, very strong. They look beautiful. And generally, I think this is a very promising project. I think there really are no obvious flaws from my perspective. And I think that, you know, you've clearly put a huge amount of work into it. So it's, you know, it's exceptional that you've reached this stage, I think, you know, at this time.
So thank you for this comment. Yes, there's really a huge work left, but I think it goes in the right direction for now.
Thank you, Kilian, for sharing your first steps in your master thesis. I totally agree. It's been a great achievement in that relatively short time, and it seems as if you are fairly focused and have your objectives set out here. Now, I would like to suggest. Of course, you know this probably. I mean, just look at it in different scales. So what is the scale that you have at this moment in time? We all can imagine that it is a very large region. So just make clear how big that space actually is. So the current network that you're showing, or the first sketches that you're showing along the lake or around these areas at the moment are a little bit very undefined, let's say that, in size. But of course, we all know that it's a large area. So I think the matter of scale is very important, especially in the projects that do include, or actually use behavior of natural inspired or bio-inspired systems as a generator of morphology, form, and three-dimensional space, or evolutionary space, let's say that. So I think that's extremely relevant. The other thing is from a technical or technological point of view, there are, as you know, a number of people out there who are looking at mycelium from various perspectives. since you are incredibly interested in the filtration function, which seems to be one of the functions with a higher weight rather than, you know, structural or insulation properties of the material, reach out to these people. I mean, reach out to these people who are possibly even working in combination of filtration and architecture, so that you have already an interdisciplinary contact point. And I'm going to put in the chat, in the Zoom chat in a minute, I'm going to put a name and an email address, which I'm trying to find for you, of a professor who's been working with that. She's back in Austria, in fact. What's her name? Claudia, you probably know her as well. I'm going to put that in the chat, and then you might be able to contact her. Because the thesis, I mean, you have two different strands, right? I mean, one is the technological aspect, which you want to get across. And one is, of course, the idea of creating new typologies and new morphologies and a new architectural language. And I think that has come, that's been very clear in your presentation. And I'm very much looking forward to how you continue and the next step. So 6 months is in fact a lot of time, you know, yes, given that you had an excellent start, let's say that. And that's the only thing you're doing, right? I mean, you don't have any other classes, courses, and so on.
Yeah, it's nearly the only thing.
Fantastic, fantastic. Yeah. Yes, so that's great to hear. Yeah, congratulations for an excellent start, and looking forward to the next steps. Thank you very much, Kilian.
Thank you, and really thanks for this input. I would really suggest to contact this one.
Yeah, I think this is a very good suggestion. Actually, working virtually maybe has facilitated contact with people internationally, but not with people local, with researchers locally. And in the Department of Biology at the University of Innsbruck, there is a quite large research on mycelium and fungi related to the territory of the Alps, and also specific breed that grow locally. So I think it's really important to start to create a connection to make that more specific also locally, because of course myceliums are one of the species that constitute the landscape of the Alps, and there are species that are locals there that can be studied, or there can be suggestion for your site as well from this researcher.
Okay, yes, it would be really interesting to get in contact with these researchers.
If I can jump in 1 second, I just wanted to add quickly, I mean, to obviously, you know, very, very encouraging start. I think the piece of research on the mycelium itself, it's one of the most convincing I've seen so far in terms of design studios, and, you know, especially your approach is very original in terms of these signals transmissions and communication. I think is something that goes beyond what we normally see. So I think that's really, really good. And I think you should really make sure you don't lose that kind of focus, maybe even try to diagram even better, you know, how this process may occur within your block, no? You know, again, part of that is based on scientific evidence, but could also be based on your own ability to draw it, and, you know, your choice of drawing and diagramming techniques. But I think that's really kind of a, in a way, fascinating bit of research, which I think you can definitely still continue to unpack while keeping it very focused on its originality. On the other end, you know, the larger scale, I think you have done your, let's say, what we now expect to be a kind of due diligence process in the lab, you know, these beautiful maps and drawings, you know, they're great. But I think right now you really have the chance to do a step further there, you know, and I think before you dive into some kind of shapes and stuff that you know, that I think may become a little bit your weak point if they end up replicating, you know, this kind of three-dimensional network, which we have seen already several times. I think there is a, you know, what I would say a kind of a ecological and you know, and political dimension to this territory, which is quite obvious. You showed at the beginning the image of this you know, Greenpeace activist. You talked about you know, contamination due to military activity, I would imagine, I mean, the area is not completely desolated and wild, that there must be, you know, living communities in those areas as well, which are confronted with this. I think you need to kind of, I mean, you have a chance here to bring that dimension, you know, much more to the forefront in a sense. And I suspect that whether at the end your project is going to be, you know, a kind of almost invisible protocol of injection of you know, of a mycelium at a kind of territorial scale, and, you know, or a much more, let's say, deliberately visible impact or kind of landmark on the landscape. I mean, that will, I think, depend very much from your response to this kind of, you know, geopolitical context, I would imagine. And, you know, and I think that's, and also to the social reality of the communities in and around your site of choice. So I think, yeah, there's no answer to that. I think you kind of unpack these layers much more, and you show your, let's say, emotional reaction to this, like as a designer, no? Like, I think then you could probably have this, you know, really powerful combination of, you know, a really strong, you know, research and a really genuine, you know, reaction. And you know, I think that would could bring the project to you know, to the next level, and possibly to be, you know, one of the best. So I think that's what I would encourage you to focus on in the next few weeks.
Yeah, I would also, sorry, Kilian, for interrupting. I would just want to join the comments, also complement your presentation and the whole development. I absolutely agree with the fact that it's very individual work. And I absolutely agree with Marco that I think from the research that we see on the mycelium, I really find it the most relevant, the most fresh and interesting from my side. I just wanted to give a short comment that I think we were discussing this before with you. I think this project is not yet about even the animals, the salmon, the bears, or the human. I think it's about maybe the soil, about the pollutants, no? And it's about the contaminant that you have in the soil and in the water there. And I would stay first in this idea when you're developing this mapping, and it's also about the question about the scale, no? I would think first about the contaminants in the soil and work on that in that scale. And I would scale up to the all other habitats, local habitats of this very specific locality later on, and really think how this distributed network of the biosensors that you're introducing could change the way they live there, how you could improve, for example, the ecological situation there, and how this would affect the local communities who are living there, and the animals and the whole habitat which is there. And I think it's a different part of the project that I hope that we come to. But I wouldn't say now that this for trying to create some kind of, I don't know, habitat research or research center or any kind of physical structure which is providing shelter for anybody. So I think that's a bit simplifies that at this moment, but but project is very beautiful. Thank you.
I just interject there. If you are going to look at how you develop this as, if you like, an interface between the biosensors, the ecological intelligence, and the human, the man-made, so, smart systems data, that is an area that a number of the major technological companies, tech companies have been researching over the last several years. They haven't actually published a lot of this work. The company that has published the most is Microsoft, which have been very prolific in this area. You can find, I've actually got a chapter in my thesis which has actually documented every project of significance that was published to 2018. There's actually a report that I've co-authored this last year, which also, that comes out hopefully this month, if not early next. And that also documents some of the developments in terms of how you translate that biological information. So for example, how you can actually capture the signals that are being released by the mycorrhizal, the fungal networks, the electronic signals, and how you can actually map that into the sort of smart city data sets that then inform the landscape scale interventions. So for example, the sort of things that are currently being explored for this are things like, ecotoxicology, toxicology more generally, and across many, many classes, both biological and chemical, of pollutants and contaminants. So there's quite a big research field, but it's quite distributed. Not all of it is out there, but if you do go that route, then certainly do draw on that, because what that area is missing is not, if you like, actually understanding the sort of the tech aspect of it. It's not actually working out how you actually monitor the biological sensors, and how you sort of program that, but it's actually more, well, what interventions does that then trigger? What are you actually going to do with that information? So if you do go that route, I'll put I'll put a link in the chat, but I will also, if you'd like to see the report when it comes out, that's actually on nano scale pollution of waterways, of freshwater waterways and of oceans, then I can actually send that to you so you can just have a look, because there you will see the companies that at the moment are, if you like, leading that process. And so you can use their work as a bit of a benchmark. And there are also some links to papers that would be useful for you to read.
Yes, it would be really great if you send it to me. I think it's a great input. Thank you for this. So.
Okay, thank you very much, everybody, for the comment. So if we move to the next presentation, we're moving to the bachelor presentation, bachelor studio. Max and Mikhail, we would like to invite you to present.
Thanks.
Hello.
I hope everyone can see my screen right now and it works.
Yeah, go to the full screen.
Yeah.
Perfect.
So, as Anna-Rita introduced at the beginning, we are in Design 1 Studio, ForestHUTS, and our task was to create a ForestHUTS in the Burggrain of Tower. Our project is called ECOlogical Emotion, short ECOmotion, because we used ecological and emotional data to create these ForestHUTS. In terms of workflow, all started by analyzing the site of the ruin of Tower. We did several different analyses. At first, we analyzed our emotional conditions by a technology called GSR. We did emotive mapping, and we analyzed the inclination of the terrain and to come to the location and the sizing of our ForestHUTS. On the other hand, we had a look at a specific plant, the large-leaved willow, who grows on site. We did a biological research, 3D scanned the plant by photogrammetry, did an algorithmic analysis of its structure to get to the final structure of our ForestHUT, of our final design. Here you can see the ruin of Tower, the area where we placed, or where our project is placed. And yeah, to come to the method of the GSR. GSR stands for galvanic skin response, and it's a method of measuring the electrical conductance of the skin. Strong emotion can cause stimulus to your sympathetic nervous system, resulting more sweat being secreted by your sweat glands. And GSR allows you to spot such strong emotions by simply attaching two electrode on two of your fingers. And the outcome can be several emotive data. In our case, emotive data mapping, including the GPS data of the site.
Okay, attached with those GSR sensors to our fingers, we approached the site and walked around, also while documenting what we actually encountered on the site. Here you can see the floor plan. We walked the route, and the red spots, or as red, we had a strong response, and we checked them with what we have encountered on the site. Most notable are the ones where we actually had a really nice view from the ruin into the valley. And also really important were the times when we engaged with other people that were also present on the site. In total, we did 6 walks. And in the end, we overlaid all the data together in one big point cloud that combines all the data from all the different walks. And then we used an algorithm to analyze where actually the most, where the hotspots are, where we actually had the most responses, and check this with our documentation, what we actually encountered at these given spots. And you can see most of the spots were about meeting people, and 2 spots are about the view. And also something that was interesting there in the top right, we had a structure that was, we found it interesting how the plants, the vegetations overgrew the ruin. We also analyzed the inclination of the terrain, which we will come back later.
To go further on, by looking at a specific plant we choose, the large-leaved willow we found on site. We did a biological research on the plant in terms of its appearance, how the leaves and branches are formed, how are they shaped, what are they colored, and so on. We also analyzed the plants in terms of its sexes, that it has female and male individuals, in terms of pollination, that is pollinated by bees and other nectar collecting insects, and that the plant has a really early blooming period. And we also watched at the distribution in Austria. You can see in the map that it's mostly in Tyrol, and the flowering period also. But we mostly focused on the growth pattern, on the structure of the plant, and for that we used a method called photogrammetry. You see here that we explored the ruin, the Burgruin of Tower. It was our site. We chose the large-leaved willow as our specific plant, did a reality capture by a photo sequence of the plant, and used that for a photogrammetry to get to a 3D scan. And out of that, we produced a 3D model by a point cloud. we overlaid the point cloud by different types of algorithm to recreate the plant structure you can see in that image. We also did several types of variation to get more known about the structure of the plants and more detailed analyzing. By watching at, or by looking at its growth pattern, we created an algorithm for our plant who should create the structure of our ForestHUTS.
With the structure of the plant in mind, we tried to develop an algorithm that mimics the growth pattern of the willow, which finally resulted in the final structure. Yeah, next. So, as I previously mentioned, we had those 6 hotspots where we had the highest GSR output, and we populated each of these hotspots with one given structure that tries to facilitate what caused the high emotional output in the first place. Also, you see combined this network of possible walkways that are generated by an algorithm using the inclination of the terrain as an input. And yeah, we will want to show you one structure more in detail. Yeah, next please. Yeah, so this is the structure 1. It tries to facilitate the view of the valley as also as a meeting or gather place for people. This is achieved by having, well, one outpost like structure in the front, and in the bigger back part, the willow structure is morphing into benches, which should facilitate encourage people to meet and sit down. Yeah, here you can see it as in the section. Yeah, and here and other here some perspective views from other structures to give a little impression.
You can see a close-up how the structure behaves and how the willow forms the primary structure and goes on and flows over to the secondary structure, building the hull of the ForestHUT. Some other perspective views where you can see the different huts we also created. Thanks.
Max, maybe you can leave the last image on.
Of course, yeah.
Thank you, guys. I would invite everyone to comment.
Shall I jump in?
Yeah.
Hey guys, well done. I kind of, it was a long time that I was waiting for somebody to try and draw trees and plants in a kind of interesting way, right? I mean, I think there has been like for too long this kind of contraposition between like plants and trees being this kind of symbol of regreening and nature, taking back our cities and so on. And I like the fact that you're kind of doing the opposite in a way. You are sort of digitizing plants and turn them into completely kind of mathematical constructs and geometrical logics kind of embodied into this point cloud. But also at some point you kind of completely redescribe the branching system through your fibrous logic. Very beautiful and interesting. Of course, this has a kind of big impact in the way then you have, you know, materialized your huts, and I think that's again, I like it. I think it's convincing. The part that I was a little bit disappointed is in these final images, the representation of the ground, of the landscape, of the soil itself. It kind of looks a bit conventional, whereas at the beginning you showed that you actually did a whole 3D scan, or at least you had this point cloud representation of it. And I wonder whether there is a way in which you could, you know, push this exercise in representation to the point of redescribing, let's say, the intersection between your huts and the ground, or the way your huts eventually may continue in the ground with some kind of rooting system or foundation system, if we talk about them as architectures, that you know, not only you know, ground them statically, but it also perhaps enabled them to continue their engagement with the territory, you know, through the layers of the ground itself, and therefore also being able to exchange with these layers in a kind of productive way, you know. And I think that's very much an opportunity that you have created for yourself, which it would be worthwhile exploring a little further, because I think you have all the ingredients to do that, and in a way it will open up intriguing conversations in terms of you know, how essentially this kind of liminal zone, let's say, between the foundation of your building and the actual structure of the soil and the rocks begin to interfere with each other. But you know, this is just a sort of an element that I think it could be yeah, beautiful to take forward. But again, I really enjoy the way you engaged with this topic throughout the project. So I think it's bigger congratulations for now.
I think you've done a really beautiful interrogation of the landscape. What impressed me about your research is that you have looked at the various different ecological agents. You've obviously, you understand the plant in its context. Your graphics are, you know, very, very clear. The infographics of the landscape were, you know, some of the clearest that I've seen at your level. And I think, you know, there's a great coherence to this project. Looking at the end result, I do on this, obviously it's not the end result, but looking at this graphic, I absolutely agree with Marco. What I would actually say, the thing that actually at the gut level this reminds me of, your work reminds me of, and again, I do really like this, it's the living root bridges that you find off in Asia. Obviously they are a fig tree, I believe. They're a living vine, or a vine tree that the locals weave across to make the bridges that I'm sure you've seen, because they've been very well documented. And it's actually, I think your work in that sense is more sophisticated than some of the very high profile projects, obviously Terraform, Joachim Mitchell, you know, they have obviously, their studios looked at this, but I don't think they've actually done it as elegantly as you have, even though, you know, you've actually, you know, you're at a very early stage in this project. And one of the things I'd look for maybe in your inspiration, there's actually a very famous figure that explored the integration of root systems and ruins. And that figure was, of course, Leonardo da Vinci. At Sforza's castle in Milan, they accidentally uncovered a mural that had been painted over. It is not available to the public at the moment, but you can actually view it via Google. Google went in there, and I've actually had the privilege of actually seeing it. And the murals, they show Leonardo da Vinci was actually looking at the integration of the root systems into the ruins, into the very foundations of the buildings of you know, that he was painting of Milan. It's actually a forest scene, but there are buildings, ruins in that forest scene. And I think if you were to look at that, it would both historically contextualize your work. in that this fusion of the built and the ecological is something that, you know, they working within the general domain of landscape and architecture have been thinking of in some cases for a long time. Certainly visually it may inspire you. And I do think that, as Marco says, you know, I'm looking at this and it's kind of like it's the architecture, and I really want to see some rich, beautiful visualizations that really convey this fusion of the man and the ecological made. But yeah, you've got off to a really great start, and I'm very impressed with your work.
Thanks a lot.
Thanks, guys. I think I really enjoy this idea of sort of connecting ecology and emotion, or ecological factors and emotion. I was thinking about like how you've collected the emotional data, maybe in particular, and working with this galvanic skin response, and how maybe because of the fact that the terrain is very inclined, you know, how could you potentially normalize the data in the sense that obviously we sweat not only when we have emotions, but also when we do physical activity. But you could also potentially look at that from a different perspective as well. And, you know, by doing exercise, you generate endorphins, which create sort of happy emotional responses in our bodies. And so then I was thinking about how you could sort of materialize your data gathering method, or the data that you've collected through the development of the architecture. And I think in some way you've subconsciously done that through the generation of these paths, because the act of sort of enhancing the need to move, and therefore enhancing the potential to produce endorphins and create an enhanced emotional response, not just through sort of the context or the ecological context that you find yourself in, could also be something that you could go further into. And in that sense, I would also sort of look at the sensuality of the context, because I think the site is incredibly particular. And in that sense, I like the idea of engaging with this emotional factor. And I agree with what Melissa and Marco were saying, which is looking maybe at the materiality of the structure, its potential relationship to the emotion, or how this engages with the data that you've collected, for example, from the point clouds. There's a lot of color and emotion studies, so some colors make us feel more or less relaxed, and how maybe that could become also an input into your sort of design and materialization. So thanks for that.
It's a very good project. So, and I think the result, considering it's a second year design studio, is very good. I see though somehow disconnection between the way the visual language of the data representation, both in terms of 3D scanning of trees and vegetation and growing element, as well as monitoring of human behavior and responses. And the final proposal, although the final proposal is elegantly represented and calibrated in terms of morphology, still the type of representation differs quite radically from the original mapping of both morphology than human data. So in a way, I wonder whether you want to keep that representation just for yourself, and why. So how do this type of data influence the final proposal, and how do we see that? There will be, maybe you're talking about willows, so element that grows. How do they grow? How do we perceive their growth? Their growth in comparison to the potential of human occupation would have a different timeline. Are there possibility through augmented reality, sensor, electronic element that coexist maybe with your architecture and with the materiality of your architecture to still retain some of these visual languages, an instrument of enhancing or augmenting the level of communication between the architectural envelope as an element that creates space, and and the inhabitant, being them human or non-human. So yeah, that is just an open question. I think it's something to work more on, how the visual language of the 3D scanning and of the data could inform more the final proposal directly, not simply in terms of morphological translation, but really directly in terms of, it's not a coincidence that all of you, including Anna-Rita, has got the 3D scanning as a background, right? So that and something in terms of visual language that was interesting for all of you, I guess. So how do we bring more of that language in the final proposal? How do we bring that to actually the inhabitant of the space, again, human and non-human?
I just would like to add a couple of words. I think you guys did very, very well. I mean, you went above and beyond the brief in many different points and levels. And unfortunately, as others has pointed out, you kind of fell a little bit on the visual communication of the project. Yeah, not being able to kind of bring these this rarefied type of representation of the scans into your final visualization, but also into your design in the way that design kind of meets the landscape. And particularly, I mean, if we look at this, if we think about what are those actually bundling lines that connect your hats, no? I mean, it's like that's it unresolved in a way. You could have kind of pushed that further. But I think, reflecting upon what the others have done and how, if you want to kind of keep thinking about this project and bringing it forward, perhaps the key comment is this folding of, and how does this emotive reading of the area within the ecological status, of the systems that act in the area, and how we are part of this ecology, and how we kind of deconstruct this our experience to this signal that then you can use for the project somehow. It's like, how does this information can fold again into the project at a much finer scale than what you have done, like by just practically speaking, you explain it very well. We use the emotive data to place the hats, and the hats then are inspired by actually a slightly different logic. And I think this could be totally come together in a much more intertwined way, and giving much more significance to the project itself, and to the operative logic itself of the performance of these artificial trees. But just overall, I think it was really, really nice. I think particularly you've been fantastic into developing the skills that allow you to really customize and to master this 3D modeling, and passing, from something that you couldn't really control at the beginning, and to something that you were fully able to design, really, while still using a sort of nature-inspired but artificial logic, and I think that was really, really impressive for me. So well done.
Thank you, everybody. I would need to cut the discussion. I know that we are out of time, but I would like to invite one more student to present the work. Emiliano Rando, it's our pre-diploma student. And maybe for the morning session, that will be the last presentation. And guys of the theory course, Julian and Daniel, we would like to move you to the afternoon session. Emiliano, you can start presentation.
Yes, give me 1 second. I was loading everything. Okay. Okay, can you see the screen?
all good.
Okay, so I want to start my presentation with the introduction to my area of study. And located in the south of Spain, in the Andalusia region, we find the Rio Tinto, a river that flows across the whole region and has always been an integral part of the ecosystem. During the last decades, due to intensive mining, the river has become seriously polluted, changing its tint into an unnatural red. The heavy metal mines located near the city of Nerva is the reason of this change. For centuries, the human activities have polluted the river, raising the pH level to a dangerous 2.2. Due to this, the marine fauna has gone completely destroyed, and only a few organisms, such as algae and bacteria, were able to survive. Nowadays, this post-industrial area has been abandoned, but the water pollution still remains. To better understand the complicated relation between human and nature in this area, I started my analysis with a larger scale territory that includes the mines, but also the nearby city of Nerva and the agricultural land. Using an algorithm called tendency lines, I was able to better understand the territory beside the mines, highlighting the morphology of the terrain. Sorry. Are huge images. Yeah. Yeah, this is a zoom in where we can see the actual mine. After that, I decided to zoom in the actual mines area. The area included the Atalaya de Cerro and the Atalaya and the Cerro Colorado, which are the two main mining holes. La Dehesa, that is the area of mining facilities, and lastly, the Grossan Dam, a water reservoir for the mining activities. On this map, highlighted in red, we can see the pollution of the river and how it flows across the whole mine site. I started the analysis of this zoom in through color coding, the two aspects that interest my project, the natural and the man-made. This allowed me to remap the territory and redescribe it. On this slide, we can observe the enhanced territory analysis as a combined result of two algorithms. The first one to redescribe the territory according to the color-coded image, and the second one to read this change in the territory. Here, where the contour lines are denser, we can observe an enhancement of the territory according to the natural activities. I applied this logic on both aspects of my research, the natural and the man-made. And here you can see the man-made analysis. Through this logic, I extracted points and lines from this, and through an algorithm, I connected them with the closest one. This huge amount of points and lines enable a new way of reading the landscape, where the most dense areas are represented, where the most dense area represent the connection between human and nature. On the next part of my project, I want to introduce you my research. The goal is to produce a bio-based structure to clean the polluted water. And to do so, I started my research on bioplastic. A plastic material that can be biodegradable and bio-based can be defined as bioplastic. I will show you work of Ari Johnson. He was able to create a waterproof bottle that can be used as a replacer for the nowadays bottle. This specific bottle made out of bioplastic can be melted and recycled without harming the environment. Next, I have a second project made at the University of Innsbruck on bioplastic. During the course, the student had to produce the bioplastic and mimic a previously studied territory. Next, I have my personal experiment on bioplastic. I ran several of them, changing only one parameter at a time. On the right, we can read the recipe that I used for my experiment on bioplastic. In the first row, I changed the amount of glycerin, but as you can observe, the result didn't really work. The bioplastic was stitchy and didn't solidify at the end. On the second row, I only changed the quantity of starch to obtain a solid material, but at the end, the structure was too brittle and break. On the third and fourth row, I observed the most suitable result. In both, I experimented the bioplastic, and the bioplastic at the end became solid but maintained a certain amount of flexibility. My goal was to produce a bioplastic that could be 3D printed. The conditions of doing so are the following: overlapping resistant and solid after drying. The reason of so is because to be able to 3D print a material, those conditions needs to be achieved. The first one, because to be able to grow, the structure need to be solid. The layers needs to be layered. And the second one, to avoid failures in the whole structure at the end. Yes, here on my experiment, I can observe that the best bioplastic need to have a certain ratio between glycerin and starch. The best condition appear in a range of 0.25 to 0.50, where the bioplastic was respecting all the previous conditions. And on the last part of my presentation, I analyzed the modern water treatment system. The water is processed through several tanks where many chemical components are added. This process produces clean water, but it's harmful for the environment. Many of these components here on the left, top left, are the result of mining activities. On my project, my system, I will produce a 3D printed structure made of algae bioplastic. The algae have the ability to absorb heavy metals and pollutants from water. And this is the final goal of my project, an ecological 3D printed bioplastic structure to clean water of the Tinto River in combination with the ability of the algae. Thank you.
Thank you very much, Emiliano. Should we start with the comments?
I'd say, I think that you've chosen an important problem, and I think that you've started the process of researching that generally well. What's not clear, there are a couple of things that you need to iterate. First of all, bioplastic is an overarching term, and there are very different properties of bioplastics. So the first thing I would do is be very clear about, when you speak to bioplastic, be particular about what kinds of bioplastic you're talking to. That has particular significance in terms of the fact that from a biodegradability perspective, there are some bioplastics of which the compounds can be reabsorbed. They are safe in the natural environment, and there are some that aren't. And so in order for your project to stand up, if you like, you need to iterate on a finer level of clarity of the particular types of materials and particular types of properties that you're creating. Otherwise, that will not be, that will not be visible, as it were, and it does need to be visible. The second thing is that you've identified what is in effect your source of materials. So these are the pollutants within the waterways, and you've iterated sort of that you want to make a material with it, but that step in between is not very clear. So you basically need to be clearer in how you are identifying, well, how do we extract the source materials, the chemicals from the water? What sort of site, what sort of process is behind that? Is it going to get extracted off? I mean, I can see before me a diagram here, but even that's not very clear. How is that water actually going to be taken out from the environment, processed? You also need to look at how that impacts upon the local ecology. So of course, as you say, there are some distributaries, there are some waterways that are going to be so toxic that the fish will have died and the macrofauna will have died. But you need to iterate that. You need to define you know, what is the sort of ecological impact at a much finer grain than you've actually done. So really in your project presentation, what is not clearly defined enough is the processes and some of the specifics. So you need to dig into that, because without that, you know, the project is not really going to hold together. So I'd say go back to those points. And also, if you really want to sort of add the extra, when you've done that, if you really want to add the extra weight to this, also think about how is that bioplastic that you create, where is that going to go? Is that going to go into local production? Is it going to go, you know, here, there? Where is it going to go? What's the logic behind that? And then that would create a project that is, you know, that has a much clearer logic to it than and application than this sort of current very rudimentary level of research.
Thank you. Yes. Mm-hmm.
I go?
Yes, so.
You want to answer, Emiliano?
No, about the last part where I will place bioplastic. In the first part, the analysis, where I have the, let's say, meeting of natural and man-made, those denser area, this could be the site for placing the bioplastic structure. That was the main idea.
Okay, thanks, Emiliano. I couldn't agree more with what Melissa was saying. I think you get to the juice of the project in the very last sentence that you said. So I think it's important that when you present the research, you sort of lead us. You have 3 parts. So what are the conclusions of each of these parts, and how does that then build to the next step of your research in some way, in a proactive way? And for example, I was going to ask also, you know, what is the connection between the human and nature? How does that relate to your research in a proactive way? And so you've just answered that question. But I think in some way it's important to identify, you know, what are your conclusions in each of the parts, and then how do they come together and build a project? I have some questions about sort of the direction that you're taking that I think also could help you in some way kind of like take the next steps for the research. So why do you want to 3D print the structures? I guess that's on one part a relationship to the materiality, but potentially also to the actual form of the structure in itself. Are your structures in the water? Because I understand that the main pollution is within the bodies of water. And how does this relate to the soil? Because that's the next thing that would be heavily polluted. The other question is, when the algae absorbs the heavy metals, does it in itself become toxic? And considering that you're working with bioplastics in your structure, when the structure in itself biodegrades, do we have to collect it if it becomes toxic? And in that sense, I would maybe invite you to reflect, rather than on a 3D printed structure as such, maybe a process of which 3D printing a structure is part of. And, you know, again, thinking about what are the benefits of using 3D printing in the architectural scale, how it can help us to optimize the form, sort of completely customize a form to a specific terrain, and what kind of performance also could this architectural form offer. But also a process of, you know, what happens when this structure biodegrades, what happens to the material that we collect, and what is the material maybe that we are using as an input for this process to kind of continue over an evolution of time. And then that's the other thing. I would invite you to reflect on time and how that relates to your project, in the sense that when we're talking about, you know, this pollution has taken place over time, and to mitigate it in some way, we need to factor in as well the time scale. I understand that these sites are no longer used as mining sites. Is that correct? Or are they still active? They're no longer used. Okay. So in that sense, you have an advantage. But nonetheless, I would invite you to sort of look at the evolution over time and how in reality, you're not just simply doing a 3D printed structure, but you're rather sort of giving way to a process that could allow to mitigate in some way the issues of pollution that are on the site. And I would invite you maybe also considering that you've looked at the connection between the human and the natural territory to think about how maybe the local community could potentially be involved within this process as well, to activate the process and to take an active part within the development of this synthetic landscape that you're working towards, which in some way mitigates the landscape that we've kind of created. Thanks, Emiliano.
Yeah, thank you too for the comments. They are super useful, and I will surely dig into them. Thank you.
Thanks for the
Can I just...
okay, Marco, go for it.
Sorry, I mean, I know it's late. I mean, just a very quick word. I mean, I think that I think the project is actually really interesting in the context also what we were discussing before about the notion of contaminants, contamination in relationship to the landscape itself and the processes in the landscape. And I would argue also that in this particular instance that you're showing to us, these minerals that are dissolved and then deposited on the edge, they also create a very strong aesthetic that this landscape possess. And then, you know, to a certain extent, are also very beautiful in themselves when you look at them. So clearly that beauty in you know, as reflected in you know, the death of several species. So there is a kind of, you know, contradiction in that, we could argue. But on the other hand, you have mentioned that you know, some organisms have survived and were able or are able to actually feed on these concentrated minerals. So the question is, how does your bioplastic membrane, let's say, or a structure becomes a kind of medium to reconcile these sort of contradicting forces in a way, and totally the time frame element is crucial here, because you know what your structure could do is essentially act as a sort of a condenser or concentrator, if you want. It could be introduced in the water in a way that generates pools where the pollutants actually become denser through evaporation, for example, and then the introduction of algae culture, for example, could become an effective method in that way of remetabolizing these condensed, let's say, pools, and you know, essentially break down the components, the mineral components, which is what, you know, some algae species do with some components, and that, you know, that's where also the research is important to become more specific. But then eventually you could be left with organisms that are in part have remetabolized these elements that could be probably released in the river and you know, and become part of the ecosystem of the river back into normal concentrations. And you know, the structure that remains there, your bioplastic structure that remains there, perhaps will have absorbed in its structure part of this process, maybe will exhibit some of the features in color and in gradients that are present in this sort of contaminated landscape, but at that point without the kind of let's say poisonous levels of concentration that you experience now. So in a way, they could become the kind of a substratum for a new, healthier ecologies to grow. So in that sense, I think that really this circle diagram that you show here should be much more an expression of this, let's say, renewed life cycle that you are introducing or that you're hoping to introduce, whereby the bioplastic becomes a kind of temporary element in a way that has a very clearly design the time frame for or useful lifespan before it dissolves. And in this useful lifespan, it does a very specific task, which is the one of essentially capturing and concentrating areas of pollution, allowing for the process of purification to take place efficiently, and then eventually disappear back into a new substratum that may be planted, maybe regrown, leaving perhaps the kind of landmark that is become now the new characteristics of this landscape. So there is maybe a design intentionality there as well that you can bring forward. It's not about bringing the landscape back to where it was, but it's about creating a new functional ecosystem on it. And and then you go back to the beginning, but with a completely different situation. So you kind of close the loop in a sense. I think that could really make this an exciting project. The actual recipe and development engineering of the bioplastic is for me the crucial element. But in order for that to be meaningful and relevant, you need all these other parameters to be declared and clarified so that you actually know exactly what you're trying to engineer. And then whether you're successful or not is another story. But at least what is important is that you become very clear about what is that you're trying to achieve.
Thanks. Thanks, Marco. I agree with the comment. And I have a further comment for Emiliano for the thesis in the next month. I think at the moment, the part that is related to the material research and the part related to the site have some correlation, but I don't see the connection that should be there yet. And I think that at least one of the two parts should be developed much more in depth, and there should be much, much more work on that and testing developed. So as you've been working with us also research project on 3D printing and material experimentation, I would suggest this part needs more work and research to be able to also reframe the larger scale. I don't think at the moment it's possible to really, develop both in the context of your thesis. In other contexts, it's totally possible, and this is the way we usually work. But in the context of your thesis, I would say that this type of experimentation needs much more work, and then we should reframe the other scale. But we look forward to see what happens next. Thanks to the jury that took part in the morning, I think we might skip the break and start directly with the next session. We have Manus here that joined. Hi, Manus.
Hello.
Hi.
Good morning, good afternoon, or whatever is the time zone.
Nice to hear you. Manus is historian tutor, Eastern Theory tutor and coordinator of the Eastern Theory module at the Bartlett Pro UD. We also is Lisa Brunner joining us, that is part of our faculty in the bachelor course. So Manus, we have a variety of courses presented today, and we will start this session from the BitBioBot, which is the master course led by Marco Maria Nerini, and that is happening in virtual reality. Thanks, Matilde and Melissa, for joining us and for the great
Thanks very much.
comment. Nice to see you. Hi, Melissa. Bye.
Thank you so much for joining us. Thank you for the comments. That was great having you.
Nice to see you or hear you.
So, Manus, as I was saying, we have a series of courses. We have the Master Studio led by Marco Maria Nerini. We have the Bachelor second year led by Anna Rita, that you know, Lisa Brunner and Matthias Vinetzer. The Seminar Theory course on this synthetic landscape led by Teresa, as well as the pre-diploma, that is the last one we finished now, and there will be others later, that are the students that will continue later in their thesis. So now we start from the master course. I don't know, Marco, if you want to say a couple of words, and also we need to enter the VR.
So we are not taking a break now?
No.
No,
okay. We take a break later. Yeah, sorry.
I'm hungry. Vabbè, okay. Vabbè, so...
Manus is in the room, so no break is allowed. So,
fantastic, fantastic.
Marco, can I interrupt you for a second? Before
Yes.
you introducing the course, I would ask, first of all the jurors and other guests enter to the Mozilla Hubs room and let it load. I'm sending again the link, so you could be loading it, Manus. You just need to press this room or enter it in your Mozilla or Google Chrome.
Yeah,
and
Marco,
start
maybe
loading.
you can say a couple of words inside of the Mozilla.
Yeah, no, I was just checking. I think I'm in already. So, yeah, no,
Sorry,
I mean,
Marco, maybe before you start, I want to also jump in just to coordinate the students of theory, because we skipped Julian and Daniel. So I want to just tell Julian and Daniel that they will present after this VR presentation, and we will shift everything.
yeah, we haven't.
Will be maybe probably moved to tomorrow.
We haven't forgotten, but yeah, we need to be a little bit maybe sharper in the rest of the day. But anyway, I mean, yeah, very quickly for the program, as I said before, was a kind of experiment in basically conducting the studio in a virtual reality space offered by Mozilla Hub as an interface for us to engage not just with the project, but also among ourselves with the students, since we couldn't obviously meet physically, and we decided to conduct effectively most of the tutorials in the virtual world of their own project. So somehow to kind of inhabit the project as it was developing. The topic, let's say, was really a kind of exploration of the notion of synthetic landscape through this new medium in a variety of sites across the world, where, of course, conditions of friction, let's say, between biospheric processes and the urban sphere were most evident. We have seen one project already in the morning. I think now the next one will be from
Ben and Linus.
Yeah, Ben and Linus. Okay, perfect.
Yeah.
So I guess we should just meet in there. If you guys manage to access the link and don't take more time.
I would propose that we keep the voice here in Zoom.
Okay.
That everyone could follow. We also keep sharing the screen here. Yeah. And but I propose everyone who can log into the Mozilla room, let's travel there. We mute ourselves there. We keep the sound in Zoom and we talk like, via Zoom. So yeah, thank you. Muting myself. Guys, you can start the presentation.
Hello, everybody. Hello. Okay, so is everybody in the scene? We hope so. Hello? Okay.
We have quite a lot of people there. Let's just check that Manos is there.
Where shall we meet? Is it the point number 1?
Yeah. Well, first we have a brief over the desertification. Desertification, in the last 50 years, there are approximately 650,000 square kilometers lost to desertification. Desertification is a very complex topic. First, there is climate change, which tackles the desert with dry periods and lots of heat, but there are also lots of more direct man-made problems like politics, who choose that the remaining water is going to touristic areas, golf courses, and hotels. Yes, so we can now meet at the first post at number 1. Yeah, we can meet there. So the first post is Agadir. It is a Moroccan city situated in the South Atlantic, in the Atlantic south of the country, just next to the Atlas Mountains.
The capital is famous holiday destination that attracts with golf courses, big resorts, beautiful beaches, and also with the Royal Palace. The city has about 700,000 inhabitants and around 11 million visitors a year. This massive amount of visitors also reflects the economic key sector of the country in tourism. On the one side, it's precious for many workers that are employed in this sector, but on the other side, many other sectors are getting lost on the way, such as the agricultural sector. We will come back to that later on. Now we can move to post 2. It's just behind you.
Well, on post 2, we show you the problems of the areas. It's over the past 3 years, Agadir has been struggling with a drought to make a choice, either the city or the fields of nature. Yet authorities chose, in fact, to divert the water to the resorts and main tourist areas. That results in having thousands of people end up with no drinking water or water for their fields. This is forcing more and more farmers to leave and let dried out fields behind. Therefore, you can see the cracks in the soil because the soil is getting too dry and everything breaks up and there are no nutritions anymore. So now we could meet at point 3.
Point 3 is just on the left. This post is called the fog base. The fog is very special to the area. Yeah, but maybe some overall brief to the climate of the region at first. The average annual humidity of the Suez Basin Channel is about 73.8%. It ranges from 70% in February to 77% in July. And the climate is, as I said, a bit particular. It's subtropical oceanic, very temperate and arid. The winters are very mild with quite rare rains, while the summers are very hot, but with no excesses. And also there is almost no rain in the summer. Along the Atlantic coast of Morocco are cold current flows that makes the climate very mild and also causes fog and low clouds, especially in the warmest months. And these fog and low clouds are transporting a massive amount of water into the inland that actually can't be used because it's not accumulating anywhere. So it just vapors in the air. And our project is to harvest this fog and to accumulate water out of the fog and redirect it into where it is needed the most. Yes, now we can move on to number 4.
Number 4 are our fog harvesters. The harvesters are designed to separate tiny fog droplets from the air. This happens through condensation by letting the wind, which carries the evaporated fog droplets from the sea, through our harvesters. For the design, we tried to generate lots of surfaces so the wind can pass, but still gives much of spaces for the fog droplets to settle and get collected. So, as you can see, the fog is evaporating from the sea and travels through the air in fog or in clouds, and then passes through our harvesters. So by condensation, the water can get collected from the harvesters. Okay. The next point.
Yeah.
Now we can go to the point 5.
Point 5 shows the implementation of our fog harvesters. It gives you an insight to its drainage system. The harvesters are arranged on higher altitude to provide the maximum exhaustion of fog and the low clouds. Yeah, they also serve as water storage towers to provide constant pressure on the drainage system. The drainage system you can see here in blue is a collection of pipes that is transporting the harvested water from the fog harvesters to the regreening site. And this system is based on the shortest walk of the surrounding terrain, which is essential for a smooth transportation of the water. Yes. Now we can proceed to number 6.
Number 6 is our regreening area. So this is the idea on how the area could look in the near future. The logic behind is that the plants could regrow by themselves, so we don't have too high of an impact on the flora and fauna of the different areas. With the natural regrowth of the flora and the soil, with the flora, the soil becomes more nutritious and the regreened area can start to become fog collectors on their own. So yeah, they could provide like a new environment and a new, yeah, they can collect the fog by themselves with leaves and so
on. You now can explore the site by yourself as you want. And yeah, we are finished with our presentations. Thank you.
Thank you.
Thank you very much, guys. While we are while we keep our travel through the room, we can start maybe discussing and commenting. Did everybody manage to follow the presentation and enter to the room?
Thank you, guys. I wanted to understand a little bit better the way, how the architecture of the fog collectors or harvesters, which are basically the key element of the project, I would say, in terms of proposal, and how the architecture of the fog collectors in a way responds to the landscape, like the way the fog actually moves across it, and also to the, let's say, necessity to, on one side, capture these micro droplets, but on the other side also to somehow collect them before they evaporates again, in order for them to become available to the plants or to the living organisms that we are trying to feed and to give them the opportunity to grow. So in a way, do you expect this architecture to function both as a capturing and as a storing device, or is the storing of the water understood as part of the ground, of the terrain? So is this architecture regreening, modifying the ground, or is it feeding water directly to the plants in real time? How does this work? Because I haven't been able to understand really the specific connection between these different elements.
So the collector's aim is to provide as much surface as possible on a dense area.
How much surface exactly this one, for example, is actually providing?
I don't know the real data. Yes, so the rendering should actually just show the system. Or what do you mean exactly? Like,
right. Then once this, let's say, once the surface is let's say intercepting the droplets in the air, what happens to these droplets? Let's say.
Yeah, the droplets are, like we said, they are guided through the harvester, and they condensate on the colder plates, steel plates, that are implemented in the harvester. And from there, they get drained to the drainage system. And yeah, from there, they get redirected to the plants to water them.
Are the winds quite strong there that are moving the fog or not? Is it quite strong wind or very gentle?
There are some strong winds. There are also a lot of hurricanes in the area on the Atlantic and stuff.
So how tall is your structure there?
I don't know. It's about 100 meters, and the first.
Okay. So how does it work structurally? Let's say for 100 meters tall structure to resist wind and hurricane force winds. At least, let's say, conceptually, how do you imagine these to work?
Well, the idea is to not stop the wind, but just let it pass through. So as you can see, when the wind is coming from the sea, it can blow straight through it in that case. So you don't have much surface which is blocking the wind. So
but you just said that you want to maximize the surface because we needed to intercept the water.
But in the flow of the wind, not like to block it, but just like so the wind can pass through, and so the fog can get collected, but it doesn't blocks the wind or doesn't get a lot of resistance from the wind.
So the droplets have many chances to condensate there on the plates.
There where?
Maximize the chances.
On the surfaces, on all the surfaces, and mostly the ones inside the harvester.
Were you able to estimate more or less how much water should be possible to capture with this kind of technique?
We didn't.
Per day or per month or per year, I don't know. Like, were you able to make a kind of estimate to understand, for example, how many hectares of land you think it's possible to regreen with one such device? And we're talking about 100 meters tall device, so it's a huge landscape intervention. How many hectares of land you think it would be possible to regreen with it?
Yeah, like we're showing in our scene, like in the back, you can see the regreening area. This is our estimated impact of the harvesters. And yeah, the harvester system can also be an adaptable system to other locations, yeah, to regreen everything there.
Can I jump in? Or, I mean, Marco, I can feel that you're going through kind of a lot of questions detailing this kind of scheme, but I want to step back and ask, what is the aim of the project? Why? I mean, am I missed it? I'm very kind of new into this kind of discussion that you have already. I don't know what is the direction of the cluster or the studio, but why regreening?
The main problem of the desert is that it's with climate change and with the all the stuff politics and people are doing by farming and so on, the areas around the desert are getting bigger and bigger because with heat and with the loss of water, the area is getting drier and drier. So the desert is growing, and it's as we said, it is growing, but also it is we lost like 650,000 square kilometers in the last 50 years of green land around the desert because it is getting drier and drier. Yeah. So we wanted just to tackle the problem by providing
okay, I understand this one, but here we have to think that any kind of intervention in any kind of ecological needs, and by intervening in any kind of metabolic circuit, you suddenly kind of change the overall ecology and the territory of that part of the planet. Okay. Yeah. And actually you can change it and you can transform it into directions that you can't imagine. For me, I always use this kind of example because I think it's a very, an example that kind of illustrates the power of these things. I don't know if you know the story of the Yellowstone Park with the 6 wolves that have been introduced in 1960s. And by now they have transformed not only the population of animals and plants, but actually the geophysical kind of terrain of the planet. So it's almost like a geoengineering agent. So by intervening in this kind of metabolic processes with your frog collectors or kind of trying to regreening, you should actually take into consideration that any kind of intervention will actually take the planet into a direction that you start kind of thinking about the consequences. I remember Marco just said it, 20 minutes ago, that the aim here is not to return back into a previous condition, but maybe to see how now we can intervene into a metabolic circuit that we have now and kind of offspring a new kind of nature, a new kind of ecology that we can see into this part of the land. So saying all this, we need to kind of think strategically and design-wise, in speculative terms, how we can create this kind of interventions. And then it comes to the idea of the fog, the fog harvester. Okay, just to put in like a sculpture-like structure there is not enough to discuss about fog harvester. There's a beautiful article by this guy called Ben Singleton that he's talking about maximum jailbreaking. And he's talking about the idea of the trap. You can't get a giraffe with a fly trap, because any trap, it needs to kind of accommodate the scale, the resolutions, the physical aspects of what you're trying to trap and what you're trying to collect. So yes, you want to maximize the cold surface. Yes, you want to harvest the fog. Yes, but you have to understand, up to the very, very minute detail, what is the system that you're intervening through? What are the wind forces? What are the nanoparticles and the particles that you want to collect? And how then this will inform your design and your trap. It might not be like 100 meters long. It might need to be 100 kilometers long. I'm just saying now. Or maybe 1 meter long, okay? Because otherwise, after a certain kind of scale, you don't collect the water or you don't collect the fog. So these things need to be part of this kind of broader kind of discussion. Marco, we can't hear you if you're trying to say something, but that's kind of my point. I mean, you did like a kind of very good analysis to the overall area, but then you intervene by solving a problem that you see. And at the moment, what you need to do is to step a little bit back, and before you're suggesting a solution, to the existing problem, try to think the problem of the metabolic circuit, the problem of ecology, the problem of the territory, and how you intervene into that. Okay.
Yeah. Thank you.
I have a question really. I'm not sure if it's for you guys or maybe more for Marco. It's like something I'd like to discuss. I think this type of visualization, they're really intriguing, really beautiful, and the narrative, I'm sure with the experiencing with the Oculus, it's even like, it's another level, right? But I'm just wondering, in terms of, I had the feeling as well with the previous project that somehow, and this is a point that has been made before, no, that somehow the process is missing. I mean, that's what is known. I mean, there is like it looks more, at least like by looking at it, as a representation of a project, of a proposal, and perhaps it's less, it becomes a little bit less more difficult to argue for a specific outcome. No, I mean, for instance, I'd be curious to understand better on this project if the landscape that we are seeing is actually like has the land. Maybe you guys said that and I missed it, but if it's the landscape as it is. Or if you are being modified through this machine learning technique that are used in the studio. But somehow it's a little bit, I think like the point that Marco was made before between this, how the logical architecture in this type of environment is combined with the spatial architecture. It's a very interesting you know, topic for research and design and so on. But it's, but I don't think that somehow here is particularly resolved. No, I mean it's that's like. So is it? How did you? Is this the landscape as it exists, or is the? Or have you modified beside kind of positioning these objects and the plants and drawing the flow lines and sort of things? So what's the level of modification of the landscape that you have?
The landscape is actually as it is. The modification is just with the mapping. So the regreen site is actually not there. This is all desert. And also, yeah, the implemented flow lines and like where water is guided on the surface. This is yeah, they add on to the side to give you the understanding on how the project works.
I see. Yeah, and I think that's like a bit the criticality of this type of presentations, and that you know, by missing to kind of tell us the story that brought you to make this type of decision and modification in the landscape. I mean, you had a narrative, but the narrative is there is a problem, we kind of find a solution, if it makes sense, no? But it kind of misses like the breadth of and the depth of a more research approach that looks at perhaps like systems and how this can act differently, more in abstract, before applying it to the project itself, if it makes sense what I'm saying. So that's how I feel. But I mean, visually, I found it super intriguing, I have to say.
Thank you.
Yes, I totally agree with this comment. I think there is, in both projects we have seen from this group, the beginning of a visual narrative. For maybe in Thole one that was even clearer because there was not the sense that this is a surface that ends somewhere, but it was more a sense of a enclosed space. So maybe this is something in a next step of the project to try and understand how you enter a different type of reality, a virtual reality, and you are immersed in that, and you don't see so clearly the limit of the surface. But in this starting of creating a visual language with this technique, I think both projects were very successful. In this case, I also think there is a little bit of a disconnection between the narrative and the drawing technique. the drawing technique are speculative, while the narrative try to be very pragmatic and problem solving. So the two at the moment seems to work a little bit on two different levels, and at a master level, this should be explored further. How does the narrative help you to evolve new language and evolve the project one step at a time, working more precisely with the type of drawing technique you have been developing? This is, I think, where we are, and that is a step that will be good to carry forward in this project.
Yeah, just joining maybe to discussion, I think that in this scenario, your folk harvesters are becoming this type of a new nature, which is much more natural rather than modification of the whole landscape and regreening it. It's also referring to the comments of Manos. And for me, I really appreciate your work, especially I like the fog now, which is looking fantastic. And it's last edition, another compliment. Well, of course, I feel myself very much inside of the work, and I'm happy to see very like aesthetically appealing results. And I think that you're creating a new aesthetics also for this kind of rooms that we were previously seeing, I don't know, in the low res, in absolutely different graphics and aesthetics. I think you're giving a lot of input here and really creating a new tool for exploring the architectural space. So that's, I think that's very important in your project, that we shouldn't forget about that. I absolutely agree with the comments regarding the narrative. I think that should be pushed, and maybe pushed from the moment where you would probably need to give a bit more attention on the development of these folk harvesters, on the form finding, how did you actually structure them, no? And I think that when we move to the actual proposal of this new type of structures, which are starting to be an element of the landscape, that would open up your project in a bit different way. So, but in any case, I think that's a beautiful work, and congrats for that. And thank you very much.
Thank you.
So I propose to move to the next presentation, since in the afternoon we should be supposed to be sharp. And Teresa, correct me if I'm wrong. We are going to the presentations for the theory course of Julian and Daniel, right?
Maybe Teresa, not to confuse completely Manos, which I think didn't understood yet that we have different courses at the moment. Maybe you want to give a brief introduction of how the theory course has been working.
Yes, I just wanted to welcome Manos. In the theory course, it's a short course, and we divided the topic of synthetic landscape into different keywords. So each presentation is a little small part of what we were trying to do as an achievement of a whole course, to try to define what a synthetic landscape is or could be. So each of the students have a keyword that they started with, coming towards understanding of its meaning in architecture and synthetic landscape. And I would invite Julian and Daniel. I would propose that we see first both presentations, and then we comment them at the same time after both of the presentation. Julian, if you are here and you are ready to share your screen, you can start.
Yes, I am. Do you hear me?
Perfect. Yes.
Okay, very good. Okay, welcome everybody to my talk on the topic BIT, as seen in the synthetic landscape matrix under the infrastructural and technological topic. Just a brief index of what I'm going to talk on the next 5 minutes. Firstly, I would like to start with the introduction to what the topic BIT actually means. Secondly, we will be shortly dealing with its history. Then we'll move over to real world scenarios to answer where the bit actually plays a significant role. And lastly, I would like to give you a little glimpse of where we might be heading to in the near future. Okay, let's start with the basic definition of the bit. It's basically an abbreviation for binary digit, and it covers the rudimental logic states. So the bit can be compared to a physical light switch. So either a 1 or a 0, yes or no, etc. For those of you who have never heard of the term bit before, I'm pretty sure you have heard of the term byte. It's mostly used as a unit of storage for RAM or USB sticks. And of course, then we're talking about large scales like gigabytes or terabytes. And 1 byte is nothing else than an array of bits with a length of 8. Now that we've covered all necessary information, let's move on to the historical aspects. The very first thing that we have ever experienced in our life is us, right? Is ourselves. So interesting enough, the process of bits can also be found in our body. It's the orientation of the DNA where our genetical information is stored on. We have an information storage of 2 bits per each pair. And of course, we don't have only 1 pair. We have like more than 3 billion pairs in our body. So just calculated, that would mean we have a total result of 780 megabytes, just for information, which would be approximately the size of a now pretty outdated CD. So basically very stunning. I would like to refer to the modern technological development of the bit in the next few slides. Basically using the bit as an information carrier is nothing new. So even already in the 18th century, there were proofs that people used mechanisms back then on little cards to automatically play music. Later, it was used to store information like voting results, calculations, etc. And it became very practical in the last century as computer technology literally took over the world. So these are the early stages of the very first digital calculation machines. As you can see on the right side, this is the Z3. It was invented by the German engineer Konrad Zuse in 1941. Specifically, this one was destroyed in World War II and was later restored. Well, why is this important? Well, it was the world's first programmable, fully automatic digital computer. And in other words, it was laying the pathway to modern computing. The next step was using those little punching cards. They can be seen as a newer generation carriers of information and programs, widely used for automation purposes, and maybe nowadays compared with storage like hard disks or SSDs. And specifically the punching cards I've just shown you in the last slide, or in the slide before, were used in this thing. It's the IBM 360. And this machine is, as you can see, filling up the whole room. And this is something that is so far apart from our current understanding of technology, but in matters of time, it's just a glimpse away, right? So 50 years compared to human mankind or even the Earth is barely nothing. Today, the bit is mostly used in the processor core of modern devices, like smartphones or computers, even in the ones you have at home or probably watching this presentation on right now. When bits are arrayed, they are responsible and form the computation of tasks. So basically, they are nothing else than a lot of electric impulses or switches occurring very fast. And just as a comparison here, you see a hay needle on the right side. And if you remember how large computers were back in the days, now imagine how small those chips will be in the future. So to sum it up, we are probably just at the very early stages of the development. To get an overview of how modern computers are used with landscapes, let's have a look at the application of the bits. So this is a satellite image of the South China Sea. taken by NASA in 1988. It covers the inverted infrared spectrum, so please have a look at the light green spaces, and you will see that there are barely any. It's simply because in the area around the Pearl River Delta, there was a lot of agriculture, so very rare buildings and construction sites. But just 7 years later, if we remove the color, but just 7 years later, everything has changed and the fields became habitated by humans and new buildings were erected. Due to the attractive geographical situation of the Pearl River Delta, industrialization took place. And well, now you may ask, how is this related to the topic bit? In fact, every pixel we see on the right side is basically represented by a series of bits. And the color, of course, tells us humans what has happened over a specific time frame. If we remove the color, a gray saturation edited image might provide more relevant data on the position of the sun and possible shadows. Therefore, bits are the most flexible and adaptive units of storage and widely used in every modern geo and landscape analysis. Well, this leads us to the final topic, which might provide an outlook towards the future development. So one way to approach the future challenges might be to use AI or artificial intelligence. I prepared a little diagram on machine learning here. It's important for me that you understand that there's not just AI. It's basically, there are different ways of solving challenges. What might be very important for landscape classification is the supervised learning on the right side and the unsupervised learning on the lower side. Usually, data analysts try to teach the computer using the supervised way of learning. But interesting enough, algorithms might also be finding an own solution without any help or human interaction. I originally planned to show you a little program I've written myself here, but unfortunately time was running out and I was not able to finish it. Instead, let me present you how the artificial intelligence might be used for landscape recognition and classification purposes. Here we have a picture of the US coastline.
Yeah, please speed up a little bit. Thank you.
Yeah. Just as an example, this is a satellite image of the US coastline, specifically the east coast of the United States. And it's obviously pretty easy for us humans to understand what's going on because we can draw a line between what is water, what is greenland and soil, etc. On the other hand, for computers, it's very hard to understand the scene. From the machine's view, there's a lot of noise going on here. That is because in real nature, you often find transitions between different forms of landscape. Every scene is kind of flowing into the other one, and there are no real borders. In other words, there are bits which are storing information that might make it impossible to create an outcome model. So what is an approach to solve the problem? There is a way. In fact, in every transition we find on Earth, there's always a certain threshold. For example, between water and land or desert and greenland. And this can be defined as a more or less numerical manner. And this is specifically where the AI is now docking onto. But if this is something what we as humans can already do pretty well, why would we need AI for engineering or landscape engineering? Firstly, it's the aspect of automation. And secondly, it's the aspect of an unbiased landscape. And finally, it's because AI accepts multi-dimensional layers, also new aspects like night and day, any seasons like winter or summer, or time in general might be added to successfully predict landscape changes in the future. So as a conclusion, to sum it up, it can be held on to note that there would be no modern life without the use of bits. They are all around us and are providing a significant role for communication, interaction, and programming. Using this technology has become essential for many kinds of fields, including architecture. And by using AI and neural networks, the algorithms may find a solution to certain tasks in landscape design and development, which might be unsolvable for us humans. Thank you very much for your interest. I would be happy to answer any questions.
Thank you, Julian. You can please stop sharing your screen,
yes,
and we will have immediately Daniel present
just give me a second.
This topic.
Hello, everyone. Can you hear me?
Yes.
Okay. So, hello, I'm Daniel, and I'm presenting you today my transition landscapes researches. So my keyword was the biotone, as you can see here. And in my opinion, it is linked to a certain kind of other keywords, for example, networking and others. So when I come to my keyword discourse from the biotone, I looked at the words ecotone and bio to combine them to this kind of like biotone, which is dealing with the man-made landscapes, combining the potential of habitation space for different kind of like ecosystems. Looking at the different biomes on Earth, which are mapped here, you can see that there is a large variety of them. And in between them, for example, the alpine and the forest here, we can see that these kind of like ecotones, these transition landscapes are shaping. When we look on ecotones in a geometrical space, it would be like that two surfaces, which representing two biomes, intersection with each other, forming these kind of like ecotones. Through my readings through the semester and beyond, I come up with a new keyword, which is really important in this case, I guess, for the future of our development in ECOlogic. So it is the artificiality of becoming, from the humans, becoming more machine-like or using machines to generate our habitats or form new material improvements, or which is really important is the AI improvements to control our habitats and, for example, our agriculture. So here just short diagram of humans becoming artificial from ArchiZoom. Going further, for me, it's really important, this aspect of a co-living human machine, flora and fauna, so that we maybe abandon our areas of habitation now and using new areas that we have destroyed in the past. When I come to site analysis, I looked at this kind of like in Cornwall located area, where we see in the north really clearly this man-made structure of mining and industry in black. And when we zoom in more, we can see the differences between the natural habitats or the landscape and the man-made landscape. And also I looked at here, for example, in the same region, the Eden project, where you can see the landscape, which is what was former also a quarry, is now turned into a living habitat or ecosystem. And then I'm coming to my design proposal in that case, looking at different locations around the world. Now here's an example of coal mining in Western Germany, where you can see also really clearly this impact on the landscape. We can see all this kind of like surrounding of these places are agriculture districts and also city districts, like you can see here in a close-up. And the idea was to transform these these landscape further, because I'm really convinced that we can't stop using the rare resources on our Earth to just turn them or just use biofuel, for example, and stuff like that for the next 50 or 100 years. So the development of these areas or exploitation would be essential for developing a sustainable future for us. So working further on these sites and bringing them into 3D space and analyze them through hydro erosion, for example, or this kind of like water flow mapping, we can predict a new landscape developing in the future. And throughout this kind of like using the curvature of the new existing landscape, we can then say in different parts, we can see through the curvature that there would be a kind of like different programmatic, aesthetic, or even new biomes, like you can see here. And through the analysis of this curvature of these manipulated sites, we can see the potential for new habitats and ecosystems lying in that. So here you can see short image of how would be potential for these surface agglomeration to build or to rise up these new ecosystems. And also having this kind of like terraformed landscape where we would live maybe in the future and abandon all these surrounding settlements to give nature some breathing space and go a step further. And that's it for that today, and thank you.
Thank you, Daniel. We will now open the discussion. If anyone wants to start with a comment.
Okay, I can start because I have to go in 5 minutes in another kind of meeting. You can all hear me, right?
Yeah.
Guys, you can hear me. Okay. Thank you very much for the presentations. Both of them were kind of interesting on their own terms. I would like just to give a tangent to the discussion by researching a little bit more in depth both of the two terms. And I would encourage students, I don't know if they have finished or this is done or there's the scope to keep going on their research, just to go back and to see what it means to see the world through these kind of terms that they're using. For example, the idea of the beat. It was a very nice historical overview of a very typical, understanding of the term and what everyone knows regarding technology and so on and so forth. But it's interesting to go back and trace, almost like the worldview based around the beat, to go all the way to Leibniz, to understand monadology, to understand why we see things in 1, 0, in the binary conditions, and therefore to be able to understand, to go further and to understand why things having outlines, why things having different shapes, how we understand these shapes, and what AI can actually bring into this kind of discussion, how they can actually demarcate different kind of qualities and different kind of objects. Because so far AI is very anthropocentric, it's very kind of anthropomorphic, it's kind of, as a student said already, is supervised to understand things that we already understand. But somehow, because some kind of problems are a little bit more complex for us, they do the job for us. The whole idea is to see what AI can do independently, if they can demarcate things, if they can outline things in a different way. And the same goes with the whole idea of the biotone. Starting with a definition from the Oxford Dictionary that makes contradiction between what is artificiality and what is natural, then suddenly, well, we are already in an epistemological field where we have to think everything according to that kind of distinction. What if that distinction is not there? How then we can see the things? These, I think, for me, are the most kind of interesting, both philosophical and theoretical questions when we have to deal with these kind of terms. You know, to kind of go beyond their kind of typical meaning and their typical understanding, and to go beyond the problems that have already created these meanings. So to be able to reformulating the problems. But I think it's, I don't know if this is the end but of the module, of the course, but it would be nice if the students can actually push further the kind of research. And that's all for me.
Yeah, it's nice words from Manos. I mean, I think that the whole point of these theory programs are really to become a kind of parallel investigation of some of the keywords that we use in the studios and the studio program. So I think by all means that it is not ending here, and I think it's very interesting to begin to you know, enlarge the perspective you know, that is afforded by this investigation in the context of the studio programs as well. I mean, in the end of the day, particularly in these two presentations, I think the terms are you know, clearly in that sense, yeah, they are creating a really interesting contraposition, if you want, between which is reflected in most of the project that we have been doing in the studio, especially with around the notion of synthetic landscape, and you know, how to redescribe you know, through these drawing techniques the kind of conventions that exist within the practice of architecture, urban design, landscape architecture, which notoriously struggle to capture these the kind of liminality of some of these zones, like the ecotone, which by definition are kind of fluctuating, blurred conditions. In some cases, also very much for that very diverse and rich of life, but on the other hand also perhaps more fragile. And so again, you know, the fact that our typical recognition of boundaries, for example, it's a kind of built on a sort of dualistic understanding of the subdivision or fragmentation of territory, and, you know, understanding of boundary between inside and outside, etc. I think that, you know, this is a type of expansion you should see, guys, having a pretty direct repercussion on the way you are approaching your project in the design studios. And in that sense, I think, yeah, I completely agree with Manos in kind of the way you can now instrumentalize this research to literally test your understanding of you know, site conditions, or, you know, project briefs and programs, you know, all these are kind of elements that you typically receive or engage with, and that as an architect you deploy to read and understand the reality of a context. And you know, but through these new conceptual lenses and the corresponding design techniques that you're learning, then really expand the way we can begin to understand and conceptualize these sites, conditions, and you know, eventually the intervention we are envisioning on it. And in that sense, again, the shift that Manos was underlying in terms of how we can then end up deploying these techniques, not so much to reinforce some ideas and conception that we have already, but rather to as really exploratory tools for another understanding of the landscape, and, you know, the form of intelligences that it hosts.
Thank you very much for the comments, Manos, Marco. Guys, great work. So if we finish with this presentation, we thank you, Manos, for joining us. Now, if you have time, Manos, are you? or maybe Manu's already left. No? Yeah.
Yeah, he said he will rejoin later. I had a comment on the theory. I think it was a good work, and I think especially in the last presentation, in the case of Daniel, it's very good when the terminology discussed also follow a definition of a visual language, which is a way of discussing theory which could be explored further, and I think should be discussed further. Theory is usually the realm of logical thinking or the realm of the discussion, but how do we discuss theory also through the formation of visual language, I think is an important point, and especially the last project was exploring that more. I think it will be a point to stress further in the future. Sorry, Maria, for interrupting.
No, no worries. I wanted to say that maybe we propose to have a little break now, so everyone recharge our brains, have some food, and we connect in half an hour and continue with our schedule. Let's continue. Okay, so should we go to the presentation of Robert?
Yes, perfect.
Robert, we invite you to share your screen. And
all right. So hi, everyone.
So Robert is as well a pre-diploma, so will present his pre-diploma proposal.
Yes. All right. So before I start, I want to say a few words. I always wondered if something surrounds you all the time, it must have a huge impact on you. And while studying architecture and using a lot of parameters to design, I haven't touched one of the most important ones to me, and that is the human mind. So in my project, it's about cognition and the surrounding. And it's titled The Embodied Environment. To start, I have to quote from Andy Clark. In some cases, interfering with someone's environment will have the same moral significance as interfering with their person. So in my presentation, I will first show you a bit of my design background. I will take my research from the cognitive biases and the embodied cognition, and then I will show you my interactive drawing and the design study setup. And in the second half, I will go to the embodied environment and look at the spatial projection, the feedback loop, and then a short reflection on the project because it's a work in progress. So first of all, the design background. The first thing was to achieve a basic understanding of how our brain is working and perceives things. So I looked at the work from Daniel Kahneman, a psychologist, as he lays out the basics for our cognitive processes in his book, Thinking Fast and Slow. And in there's this picture with the quote, "To observe your mind in automatic mode, glance at the image below." And so I learned that there's an automatic mode, and it's basically uncontrollable. So it's completely subconscious. And whoever is watching someone in the face just from an image or a real person, he receives a stimuli, just a visual stimuli, that can have a complex impact. So then there are the cognitive biases, and they just describe how brain works. So that's the reason why there are so many well-described cognitive biases, things that most likely trick the mind, and you can see a map of them on the image. But those biases, they have one problem for my approach. They are mostly triggered by language and not by form. So I figured out to use eyes driven by form rather than ears listening to a spoken word. And so for the first step, I really needed to get the attention of a person into a certain direction, like you can do it with language. And so I needed to control the eyes. So I built a custom eye tracker that delivers me the points where people are looking at. And as you can see down at the left, there's the eye movement, and it's just translated and calibrated into a screen at the moment. And yes, for the beginning, it works out with this DIY tool. So I linked up the eye tracker onto a mesh. And as you can see in the animation, down you have the coordinate system. And when the eye moves, it leaves the imprint on the mesh. What it actually forms, I will come to that later, but this was the first link up to it. So this would allow me to mirror someone's eyes in a geometry. However, this is also far away from triggering any cognitive process. So I needed more information about it. And that's where Andy Clark comes in. And in Clark's theory, it is possible to change one's beliefs through changes in the environment. And he compares it to an Alzheimer's patient who relies on his notebook. But not always, because like this person, he can't remember stuff. So if something is important, he writes it down. And if it's outside of his mind, but it affects his everyday actions. And in this theory, I could find a part of the notebook that we all carry around. And that's perception motor control. And according to Clark, this is something like an evolutionary relic that drives us. And with the eye tracking, I'm already close to the motor control. But he gives me an even better hint, and it's emotions that are the key. If it's emotionally arousing, you're acting on it. So how do I achieve this? And that's where I started to look at the galvanic skin response and the heart rate to inform the design of the emotional state of the observer. And as you can see, also, I just linked up to sensors, to an Arduino, and measured the galvanic skin response that measures the conductivity of the skin. And this reaction of the body is completely subconscious and allows conclusions to the level of arousal. And the heart rate measures the beats per minute. And I just use it to complement the GSR measuring results. However, then I got the graphs, so I translated them in a scale that I can use them. So I set different levels of arousal, and this is how I applied it to a geometry. So the more aroused the person gets with the GSR fields, the larger the geometry gets affected. So you can see the GSR rising at the bottom. You got the slider with the red dot. It's like, and it's going up and down. The same is attached to the force. So how much the geometry gets distorted. You can see again, slider going up and going down. And then comes the heart rate. And the heart rate is responsible for the height. So it gets in a third dimension and it reaches out. And that's the thing, yes, that's what I use for the heart rate. So you can see here the comparison between the different GSR levels, left a low arousal, right a high arousal. And they all use the same eye tracking patterns at the moment. So this is really just about the emotional or the arousal of the person. However, this needs a bit more support, I thought. So I will take a look at the embodied cognition. So what is the embodied cognition? Basically, it's in sharp contrast to the dualism from René Descartes in the 7th century, where the mind and the soul is regarded completely different from the body. And the embodied cognition follows the idea that the mind is not only connected to the body, but the body influences the mind. And it has a relatively short history and that date back to the early 20th century and is empirically studied only for the last few decades. And one key figure is George Lakoff, professor at the University at Berkeley. And he states that our brains take their input from the rest of our bodies. What our bodies like and how they function in the world structures the very concepts we can use to think. We cannot think just anything, only what our embodied brains permit. All right, let's have a look at architecture. Does this work? If a stimuli is different, do we behave different? And this is a study from Anne Sussman in 2017. And she does pretty lot eye tracking studies and changes architecture to look where people do not look. And for instance, she found out people do not look at blank facades, as this image shows. So a Photoshop version on the left side without windows reveals that if there is nothing going on, people won't look there. So from this point, yes, pretty obvious works. Then there's the standard eye movement chart from neurolinguistic programming, which is regarding subconscious eye movements. So if you're thinking in a thinking process and you're remembering stuff, you most likely look to the left. And if you construct stuff, you tend to look to the right. So it shows that some eye movements are connected to certain areas of the brain. And then from the design perspective, there's the research fellow Pierre Kutilek from the ETH Zurich, who designs with brainwaves or brain activity. He also uses an algorithm and a design which has certain design decisions. And with the feedback from the observer, as it's in a diagram shown, like the blue person, it's processed and puts out a new stimuli. So depending on where this person actually, or how much it is stimulating, the design takes another decision. And with this background, I was confident enough to set up the interactive drawing, consisting of eye control, GSR force, GSR fields, and ECG elevation. And this is what it looks like. So this is now all the forces together. You can see the mesh is guided by the eye movements. Down there, you got the control panels. And as we go back a bit, you can see like the large impact when the GSR is really, really up. You got like there are 5, then the big impact comes, and that's what the interactive drawing looks like. Okay, so to make a design study out of it, I made a pretty similar setup to Pierre Kudelec, and I got the observer, I got the measuring unit and the processing unit. And then I got the design stimuli. And this design stimuli continues in a loop and always updates as the observer behaves. This is the short diagram of it. So I got at the red dot, it starts the design stimuli, which is initially designed by me or by the algorithm. And then it gets presented, measured, the biofeedback gets recorded, then it gets evaluated, and a new deformation of the geometry is happening. It's a bit confusing. So here's what the setup would look like. So first of all, I chose for now to do it in VR. So there's going to be a VR projection that you feel like you're completely in this room. Then there's the possibility to link up the person who's actually occupying the geometry and also designing it. So it's really linked up to their eyes. The person is looking at a certain spot, so at this spot is something happening. And the person is very aroused, so it gets a crazy geometry like this. Then there's the possibility that a third person is linked up. And it's not actually observing the geometry, just the data is getting gathered from this person. And as you can see, the geometry behaves different. And so what are the difference between them? So the interactive drawing and the recorded drawing, for me, the interactive drawing just mirrors something that's going on in you, and the recorded drawing makes it some kind of empathic device that you can, like looking at somebody's face if he's talking to you. So it just mirrors the state of this person. All right, and just from the setup, we got here, yeah, the control panels, how the drawing is made, and yes, exactly. So down there you can see the setup. You can see the top view as well as it's reaching out. Okay, so that was it so far from the work in progress. I got a short review. So the first critic point is the geometry itself. The screen-like base grid is not the ideal geometry to fulfill the task, I'm absolutely sure, but basically it's just a point cloud behind, so it can take any shape, and it's just for visualizing now the state of what the research had gone. And the main intention for the pre-diploma was to create a tool to measure and visualize physical reactions of the body and to create a workflow with the sensors for an interactive drawing. And my further intention will be start stimulating and measure reactions from the evolving stimuli and learn from the effect of different geometries and develop the embodied environment. All right, thank you very much.
Thank you very much, Robert. I would like to invite everybody to comment, ask questions if you have any.
Yeah, I mean, I can kickstart if that's okay. Hi, Robert, how are you?
Hi,
I can see you've done some progress. Interesting, very interesting work. I was just wondering, I mean, in this, I think there were 2 points that I thought about when you were talking, right? So on one side, you are discussing ideas of cognition correctly, and I think you also have very good references. Mm-hmm. But then I think that actually, like, for instance, the Kudelec project, it's very much about decision making, which is beyond the cognition, the idea of cognition itself. So there is a process that passes from cognition, knowledge accumulation, perhaps behaviors, and then get to decision making. So I think that perhaps there, if you kind of start to keep looking into like the theory and from the neurosciences, philosophy of sciences, and so on, you might find some, you might expand a little bit better, and it would give you like some further point to develop the project. Because I think here for me, the key point is ultimately, what's the purpose? No, I mean, what's the aim? What's the operativity of this ultimately, okay? Because I think on its own, it's extremely fascinating. But the big question is, why, you know. For me, it's like I think you need to argue for the potential of this type of technology to be relevant somehow, and I think that's a little bit missing now. You pass through a certain point. For instance, you mentioned that eye movement. You mentioned a study where eye movement is attracted by details, right? But then you set potentially your user, let's say, or your performer, as I prefer to say, in front of a blank screen, where actually everything, you know, the project is it starts from nothing to emerge into this sort of specific organization, and you say, well, it doesn't matter really if it's this shape or another shape, but it should matter, right? That's exactly the point. I think that if you, I mean, on one side you have kind of established like a very interesting workflow, but I think you should kind of reflect a little bit on, and it could really gain a lot of much more relevance if you imagine some sort of specific operativity for the project, which I'm sure you are one step away, I think. And then I think everything will follow, will become like a very specific thing to and it could be extremely communicative and use, you know, all of these theories and technologies that you have, you know, kind of reflect upon and structure this, but it misses a little bit the context for me at this point. But I mean, super interesting. I'm looking forward to see where you are in a few months ahead again.
Okay, right. Thank you very much.
Maybe I just follow up on Anna-Rita's comment. And I mean, first of all, I think really this is exciting stuff because it's in a way touching upon a topic that is kind of obvious to everyone, like that, let's say, good architecture makes people happy or makes people, you know, think better and be more creative. So if you are in a good space, so that's a kind of obvious thing. But on the other hand, there is very little, you know, serious research or work done in a sense on how we can effectively deploy this possibility to use the environment to benefit people's health, if you want, especially mental health. But you know, as you have clearly also stated, you know, cognition is embodied, and there are very clear correlation between the two. So in that sense, I also agree with Anna-Rita that the way you design this virtual landscape of yours, it's a very crucial element, because it's the element that, you know, creates the possibility for a feedback loop that becomes you know, beneficial and positive for the cognitive abilities of the person that engages with it, you know, rather than perhaps you know, driving him or her into a sort of catatonic state, you know, and therefore kind of disintegrate its cognitive abilities even further. And again, the purpose of it, I mean, on a very banal level, it seems totally obvious to me that right now, from this perspective, the current crisis we are in as a society and the ecological crisis which ensues from that, it's very much the consequence of the fact that the vast majority of us spend like 99% of their time in kind of ugly indoor environment with little connection to anything that arouses you know, our senses and our metabolism and kind of keeps it alive and creative. And so, as you said, if basically what you are allowed to think is really dependent from that, then, you know, there's no surprise that as a society we cannot figure out any credible way to emerge from the crisis in which we are in. Just simply we can't think of it because we have put ourselves in a position of not being able to. And this is very much true to the let's say the struggling working classes, as well as the wealthiest leaders or persons in the world, you could argue that wealth in this case is not necessarily the factor, you know, like the famous 1% mostly spend their life into kind of a cheesy air-conditioned environments from one place to another with very little reason for being happy or creative. So, you know, it is a kind of fundamental problem, I think, of humanity where we are now. So I'm kind of exaggerating it a little bit, but, you know, I think in a way there is something really powerful there that you could aim at. And, you know, in a way you could also begin to speculate that your device could be some kind of a, health machines or curative protocol that in a way kind of through the VR medium can effectively create moments of activation and exposure to a landscape that you know, in a way becomes beneficial to the capabilities of the brain of the person, that subject that becomes part of this process. So, you know, in other way, I think there is a lot of opportunities here, and I think it may be interesting to just try to figure out a very clear, pragmatic scenario and aim to help you test the whole idea, the whole setup, and then, you know, from there see where it takes you and maybe how you can generalize it, you know, more from that specific case study or scenario. And then, you know, you may find that there are a variety of images and landscapes and processes that you can introduce in this. But, you know, again, to start from a very specific one, I think it would be very, very good and important.
Yeah, I can.
Thank you.
Yeah, I can maybe just add on that, but thinking same direction that we also were discussing it all the last creeds, that if we target your project from the very beginning and towards specific direction, that would help you a lot to find an answer. That we need this hypothesis that you are following in order to have a clear development of the project. And what it could be, there is probably different direction. What are you discovering? What you're trying to achieve? You need to say it to yourself clearly. Are you, for example, now you are thinking on this some type of interaction between between the person and space, or between the person and the memory of the space, or the person and another person? I don't know. Is it the scenario of the interaction through the space, with the space? I don't know. If so, for what? Now, how do you actually open this up? Or are you trying to find a typology maybe of the virtual space that would be interesting target and interesting question? Because same that we were discussing, I think the virtual space might have us absolutely different rules and absolutely different scenarios to discover. And that would be probably the way to investigate this topic. And but then I'm not sure that you need to work with a pattern. I think you need to work maybe with with your surrounding. I'm not sure that pattern helps, or maybe we are just not there yet. No, or are you trying to discover some layers of information of the physical space through the augmentation, via virtual layers? No. Is it this case, this scenario? And then in this case, maybe the patterns that you're developing are working, and there is a way to maybe open up the memory of this physical space through the virtual. I don't know. But still, even all my proposals now sounds quite abstract, that I just suggest you to jump into the specific direction. Same as Anna Rita and actually Marco already just told you. But anyhow, I really like the development. I think there is some good steps made, and there is quite a strong theoretical statements and a lot of reference that you are pointing out. And I think the development is coherent. So I'm looking forward to working next month, next half a year, no, we still have time to develop. So we are in a good moment. So yeah, looking forward.
Perfect. Thank you, Maria.
Hi. Hi, thanks for the comment. I think we are going to end up being a little bit repetitive on the main core of the comment because it's quite obvious, but I will try to take it from afar. So we have been working with you already on the master design studio, as actually for the other pre-diploma that were with us today. And so we know the way you work, and I think you really have a talent for pointing out contemporary brief. So I think this was the case with your master design studio, is again the case with the proposal that you bring forward for the pre-diploma. On the other end, I think you should not rely simply on that, because you should, I think in a way, the master design studio fall a little bit short on relying on that and not developing enough a design scenario. So it's really important, as all the other three comments were pointing out, that we pinpoint a clear design scenario from within which the thesis is working at the moment. The drawing you have are quite elegant. They have a certain language. They work with your diagrammatic language and with the theory. Still, I don't think they are a convincing proposal at the moment. I think the proposal in terms of design need to be framed more. Is it enough to think that we will have a virtual landscape that we interact with and that is a representation of certain parameters that we cannot directly map physically or materially? What is the framework? We will all meet in much more precise, to the point of maybe becoming boring, that I think you need to have a much more precise framework, then we zoom out again. So are we talking about a design scenario whereas there is a, I don't know, a virtual landscape that is generated by our emotion and become our representation? Like, for example, one aspect that I found disconcerting where I meet in virtual reality, and we were in some of the project before in virtual reality, is that I cannot read facial expression. So I get a little bit disconcerted because when I speak to people, although they have their own avatar and they choose their own avatar, I can't really read any facial movement at all, and therefore any reaction from the other side. This, when I'm in virtual reality, disconcerts me completely, because probably in the way I communicate, I give quite a lot of relevance to that. Is this part of the landscape you are investigating, or you're tuning more toward an aspect of augmentation of the material reality we are in? So we are now talking about parameter that maybe is not so easy to visualize, both related to the person, but could also be related to the environment. So are we talking about the fact that there is a form of synthetic landscape augmenting the material landscape that surrounds us, that we can design and becomes for us a way of communicating? This could be also a very contemporary topic in a moment in which jury happen all virtually, conference happen all virtually, and there is a shift in the way we introduce ourselves to the world. So being part of an event is not only discussing the content of the event, it's been for a long time also being part of a physical space, exchanging physically with others. If this exchange is not there, what other response can design provide? And I'm still convinced that Zoom is not the response. There needs something that have a different dimension to it. So I think here in what we discussed, there are at least 3 to 5 briefs that have been proposed by us. I think you need to work much more energetically and top down in trying to create a scenario yourself, even a brutal one. And then from there, we zoom out again.
Okay, thank you.
Thank you.
Thank you, Robert. I don't know if there is enough time for me to have a comment also, but I'll try to be very short. You made quite a nice step since I saw your presentation last time, but even though I was still missing some beats, just connecting to what Claude and Maria was saying, you know, need to be a bit more specific in the proposal that you are making. I'm really appreciating that you are making a proposal here, but I'm very confused with what we are seeing on the screen right now in this slide, for example, because as Claudia was saying, are we designing through the observation some kind of synthetic landscape, or as Maria was saying, are we moving through space and experiencing in space and the screen is displaying, no? Or something else? Because when I'm sitting in front of a display screen that is visualizing me, what is inside of me, or what I'm thinking, or what I'm experiencing, then we need to be very specific on what is this good for, you know, or is it just the visualization? Say, oh, I'm able to visualize what is inside by visual language, good, but then am I supposed to also read what it's saying? Am I supposed to be able to recognize that this screen is actually telling me that I'm angry when I'm actually not really feeling that way? You know, like there, these are all interesting moments where you can start to try to figure out what you are actually going to achieve, or what you are trying to achieve, or what kind of experiment you want to set up in order to move on and create some kind of conclusion in order to move on with that conclusion. I'm trying to be quick. Thanks.
Okay, thank you.
Thank you. Anybody else wants to add something? Stefan, if you...
Just really
Sabrina,
quick,
yeah, sure.
sorry. Because I actually really like it how the three sensors are kind of translating into the 3 dimensions. But as Anna-Rita was already saying, I don't want to repeat too much, but that right now it was just missing then that you're kind of looking at a blank screen and this is the output you get from your emotions, like looking at different places. Maybe it just missed it, that you're looking at a blank mesh, right? Like there's no input image that you're looking at.
No, there's no input image.
Okay, because if it's like this, I could think it's like really interesting if there's like a different images that trigger maybe different emotions. And then when you have like a real big data set of different shapes, which are kind of abstract, but you can still kind of compare them. If you have like an image of a war scene or children dying or something, it's probably gonna be a completely different shape than if you look like at a really pleasing landscape or something. So if you have like a lot of those, maybe you can find like relationships between them, and this could be the way how you read it, because I think it's really nice like this, just having it as an abstract virtual environment, kind of.
Yeah, but actually, sorry, no, go for it, go for it.
Okay, yeah, so yeah, this was just really about the visualization, how the sensors work together. And like a radical scenario would be that you link it up if you have a conversation and you have a large data set in the background and you press them like into the point cloud and you get the shapes and the contours of them. But I will come up for sure with a radical scenario, because otherwise it won't develop that much. But for me now, it was just about getting the data from the physical body into a mesh or into a geometry. And then, yes, that's a step so far. So Marco.
I just wanted to add about that in a way, you know, even like the kind of example you had at the beginning that seemed to be quite trivial now, of like this Photoshop of a kind of traditional facade with and without a window, right? And in a way, I thought that maybe actually that's in its simplicity, it's quite interesting, because it kind of introduces an instrument for kind of altering or manipulating like a kind of classical order. And, you know, if you would like, you could think of this as something that grows into resolution somehow and in a kind of level of detail, so that basically rather than just being a window on or a window off, you know, like it could actually become, you know, be altered on a much more granular level in a way, and begin to create level of details that operates, you know, at different levels. And, you know, this could also be an interesting point of view, in a sense, like to take maybe actually examples from known architectural orders or kind of a facade organizational patterns, and then kind of submit them to this test and kind of alter them through this sort of a feedback loop, and see what kind of reaction these produces. So in a way, like kind of a almost bring back architecture in its most kind of a traditional compositional form, but then subject it through this sort of iterative process, see what it does, what it creates.
It's interesting. Yeah.
It's just an idea, but
yeah.
Okay, maybe just a last quick comment. Hi, Robert. I think you have a really nice visual presentation done, and I think it's a very good scaffold, a very good approach for further design work. By now, I think it's more analytical tool, which is really intriguing and impressing somehow to this point. But I also see the danger of the circular reasoning at this point. That you are in a circulus vitiosus. It's a circle which isn't fed by alternative sources somehow, and I think it's very much orientated on a visual approach. You decided between language and design in the beginning, so I think this is way more complex and way more connected to each other, these influences as well.
Okay.
But you also have good references. It's really very promising, I think.
Okay, thank you.
Thank you very much, everybody, for the comments. Thank you, Robert, for the great presentation. I would propose to move to the next theory presentations and invite to present Mahira and Maya.
Mahira, if you can start and share your screen.
Yeah, just a second. Can you see my screen?
Yes.
Okay, perfect. So, hello everyone. My name is Mahira, and today I'm going to talk about fractals and fractal architecture, or more precisely about recognition of the role of nature in the formation of fractal architecture. So the research methodology and the main areas of the research include chaos theory, form, geometry, nature, and fractal architecture, but mainly understanding of the fundamentals of fractal theory to discuss how the knowledge of fractals have contributed to architecture. So we commonly recognize when shapes demonstrated symmetry under the three familiar transformations of reflection, rotation, and translation, but fractals demonstrated also a fourth type of symmetry. They possess self-similarity, as we can also see on Sierpinski gasket. We recognize when shapes demonstrated symmetry under the three Can you hear me? Transformations of reflection, rotation, and translation. But
we can hear yourself in the background without you speaking.
There is another you.
There is another you.
Okay, what's going on?
That's
here another you is 30 seconds later.
Maybe it's YouTube streaming.
My internet connection is always too bad. Okay, I will try to fix it. Okay, so I would start with term of fractal. Fractals are mathematical shapes that are made up of never-ending patterns that repeats itself at different scales. Okay, so within the postmodern understanding of the centrality of space, it's now possible to discern new developments that reflect both the contradictory tensions of globalization and the obsession with theories of chaos. But nowhere are these changes more acutely revealed than in fractal, which is no longer shaped by the linear mapping of modernity. Can you hear me?
Yes.
Okay, so since ancient times, the fractal world had a strong influence with architecture, and one of the most striking examples of fractal architecture are the Boulois settlements of Zambia. Fractality as a concept in urban pattern design today refers to the tech of the desired characteristic of urban pattern and its repetition with greater distortion for better adaptation to existing environment. And also when applying fractals to cities, they are not interested in zooming in forever and ever. There is also a smallest unit, which is a city block, and the fractal will grow out of this, more like a tree in how it starts at the trunk. So here we can see how street networks exhibiting complexity through grain, also connectivity and permeability. So left is California, in the center Rome, and right is Dubai. So, how we can apply fractal patterns in building structures. So there are many other techniques that are present like in Hindu temples to achieve greater visual complexity in expressing the idea of multiplication and growth. And for example, here, Gaudi was one of the earliest to employ tree-like columns, which were fractal in principle, not formally known as a fractal back then. So, and also here, 15 rows windows from Gothic cathedrals like in Milan. So it's using also fractal geometry to provide them propulsion. One of the finest fractal column design can be seen also at the Stuttgart airport on the fractal columns. Actually the human fascination by fractal geometry and technological developments of the time led to a new rebirth for contemporary fractal architecture. The new element that has brought major changes in fractal architecture and in architecture in general is the digital computation and parametric design. Yes, so so Museum de Loire, the dome unites this microcity and takes up the Islamic tradition of the perforated screen and the use of self-similarity and fractal organization of patterning to create a special microclimate below. So here, some study of the initial duplication of the fractal pattern and some fractal patterns studies. And some of the late projects in the Fractal Pavilion built in 2006 And another strong application that this type of architecture has had are the pavilions, in which students and designers is explored the potential of wood within architecture. So here we can see Fractal Forest Pavilion in Milan, so the Fractal Forest Pavilion was installed in international exhibition in Milan. The challenge of composing the story was done by using two different mathematical design, like algorithms and fractals. Algorithms helped us to represent the growth, and fractals represent the nature, so like the forest by tree branches. So here are some examples of from Michael Hansmeyer. He first designed his ornamented columns using algorithms. Can you hear me?
Yes, yes, just speed up and conclude, please. We are running out of time.
Okay, so some examples of Michael Hansmeyer. Here's some design from Michael Young. 6 forms that repeating 6 times. And yeah, so also thanks to the development in the technological field, we have seen how it's been possible to design and build almost unimaginable, like inspirations to 3D printers. We have seen how fractal architecture is an extremely various theme, and its bipolarity between the nature and the mathematical universe. I think that's it, yeah.
Thank you, Mahira. We will have next Maya. Can you please stop sharing your screen, and we will right after you see a presentation of Maya, and then we will have a short discussion. Maya, are you there?
Yes, I'm there. Just wanted to open first. Do you hear me?
Yes, and please try to be 6, maximum 7 minutes long.
Yes, yes. All right. Okay, so I'm Maya Wolf, and I will talk about the process of crystallization in the following presentation. We all know different kinds of crystals which can exist in different sizes and from different materials, from caves of selenite crystals with a diameter up to 2 meters until the observable small size of snow crystals. But what is a crystal actually? A crystal is a composition of a large quantity of unit cells that link over a time. A unit cell is based on the geometrical constraint that it fills a space completely by joining the same shape together by only translation along its 3 spatial directions. As outcome of this, there exist 7 parallel pipette shapes that can build up the crystal system. From these crystal system resolve 7 different crystal lattices. These can be understood as extensive properties, as the crystal system depends on the molecules that are involved. I want to explain this further on the example of water. The extensive properties of water include that it consists of 2 H molecules and 1 O molecule that form an angle of 120 degrees with a diameter of approximately 0.28 nanometers. Due to that angle of 120 degrees, water arranges in a hexagonal lattice. Looking at a hexagonal cell, we can perceive that it has 6 horizontal prism phase connections and only 2 vertical basal phase connections. The horizontal growth direction is therefore favored. This is the reason why a snow crystal mostly grows as a thin plate. Having a closer look on how snow crystals grow, I want to explain this contaminational growth on a two-dimensional basis. Starting off with the hexagonal grid, every cell gets a starting value rho, which corresponds to the diffusion mass value. In the next step, a seed cell with a boundary mass value of 1 is added. This can be understood as a contamination particle triggering the dispersal. The next step displays the diffusion of water vapor between the cells by blurring the diffusion mass values. In the three-dimensional approach, this blurring would be weaker for the vertical cells as it has less connections. In the following, the boundary cells are freezing to the seed cell, which is displayed by adding a constant kappa. Thereafter, cells with a diffusion mass value bigger than beta 1 in this case are attached to the ice cell and turn into ice as well. As a result of former steps as chemical reactions, heat is produced, which melts the boundary cells. Due to this, value decreases slightly by mu. In order for snow crystal to grow, these steps of diffusion, freezing, attachment, and melting are constantly repeated. The variables introduced in this approach of crystallization can be understood as intensive properties predominating during the process of growth. Due to these in nature changing circumstances, saturation, pressure, temperature, and air movement, we get an infinite variation of snow crystals. A possible growth for fern dendrite snow crystal could look like that if it would be growing under fixed circumstances. This is the snow crystal until a radius of 30. If we would look at bigger snow crystal with the same values, it could look like this at a radius of 400 nanometers. Making the switch towards architecture, we can realize that there are keywords connecting architecture and crystallization, like for example, growth, shape, and properties. The research project from Archiflakes from Cosmos Architects compares architecture to snow crystals as both aren't everlasting. They understand a city as a growing system that depends on different properties and can therefore variate just like snow crystals do.
Maya, speed up a little bit.
All right. The snow crystal tower from Lava Architects is inspired by the shape of snow crystals. They integrated those natural patterns of organization in order to provide a good sunlight exposure for the housing units. Lava Architects concentrate on the shape of snow crystals as base for the floor plans, using the convexity of its shape to structure the building. The project Jardin Fluviaux in the city of Orléans from ECOlogical Studio proposes an installation on a bridge in order to display multiple natural incidents happening in and on the Loire River. This project is connected very closely to the predominating natural circumstances, the microclimatic effects on the river and its fast-changing vegetations and the riverbed consist of complex dynamics, as well as the river is very unpredictable and fluctuates dramatically. By installing a computational generated grid in this area, it will serve as a sieve displaying the effect of aggregation of different materials such as soil particles or ice crystal creation during cold periods. The project Jardin Fluviaux is based on the former prototype project BioReclaim from ECOlogical Studio. Here, biorock is used as an organism in prototype experiments. Through the electroaccumulation of minerals, biorock generates a bone-similar material. The proposal is to plant a seed cell and an architectural intervention into a system in order to shape the element by the context of its circumstances. Due to the changing circumstances, biorock material grows differently. These two projects concentrate on the natural circumstances as they try to incorporate the process of crystallization growth, which strongly depends on the predominating intensive properties. To conclude, we can notice that architecture evolved from copying crystallization to integrating it into design and creating a synthetic landscape that is formed by a growth of a material guided by architectural intervention. Thank you for your attention.
Thank you, Maya. We can now open for a short discussion. Maybe you can keep some kind of image in the background.
Yes.
Yeah, these two presentations, I think it's quite lovely to see them one after the other in a way, because they are almost like a kind of logical continuation one of the other. I think that the first excursus on the concept of fractal and fractal dimension, it's a kind of a really good premises to the second in a way as an example of that. I know it was this was focused on the idea of crystallization, but effectively it is very much an exploration of fractal dimensions in the process of formation of the crystals. You can discover that and see that quite clearly. And I think especially I appreciate in this second presentation the underlining of the let's say effect of this concept once it is understood as a kind of process taking place within a certain milieu or a certain environment. And in that sense, the conditions of the environment determine often the outcome of the process. So it's a kind of non-linear process. But on the other hand, also the dimensional value, let's say, of the fractal form has a very direct consequence or relationship to the process itself. For example, if you look at biorock formation, the fact that the actual surface corrugation of the fractal morphology compared to its volume, it's very high, creates a possibility for a certain type of exchange, with the medium surrounding the morphology. Then it doesn't happen if the morphology itself it's more simple and homogeneous, therefore has a different fractal dimension. So in that sense, I think there is a direct relationship or correlation between the more mathematical concept and the actual process when you observe this into a landscape or into a kind of also synthetic landscape or induced kind of landscape. So in that sense, maybe the only extra comment I would say is maybe refer to the first presentation of Mahira, that it would be good to refer it back a little bit more directly to these elements of landscape as well as the architecture one, and maybe try to highlight how the fractal dimension is not only observable from the formal point of view, but actually the mathematical idea of the fractal dimension has a direct implication in the way systems, for example, behave in the landscape. So the whole idea, for instance, that the coastline of a country, cannot be essentially measured. If you keep zooming in, you will find more and more fractal articulation and dimension to it. It's an interesting notion that, for instance, could be evidenced. And in that sense, again, connect back to some of the idea we were discussing today of a certain necessity to expand notions of boundary, border, etc., to highlight the real nature of some of these conditions when it comes to the landscape. So the mathematical concept of fractal dimension helps uncovering this, especially when we are talking in between, let's say, the 2D, 3D world, which is often the case for architects, and the possibility to find dimensions in between those through a mathematical definition can become actually very interesting in terms of the repercussion it has to the conversation in architecture. All of a sudden, there is a world of possibilities that opens up in between the classical distinction between, line, surface, volume, 1, 2, 3D, when you discover that actually there can be something as a 2.38D. And, what does it mean in the real world?
Maybe I jump in. I just wanted to give some suggestion to the students when you are opening some theoretical statements that we are investigating, not exactly as a theorist or not as a philosopher, but more as a designers. I think that we need to find our personal way how to create a story, how to create your personal statement. And the strongest point for us, I think, is visual. So I would suggest to you in the future projects that you will be developing maybe in the similar courses of the theory, that you still focus not only on your statements, but also creating this visual storytelling through your presentation. Because you can create it very precisely, and then the aesthetics of your presentation will be creating the narrative. And I think that's two important parts which should support each other. Your visual with your narrative, creating one statement. Yeah. Thank you very much for your presentations.
Maybe in that sense, the Daniel's one before was a quite good example.
Yeah, I think Daniel one was a good Daniel one was a very good example in the sense of where we could aim also as a discussion for the next years. Because I think it's really, really important. We are here somehow setting the basis or the catalog of what a synthetic landscape is. But one crucial aspect of synthetic landscape is how design and visual language enter an ecological conversation. And I think the edge that really this theory course could have is not about necessarily deep in complex philosophical question, but rather in expressing philosophical question from the point, and theoretical question from the point of view of design. And therefore using very specific type of diagram, very specific point of view from which the images are taken to speculate on how these visual enable us to discuss the concept that you are discussing. I think this is a very important point to be brought forward.
Yeah, and maybe for example, even in the future, when you read an article, read a book, draw it. Draw a diagram of your reading. And it's also very easy for us. I think we all mainly perceive the information visually, like people who are working with the image, with the graphics, with the in the field of design, know that I think we perceive this information differently. And when you draw the text, that you will also highlight your own conclusions and the meanings that you are highlighting in the text. So it's very great instrument that we discovered, I think, in the work with the students. Okay, so should we move on? We still have a lot of students, but we actually running out of time completely because all our presentation is taking quite a lot of time. So we propose to do just one presentation of bachelor today because we're not handling two. And
I
Lucy,
want to comment properly because I think the bachelor did a very good work this term. So we will see another project today and 3 projects tomorrow. So we have 2 bachelor projects today and 3 tomorrow. Thank you, Maria. Sorry for interrupting.
Yeah, so Lucia and Arlene, we invite you to present your project today, and Marina and Cecile, we give you all our time and attention tomorrow, and also the rest of the students who didn't present today. Also Fabian and Felix, we didn't forget about your theory presentation, so everybody who didn't fit in our tight schedule today. Sorry about that. So, girls, we are waiting for the presentation.
So, hello everyone. The name of our project is Wood Wide Web. It focuses on the trees of the site and mycelium, which allows the trees to talk to each other, the talking trees. The task of the teaching event was to create a forest hut. The hut should be located near the ruin in Thole. The ruin is 812 meters above sea level and is situated on a slope of the Nordkette. To analyze the site, we chose a 60 by 60 meter area. In this square, we found a tree on site. Its location is marked with this red dot. The circle distinguishes the size of the crown.
The tree that we chose on site is a European beech. Its germination happens through squirrels and mouses. They bury the nuts in the soil where they sometimes forget them. And from this point, a new tree can grow. The roots of the beech are as big as the crown, which can shade up to 600 square meters of the ground. The roots also form symbiotic relationships with fungi and more specifically mycelium. In order to understand the European beech better, we made a 3D scan of it with photogrammetry. For this, we scanned the bottom part of the tree on site. The result was this point cloud. Here is a detail of the root section. We also produced a matrix to show the complexity of its 3-dimensionality. And with this point cloud, we also conducted, and with a shortest walk algorithm, we conducted those root-like structures. Again, we have the root section, but this time with the shortest walk algorithm and also the matrix with the shortest walk algorithm.
Now to the deadwood, which is the end product of a decomposted tree. It is a biotope for insects and fungi. In this process, from tree to deadwood, organic matter is decomposed to humus. CO2 and H2O are emitted. Here is also a front picture of the point cloud. Again, a detail of it and the matrix. And also with the shortest walk algorithm. A big part in the mineralization process of deadwood plays mycelium. Mycelium is a network of roots that derive from mushrooms upperground. The mushroom, the fruiting body, produces spores, and if they germinate, they will become mycelium. Mycelium not only plays a part at the end of a tree's life, but also during a tree's life. Underneath the ground, mycelium forms a vast and connected network that links the trees through their root system. These tree fungi relationships, called mycorrhiza, connect the trees in the forest together, forming an underground communication network to exchange water and nutrients, to nurture their seedlings, and even send warning signals when under threat. This way, on average, one tree is connected to 47 others.
Now to our concept. We really like this idea of the trees and the mycelium working together, and we wanted to take it for our own. The first step was to localize the trees on site. The stems of the trees are highlighted
with those white dots that you can see in the second picture. We also added a ground study with the help of this satellite image. We did so to gain the information of the underground roots, which are the same size as the crown. This slide, the next slide, clarifies the size similarity of the crowns and the roots. We needed this information because the roots play an important role in finding the paths that the mycelium takes as it connects the trees with each other. Using the stem points and the algorithm, we created this mycelium network. We wanted to clarify on this slide that the mycelium doesn't just stop growing from root end to root end. It grows all over, and in a scale that the human eye is unable to take in. And now to our design. We wanted to create an installation that connects the trees. So basically the construction that emulates mycelium. And for that, we wanted to use the mycelium network that we just created and that we showed you. And we transformed it to a three-dimensional assembly.
From the top view, you can see that our structure is situated along the path. It integrates into the ruin and the landscape and also connects the trees on the side. The structure is meant to be an installation, simultaneously an observatory. The construction visualizes the mycelium network and creates awareness for a different type of communication. The idea is to use an organic substance that can be vaccinated with mycelium. The water that is transported by the mycelium is very beneficial for a bee's immune system, because if they drink this water, it reduces the possibility of a very common cause of death among bees, the deformed wing virus. It's basically a vaccination for bees. So to sum up, our construction can help the bee to survive as it provides them with a stronger immune system, but it also allows humans to understand this vast and often unknown form of communication. Thank you for your attention.
Thank you.
Thank you very much for the presentation. I think it's some impressive work. I really love the visual, and in general, I'm very impressed by the whole bachelor studio that you managed to achieve this quality of work. And it's really great that you are targeting not only the for example, technical development, or the drawings, but you're also going to the narrative, and the narrative is very well curated. Maybe it would be great to see the more relation with the surrounding environment of your proposal. That's what I was probably hoping to see at the end when you, for example, were showing your first scans. You were more not focused only on the structure of the bush, for example, or the tree. You're scanning like a root system, if I'm not mistaken, or some part of the environment. And I was hoping to find this relation of your structure now with environment, which is a bit of undeveloped. But otherwise, I think that's a beautiful work, and congratulations for the project. I would invite everybody to comment.
Yeah, can I see again the tree that you scanned before? It's like really quite a beautiful system, and if you could just show me that image again, because it was really spectacular.
Do you want to see the beach or the deadwood?
Well, actually both. I mean, this is very intriguing also.
Mm-hmm.
If you just go back to this one, yeah, both. The close-up, exactly. I mean, this is really great when because I mean, something that I found really a bit of a pity here, again, work, it's exceptional, especially for bachelor level, there's no doubt about it. But I think, all of a sudden, there is so much detail here. And, like we could keep zooming in and exploring. And in a way, I like when it's sort of filling up the screen, right? So there is no kind of black background left. And so we are really kind of immersing ourselves into this 3D scanned world. And again, one of the cool things about 3D scanning is that you are kind of operating almost across the kind of two worlds. One is that is extremely abstract, no? Because you are back to a collection of points, the most minimal way to capture a morphology or a piece of landscape, in your case. But on the other hand, there are informations attached to it, like color, for example, which when looked at together, of course, have a kind of a materiality to them, no? Which is a kind of perceivable. So you can really play across these two worlds. And in a sense, you are already kind of expressing this idea of a synthetic landscape in this ability that you have to capture these two aspects. And then, of course, it's fantastic when you start using these as a way of a kind of reconstructing a system of fibers, no, or a system of, let's say, paths of communication, which in your case may be not just material communication, but also a form of informational communication. No, you're talking about the wood web, you're talking about, conversations occurring, communications occurring between plants. So again, you are representing this piece of landscape as a kind of bundle of fibers that communicate information. Maybe pretty similar, although of a completely different nature to, the fiber optics, for example, that are, bundling our cities together, connecting the web of our cities. So in that, I think you already are building up a language for a new kind of architecture that is very much, let's say, the interpenetration of landscape, material, biological organisms, and informational systems, right? And that's for me, it's really the highlight of the project, in a sense that is already there, is drawn, is beautiful to look at. I wish we could explore it a little bit more, just dive in and kind of translate it into the final proposal with a little more consistency. At some point there is almost like a jump, and this kind of is left behind a little bit in terms of, not in terms of concept, because the concept is coherent, but more as a language, really, as a kind of a visual and design language. That's I think the main element. I think otherwise the rest is beautiful. Also the concept, I love the way it kind of brings together the different trees of the site. So it's almost like creating a reading of the site that is a kind of very innovative and I think that's really exceptional for the level of the course, for sure.
Thank you so much.
Yeah.
If I may, sorry, excuse me.
No, go, Stefan, go.
Just a brief comment. Congratulations to this result. At any rate, it's really very beautiful. And we've been talking about bit today in another contribution. And we didn't talk about the bit rate. And that means that everything that is digital has very high restrictions, because the bit rate, if you look at the early times of MP3 files, they have been that the sound was very poor because the bit rate was very low. Today that is much better, it has improved very much. But what I want to say is that what I am seeing here at within that picture, this is a biocomputer. This network of mycelium. This is a biocomputer without a low bitrate. It has a very, very high bitrate. We could probably say it is a it is an infinite bitrate, and maybe we don't understand the entire possibilities of these networks today, but I see there must be incredible potential if we once understand this potential one day, and it's visualized very, very, very well in this image in this laser scan, in this 3D scan.
Yeah, I just want to add a note from my side because I mean, I really enjoyed working with you too. I think that your project developed into something that has I think your project is particularly good because you really understood the value of an architectural narrative. I mean, and that really elevated completely the project. And by making that step, really kind of the project was driven into something that is, I think overall you managed to do something quite beautiful and with a strong message, which I think it's lovely, particularly at this level of study. If we had another 2 months to go, I would probably torture you and ask you to kind of, kill yourself with your little laptop and have much more complexity. And we have seen just before you this presentation about fractals. And I think this is a concept that when we look at this specific perhaps organization, you can start to see that coming through at the different scales, no? And so, and that's perhaps what the visualization, the way you represent your concept is a bit missing, obviously. And I know that you are aware of this, and so like that's probably like. But I think you did like an amazing work on developing like skills, and it's all like I'm glad that you have built them now, and that you have as well this sensibility, and so you have like your learning experience was very much, I think, also aesthetical, because I remember your first sketches to what you have now, and I think that's a massive achievement. So well done, really. Thank you.
There is who was intervening here? Lisa.
I'm sorry.
I can go to the conclusion. Go for it.
Okay, I just wanted to say congratulations to you guys. You did a great progress through this semester. And I really like your drawings at the end, because this is the first time I'm seeing them now as finished drawings. And I just wanted to add to Stefan's comment something that's really interesting here, because those trees are passing data from one to another, and you're extracting that data by making this kind of structure which the data is flowing through. So this could be something really interesting for scientists as well, not just visitors to this site, to work on that, to study like how those trees are processing that data and what data is going through. So I just think of it as a bit of a lab as well, and not just the structure and the viewing point. That's just what I wanted to say.
Okay, Claudia, I think now you have a right to say a chance.
No, just Marco came here telling me what the project can do next. So like we're continuing the conversation off because nobody was listening to me anyway. So, okay, no, thanks for the comment. I think the project has got a very good narrative, as it was underlined before, and I like the fact that you look into the connection between different systems. Our next step will be, if you carry on the project or the technique, I also see your second year, so this is an opportunity, because I see a project in the portfolio as a way of, through the year, crafting your own method and your own portfolio. So, exams are not just about getting a grade. Actually, for me, the grade is quite secondary. Probably as professor, I'm not sure if I'm supposed to say that, but I don't think the grade is the main aspect of the project. The main aspect of the project is the project itself, is how you are able to learn from a tutor, but also to reappropriate certain element of what is a brief and what is a technique. And now through the year, first year, second year, third year, and finally to the thesis, we're able then to propose your own take on what has been taught to you or what has been discussed with you from your design tutor. So in that sense, definitely this image or some of these images have probably more to say and something that is worth considering if you are interested in this type of brief developing further. So how do we work with this amount of color? I mean, I usually in drawing start from very abstract color, because when we work with computation, working with color is not so easy, it's quite challenging. But in this drawing, we have color that are somehow emergent and representative of information. So this is a very good starting point to try and understand how project can retain this information and bring it forward. I know it's a methodological challenge, and the reason why somehow the faculty here is also working with teaching as a research is that we open up the question to you. We don't have a univocal solution to this, but it's a challenge that we are all facing on how do we relate natural and artificial system, and which kind of technique we use to represent them and modify, evolve our relationship with them by using information, but information that becomes also visual language. And here I think there is a key to resolve that, a key that you started you attempted to resolve. I think is very successful on a brief level, is accomplished for a second year on design level, but I think there is more that can be said on this translation from the abstract mapping information to the design solution. And I wish some of you will bring forward and investigate this forward in a future project. As Latin said, repetita juvent, not only rapid in Latin, also deluse, so it's okay. Okay, thank you. That was my comment. Do we have other comment on this project? Or the student want to say something?
I think we're good. Thank you.
Thank you. So I think it's been a very good day. I don't remember who proposed to have the jury all together, but I think that was a very good proposal. It worked out very well. And I think it was inspiring to see projects of different kind, different level and approach. Some are more tested methodology, some are more explorative, some maybe need some tuning, but somehow seeing them all together allow us to discuss how we bring the work forward. And it's really not simply about evaluating the project, but it's really about evolving what we want to say in terms of design and approach to design. Thanks to all the students and to all the faculty. And I guess we'll see you tomorrow on the same link. Correct, Maria? I don't know if you...
Yeah, thank you very much for the presentations, and thank you very much for all the comments. It has been a great day, long but really enjoyable. Absolutely agree with Claudia. That's a great idea to present together. I also think that, I hope that all the students enjoy seeing presentations of other, and I think that's like you support each other and we all create together our narrative, and yeah, we all work in the same direction. So that's very interesting to correlate projects between different groups. So thanks a lot, and thank you for all the faculty for amazing work. But yeah, we continue tomorrow, same time, same link, 10 a.m. Innsbruck time. So please join us here, all the students and everybody who's following us on YouTube now. Please connect same place on YouTube channel. We will be streamlining it as well.
Bye.
Bye.
See you tomorrow.
So we are live. Welcome back to the second day of the Synthetic Landscape Lab Super Crit. Thanks a lot to all the faculty and guests that have been joining us and we have been introducing yesterday. Thanks a lot also to all the students that have been investigating synthetic landscape on multiple levels, from design to theory, from initial part of their curriculum to the final moment. So I think we can start again. As usually we start from the VR room. Maria has got the schedule. Maria, we can start. Thank you.
Thank you, Claudia. Yes, we are glad to start. We invite you to join our first presentation in the Mozilla Hub rooms. First presentation will be run by Peter. Peter, I would kindly ask you to share the link to the room also here in the chat, that everybody can start loading the room. I propose to do the same as we did yesterday. Let's enter to the hub room. We travel there, we navigate, we see each other, but we keep the voice in the Zoom. So we could be recording it and streaming it as well. Kilian, may I ask you to share your screen while you'll be walking in the virtual room, so we could also see this trip via Zoom. So let's start loading and see you in Mozilla Hub. So
okay, so hello everybody. Welcome to my room. So you are now in the year 2053, and here was once the small village of the Schweiger located. It lies at an altitude of 864 meters above sea level in the Bavarian Alps. Today I would like to take you on a virtual journey through the region. Thereby, I will always stop briefly at the marked sites. There, I will tell you a bit about the landscape, how it could change so quickly, and how we try to protect it from the decay. For a better understanding of scale, the surrounding grid with a square of 25 meters gives you a little bit of a scale relation. So let's start at the beginning. Due to the once beautiful landscape and the pure mountain air that surrounded the village, people from all over the world came here to enjoy this quietness. Quickly, these qualities were used to make money, and so there were soon huge luxury hotels everywhere. The surrounding landscape was soon characterized by golf courses, outdoor pools, cross-country skiing trails, hiking, biking routes, countless vacation homes, and of course, huge ski resorts. If you look around, you will see the ruins of the village. The ground here is colored in addition to the slope of the terrain. If you look up, you can see how the place looked like in former times. If you now turn your attention in the direction of the mountains, you will see the Schweiger Horn directly in front of you. And next to it, the slightly higher peak, the Siegeswanger Horn. Each year, artificial snow was produced here over the length of 15,000 meters. That was the longest snowmaking system in Germany. Such large projects were made possible because they were heavily supported by the government. Also in front of you, a little bit at the right, you can discover the old valley station of the global ski resort. The local ski resort, sorry. The so-called World Cup Express. Let's walk there, follow the old cable car and meet again at the marked waypoint 1 to continue my narrative there. So you can press G to fly, or if you want, you can also walk to the first waypoint.
We're here.
Yeah. Is everybody there? Okay. So unstoppable, the romantic mountain scenery turned into crowded mountains and lots of traffic. The managers of the facilities had to do even more interventions in nature to be able to handle the rising number of tourists. In 1999, this mountain was equipped with a 6-seater and a 4-seater chairlift. And due to the snowmaking systems, it became possible to welcome ski tourists not only in winter, but also in autumn and spring. Every day during the winter, heavy machinery was used to groom the 17 kilometers of slopes. When these heavy vehicles drive over the track, they flatten the snow cover. As a result, the snow and the ground below becomes compacted. The plants can no longer breathe and begin to rot and die. Among other things, this has also greatly boosted the erosion here. To make even wider and longer slopes possible, large areas of forest were cut down, mountain slopes were blown up to connect ski resorts, and the ground has been heavily compacted by inappropriate use. These problems were intensified when the consequences of the climate change became apparent. Previously, there was constant cold and wet mountain climate, but today there are long periods of heat followed by equally heavy rainfalls. Normally, the humus soil found here can absorb and store a lot of water, but due to the compaction of the soil, water can no longer be stored. It collects on the surface and flows down to the mountain at high speeds. The blue lines here on the ground show their path. Deep furrows have been drawn in the landscape. The more water, the steeper the slope, the deeper the water can dig into the ground. Here you can see what happens when such watercourses are connecting. Since the trees are also gone and the sun can strongly heat the surface, the dry soil is easily washed away. Around you, you can see the result of an analysis of the landscape. Here, the areas of the high slope and the places where several water streams meet were extracted. The squares represent the slope, and their size is proportional to the percentage of the slope at that position. The collection of circles show the places where a high density of water flows. The radius is the distance to their nearest neighbor. So when the high slope areas come together with a high density of water flows, the potential of erosion is maximized. In the past, however, not only the humus soil stored water, but also a variety of flora and fauna. Unfortunately, this biodiversity could not withstand the change in climate, inappropriate use of the ground, and deforestation. I have therefore used the information of my analysis to find and protect the most sensitive areas of the mountain. With the help of a special scaffold and microorganisms, the soil should be supported and stabilized. So please follow me to the second waypoint. Attention, where we will dive below the ground and meet again at the waypoint 3, below the surface. So just follow me that you come on to. So in order to dive here, you have to press G to go in the flight mode, and then you can go at waypoint 2 under the ground, and then you see the third waypoint right in front of you. So, as you can see, a simple scaffold was created which reaches down to the rock layer, whereby its density changes in different places. The soil in this area around the artificial framework was also inoculated with a specially cultivated mycorrhiza fungus. This kind of fungus was used already in the past to save fertilizer in agriculture and make the harvest more profitable. Also, in earlier forests, the mycorrhiza fungus existed naturally, connecting the roots of all trees. This gave them better access to nutrients and water, and the fungus gets proteins and sugar through the photosynthesis. In addition, of course, the soil was stabilized and glued by a fine network of mycelium. Therefore, we have taken advantage of these benefits. Here, straight ahead, you can see the dense mycelium network in the lower layers of the earth. There it stabilizes the soil and transports water and nutrients, which only exists in the deeper layers of the soil. If you look at the artificial scaffold, you will see that its density increases towards the surface of the soil. This is supposed to better stop small landslides and also to slow down the store surface water. Please follow the blue lines now into the metal scaffold until you see the next mark. So just follow this blue line I dropped there. And then it's a bit difficult because so you can stay under the ground or you can put your head above, then you are between the scaffold. So from here, you can see again several spots where the flowing water, So the surface water that is produced by heavy rain is led into the grid until the density of the water lines is maximized. Then the collected water flow is slowed down by the more dense areas of the scaffold. So the water is able to seep into the ground or to be absorbed by the mycorrhiza. At this point, the mycorrhiza is connected to the dense framework. With the help of a pipe system filled with substrate, the fungus is able to leave the ground and connect the artificial leaves on top of the construction. If you now follow the blue lines further, you can notice where the water flow is slowed down. This also where most of the connections between the pipe system and the mycelium take place. So let's meet outside at waypoint 5, and you can take a look below the surface and up to the surface. So from here, you can see again several spots where the flowing water is slowed down. You can also see that the pipe systems connects there and leads the mycorrhiza to the upper layer of the scaffold. The three main causes of erosion are the forces of wind, water, and sun, which are fully effective due to the missing forest. A solar analysis showed that this side of the mountain is highly exposed to the sun. And so, as I mentioned, the erosion process would be a lot faster. So the other end of the pipe system is connected to a large number of artificial leaves made of silk fibers filled with chloroplasts. These clean the air and produce energy for the fungus, and the fungus brings the necessary water and nutrients. In addition, the artificial leaves are precisely positioned to provide shade to the steepest areas of the site, giving the soil perfect conditions to renaturalize. So thank you very much for your attention, and take a look around on your own now. We will meet again on the peak of the Schwanger Horn for a final discussion. Thank you.
Thank
So
you.
if you go to the right, you also see the cable car, and if you follow the cable car, you will come to the Schwanger Horn as well.
Okay, we meet on the peak. Huh?
On the peak, yeah.
Okay.
Desert.
I like the way you talk about wandering around this landscape as if it was your home, which it is, in fact, I think. But it's interesting.
Yeah, I think you
it's
always
kind of
realize problems more if it is too late. So I found it interesting also from this perspective to see a problem that isn't there yet.
Yeah, no, I like the way in this case you use the VR as to create a narrative and then yeah, sort of inhabit it, no? And I think it's interesting to observe how this creates a shift in the way the project is presented compared to the most common narratives. It's really like a journey and a walk that we can do together and explore it, but also in this case a walk in time, no? And I think overall the aesthetic of the project in that sense is quite effective in kind of bringing you, or kind of bring to the attention what it might be, and the way you have used the data and information to basically simulate what it may be. I think it's good, it's credible. I mean, you can see the correlation between the different parameters and the way they affect the landscape, but then you can also inhabit this kind of a slightly dystopic landscape. I think it's in that sense it works quite well. But maybe I also let someone else to come up with their first impressions, and then I already commented a few times on this, so I don't want to take too much time out of the conversation.
Can I say something?
Yeah.
Good morning. First of all, I didn't have a chance to say good morning before.
Good morning, Matthias.
I have good morning to everyone.
Good morning.
Never seen the project before, so I had a bit of a struggle at the beginning. First of all, because imagine it's like this: if I go to a new city, I have no idea about the city if I haven't do research before. Okay, so I had to struggle to orient and to understand the project. So for me, it would have been great to have a small introduction to understand what is the project about before seeing this VR room and whole mountains with I mean, it's quite the VR room looks a bit complex to me. The only reference points is this 1, 2, 3, 4, 5, and you explained it, right? You explained where we should go and what happens there, but it might have helped me to understand beforehand, just to get an idea, an overview of the project, where it leads me and why, So I had a bit of struggle following you around because the virtual room was already complex for me. So while I was moving around and following you, I had some struggle following you, to understand what happens exactly. So yeah, that's all.
Okay, thank you.
I had a very similar problematic yesterday because I was also new in the VR, but it just takes a couple of moments to orient. And I have to say today, I also really enjoyed your project and the way you visualize the narrative and also the way you lead us through a narrative. I was also myself surprised that I was able to follow because the VR is very new for me too. And I'm always getting very excited or sort of half excited, half struggle when you say, now we turn to the right because I'm in the room. It's not 360 around me and everybody's looking somewhere else. But then it's incredible how we in the end meet and end up at the same place and find the spot. So in that way, I think your project was very well narrated, and I really enjoy the space, how you visualize the narrative, also in a way that it's not just me moving through the space, but we have this cloudscape, and then when we move down, we have this mycelium network, and we see the dynamic of the space itself also. So for me, that was very successful in that way, that I'm moving through a dynamic space already that is full of, let's say, intensive properties, ever-changing and dynamic.
Thank you. I tried my best to get an atmosphere like in dystopic atmosphere a little bit.
Yeah, I really enjoyed that. It's also quite a topic I like myself personally, but also in that way, I have to say it was very well crafted in the VR.
Thank you.
Well, I think there was a good presentation. There are a few elements. I couldn't meet you on the top because unfortunately my headset was out of energy, so I could just stay in the entry point and not move. But I will try again later. But despite these challenges, let's say, technical challenges in exploring virtual landscape, I think the proposal was well explained. There is something that it could have been evolved more. So the way you, well, you connect the narrative to the drawing and you represent a system. So you talk about mycelium and growth, but when immersed in the landscape, we also see a lot of grid, and probably the things that is more visible is the grid. Somebody took a photo. Good.
Not on purpose.
Okay, so the aspect that is probably more visible when you are immersed are these grid that are not completely in tune with the landscape. While when you speak, you always talk about the mycelium, the growth. So I would have explored a way to visualize or transform this growth in an experience more, so that we don't simply listen to the fact that there are elements growing and changing, but we experience them more. Of course, there is the fog element, but maybe there could be other elements that add to that experience and allow us through the immersion in the landscape to understand the project in a deeper manner, even without the explanation. Maria took photo as well now. It's a contagious.
How do you take a photo?
No, I was not supposed to take a photo. I just came close to this camera and photographed me.
Tourist in this landscape, I guess.
Good, yeah.
But can I just jump in real quick again?
Go for it. Yeah.
What I really liked is the idea with the water that is kind of running under the water, because it kind of seemed like kind of a glitch, that it's like you had to do the surface below to create these kind of rivers or flows, but then you kind of made use of it and just dove under the surface, which I thought was like really cool. So you can see what actually is happening below the surface with the mycelium network and so on. I think that was a really, really cool idea.
It's just not flowing in the right direction everywhere.
Well, that's probably not possible.
Yeah, I mean, obviously, it's crude, right? In many respects, and we knew that because it takes time to, and also there are limitations with the hub, etc. But I also agree that it was a really great way of making use of the possibilities of the platform and begin to uncover, for instance, these layers, the multiple layers, the water table, the rock, the soil, which these are the kind of, let's say, strata of the landscape that are often overlooked. But, actually, when you start talking about landscape in the way we are, they are critical, they are crucial. It's really a kind of a thick three-dimensional skin, the landscape as such. So again, I think the way you have that, absorb that into the narrative of your project and trying to articulate your project as your intervention as a system that operates across. It's very interesting, and again, it's still quite crude in a way, the way it's modeled, I would say, but at the same time, I appreciate the fact that you have done it, you built it into your narrative and the journey, so everyone, you know, got to dive in and through the various layers, and you could use that to describe the way your system, your scaffolding was operating across. I like the idea of the scaffolding too. I'm not entirely sure about the way it has been modeled in the end. I kind of feel like it should have been more part of the meshes that describes the surfaces in a way that should be more a materialization of this three-dimensional thick skin that the soil is, whereas at the moment still seems like it's kind of landed there somehow and it doesn't quite connect. But again, I know that you know, because I follow the evolution of the project, that you also went through several attempts and several tests, and you know, you have struggles on one side with the narrative development of the project, on the other side with the platform itself and its limitations. So, you know, I think again, this is a first experiment we're doing in this direction. I think it's very successful.
Yeah, and I think Peter in this process found a lot of really great instruments. I was just now, while taking photos, I was hanging around the room and looking into all elements that you introduced, the grid, this idea of the landscape, which is hanging there as a cloud, creating the feeling of the cloud, but at the same time, if you actually go there and you look from the top, you have very cool, like there's really great way to express and overlap information, you know, that you discover yourself. And I think there is also, like, what is the most important for me in these hub rooms probably is to create the narrative through the travel in the room. Now that, for example, a person who has never been there inside of this room could travel around and maybe not from the first point of view, but at a certain moment, understand the narrative, understand this topic, feeling that you're introducing, understanding what you actually want to propose there. And I think you achieve there, and that's a great achievement, and it's beautiful. I think that we need to work more on the idea of the ground, and when we are starting to introduce the structure, we have this, Marco was saying that maybe the proposal would look a bit different. I would agree with that. Maybe having more relation with analysis that you are doing, with this flow lines that you are drawing, and maybe I would imagine the proposal emerged from this surface of the ground and modifying the terrain itself rather than having this scaffold. But in any cases, I think even this scaffolding, it has quite a good resolution, and you develop it a lot. And I'm actually impressed about the work that you've done in the last 2 weeks, I think, if I'm not mistaken, or even a week. So congratulations for the presentation, and thank you very much for the work. I think that's very successful, and it's super. Thank you.
Thank you.
If I might just add, oh, sorry, Maria, you were close.
No, jump in.
Sorry, I just wanted to add that, like a note. I think I was very impressed by this project, and I tell you, I don't know if it's about, you know, it's not maybe perhaps like the little flaw that has been highlighted on the resolution of the scaffolding or the actual kind of design of this, of this element of the landscape. But I think it was very, very creative in the way they actually utilizes the media of presentation, and which is also a media of design. That's so experimental in that sense. Both as ambition of the course, and also particularly in this case, I thought it was particularly interesting. No? So there is this layer above that represents I understand what was there before, you know, the state of the art of the existing landscape, the analysis below, the substrata of the layer underground, and how the projects start to emerge out of this multi-layered reading of the landscape that is no more just like you know, a surface, but it becomes much more rich than that. So it's a real like informational landscape, right? Where every single data at every single point becomes like a representation of a much richer narrative. And so I thought in that way it was really interesting. And I think that's kind of allow for new possibility of conceptualization itself of the project. And there is this kind of a strong intermingling of the narrative, the project, and it's very, it sounds very, very exciting. I think perhaps like this project, more than the other, has kind of pushed this this way of making like an argument, a sort of, as I say, informational landscape itself. And I think in that sense, it's very, very interesting. So, I mean,
thank you. Thank you very much.
The image of the past in the sky in the middle of the fog, when you are with the Oculus and you are down there in this valley and you look up, it's quite interesting. It feels a bit like a kind of dream, no, or almost like this vision of the paradise that it was, and that is gone now. I mean, honestly, when you are in it, it actually comes across as quite powerful. A little bit less.
I hope that I maybe can try it soon at VR. Maybe I will get it.
It reminds me a little bit Bratton, no? The layering of the different layer, the nomos, and so on, the cloud and all of this. That I think when you think about it, I mean, it's criticized, no, his model, because exactly of this layering, because people do understand them as something very physical and stuck, as for the title. But I think this is a very good example of how much more, these layers can become something that is much more diversified, ubiquitous, and I think it's it's very, very, and atmospheric. Exactly, that's the word that I was looking for. Yeah, I'm sorry I didn't actually go in, so I had to look into from the others, because early in the morning I don't have a good connection. So I was like, no, so I had to look, I think, from Corbinian, I guess, view. But I thought it was very interesting and very creative.
I hope I went to all the important spots.
Yeah, thank you very much, everyone, for the comment. Thank you, Peter, for the presentation.
Just one little thing, Peter, it would be interesting, since obviously Mozilla Hub is a sharing platform, it would be interesting for you to organize a session with the local community or with the administrator of the village there, and see what they feel and think about it. Because again, the interesting thing about this is that now you have you have a virtual space where you can kind of invite people along, and so your project essentially is public, right? Is a part of the public domain, and especially in your case, it could be actually quite provocative, when you bring people that are actually attached to this territory, that live there, that have a feeling about this territory. And I think it could be also an interesting experiment for you to do, see what their reaction is to hold this.
Yeah, good idea. I had the same idea, because a friend of mine is forester there in the community, and I told him I have a project analyzing the landscape in this area, and he said, yeah, if I want to present my work afterwards in the community, but I think it's for these people it would be a little bit too utopic.
Let's see.
I mean, maybe I will
dismiss it. Some may dismiss it, but in some way, if the project works, some may actually get quite emotional or react and quite switched on about it. I don't know, but I mean, it's definitely. So I would be curious to see. But you need to bring them into the Oculus, huh?
Yeah. Thank you very much. We really need to move on.
Thank you for your comments.
Thank you, Peter. So I propose to stay in the virtual reality a bit longer, and I invite you to another project of our master students, Catherine and Melvin. I already shared with you a link to the hubs. Catherine and Melvin It's correct.
Maria, this is not the latest.
No?
No. At the moment, we have the theory in the current one that we discussed last night. We have Joy, Boulois, impurity, and Mirko Fantini catalyzing.
Oh.
Okay.
So if we are not changing the schedule, we should move on to theory course.
Okay, sorry, I just opened the document, which is probably, was not actualized. I'm sorry.
Joy is already sharing the
Either
screen,
way,
so
we are going to see everyone, I think.
Yeah, so guys, sorry for the confusion.
But before Joy will start, maybe for Matthias and anyone who haven't been there yesterday, I will just make a short introduction from the theory course, where each student was looking at a certain specific keyword. And we have created a sort of matrix of, I think, almost 16 different keywords through which we are working on something like a definition towards what a synthetic landscape is. So each student is working on the one piece of the puzzle. Joy, I will leave you space now for presentation.
Maybe it's also important to very quickly add that this is not meant to be PhD kind of theory. It's really about expanding the meaning of the words that we use in the studios and helping us unpack some of the concepts that underpin the project of the studio. So it's very much to be understood as an extension of the design and studio work, and as such it should be understood as such.
Thank you.
Okay, hello, can you see my screen?
Yes.
Yep. Okay, my name is Joy. I will present to you my theory course. My keyword is impurity, and the keyword is closely related to a keyword that we already saw yesterday. For example, the keyword contaminant. So the composition of air that we have today is omnipresent and crucial for life on Earth. It is a gas that we cannot see through a microscope, is the atmosphere of the Earth. And this is what I am most interested in. My main questions are, why today landscapes fail? Is humankind liable for global warming? And I have two hypotheses: impurities affect climate change and purities affect climate change. So first I want to explain to you something about human relationships to create a connection with our relationship with nature. I read the book Why Nations Fail to understand huge differences in human wealth and poverty. An exclusive government is corrupt, does not provide public services, and there is an absence of political rights. An inclusive institution, citizens have a voice in political direction, their country is stable. They are healthier, live longer, and have a law and order. And these two words I propose can be projected onto our relationship with nature. The distinction between exclusive and inclusive countries may sound bizarre, as it puts everything into black and white. What exactly is the border between exclusive and inclusive is hard to define, because different groups and individuals typically benefit from different economic institutions and also from different positions in time. And it's the same with the words purity and impurity in the atmosphere. But I try to find some answers in time. So I delve into the past to see which dynamics and compositions work good for our planet and which do not. I first analyze the energy balance. So without greenhouse gases, it would be -17 degrees, and with greenhouse gases, life for humans is allowed, so we have +14 degrees. My first diagram is about Earth's primitive atmosphere 4.6 billion years ago, and it was mostly consistent of hydrogen and helium, but the Earth's gravity was too weak to hold them, and particles were scattered into space by strong solar winds and a young active sun. My second diagram is showing another process called outgassing, where volcanoes gases got released from the planet's interior, and this is still important today as carbon has a closed cycle. My third diagram, with photosynthesizing bacteria, the first oxygen was produced on Earth that was first absorbed by iron, and a significant amount of oxygen appeared in the atmosphere as 2.2 billion years ago, and increased steadily until it reached stable oxygen levels 1.5 million years ago. This time span here now is closer to our time. it is counted in millions, and this one was counted in billions. So, and if you look at it properly, we can find 5 mass extinction within the last 500 million years. And due to the loss of biodiversity today, we could also put a line on today's day. Climate is not stable when viewed over long time spans. Also, Earth has experienced several back and forth shifts between warm and cold, and CO2 levels have been stable since the last mass extinction. And the temperature, as we know, is about 14 degrees. In pre-industrial atmosphere, clean dry air was 99% nitrogen and oxygen. And what is remarkable is that only this 1% is affecting weather phenomena and climate. The CO2 was only 0.04%, and by 2050, prognosis say that this number will double to 0.08%. Although CO2 is an efficient absorber of energy and therefore influences the heating of our planet. The magnitude of such temperature changes is uncertain and depends partly on the quantities of CO2 contributed by human activities in the years ahead. And it is hard to define now what exactly is purity and impurity, and because it depends on where we are in time. And we can define purity from the human perspective as a safe atmosphere, which means in general, it should be a bit colder, so less greenhouse gases. And global temperatures have been warming for decades, largely due to human activities that are altering the composition of the atmosphere. So impurities affect climate change and purities affect climate change, so both are very true. Then to come back to the concept of exclusive and inclusive, I have some examples, some case studies. So Bosnia has a high amount of fired power plants and they produce 72% of its electricity with burning coal. And Iceland, on the other hand, is already a step more innovative and they reduce greenhouse gases by using geothermal energy. Iceland has 99%, like almost 100% renewable energy supply. Here on the left, we have Nigeria, and between 2000 and 2005, the country lost 55.7% of its primary forest. And on the right, we have Norway as the world's first country to ban deforestation. Rice farmers are among the world's most vulnerable to climate change impacts. On the left, we have an old-fashioned rice paddy, which produced a lot of methane. And although present in much smaller amounts than CO2, methane significance is greater than its relatively small concentration would indicate. And this is because methane is about 20 times more effective than CO2 at absorbing infrared radiation emitted by Earth. And on the right, we have an efficiency of 26% less greenhouse gas emissions. And also the rice quality is better, less seeds, plant protection and products, and less water. These are the books that I wrote, so thank you.
Thank you, Joy. Thank you for your presentation. So we move for the next presentation of Mirko, and then we comment both at the same time. But I already have to say that you have done a lot of work since last week. Thank you. You can stop sharing your screen maybe, and Mirko can connect to continue with his presentation.
Hello to everyone. So my topic is catalyzing. Catalysis is the process of increasing the rate of a chemical reaction by adding a substance known as a catalyst. Catalysts are not consumed in the catalyzed reaction, but can act repeatedly. Often only very small amounts of catalysts are required. Catalysts make such a breaking and rebuild happen more efficiently. They do this by lowering the activation energy for the chemical reaction. Catalysis can have multiple meanings. In my opinion, It means that something small managed to trigger something large through a reaction caused by a factor that could be natural, such as the sun rays, or by a chemical element that causes changes to the final shape, starting from the molecular level of matter, creating something new. My two domains are programmatic and biocomputational. Programmatic means that is happening or done according to a plan or using a particular method, and biocomputational is the application of computer science to biological research and the practice of using computers to perform calculations. The analysis of the definition of catalysis leads to the branch of chemistry, bringing to enzymatic catalysis the most present in biochemical reaction. Catalysis can be divided into two main types, heterogeneous and homogeneous. In a heterogeneous reaction, the catalyst is in a different phase from the reactant. In a homogeneous reaction, the catalyst is in the same phase as the reactants, and it is not possible to distinguish the outline of the different components of the reaction. However, even if the reaction are in the same phase, but you can still see the contours such as water and oil, just an example, it's still a heterogeneous catalysis. We can see on the right an example of a scheme how to distinguish heterogeneous and homogeneous reactions. There are different types of catalysis, but one of the most interesting is the enzymatic catalysis. It is a type of catalysis carried out by catalysts called enzymes. Most of the enzymes are proteins. This type of catalysis is one with which practically all biochemical reactions take place. Photosynthesis is an enzymatic catalysis. During photosynthesis, with the mediation of chlorophyll, sunlight, or artificial light, converts 6 molecules of CO2 and 6 molecules of H2O into a molecule of glucose, a sugar essential for the life of the plant. As byproduct of the reaction, 6 oxygen molecules are produced, which the plant releases into the atmosphere through the stomata found in the leaf. Here we can see the stoichiometric formula of the catalysis.
I think that we have, your presentation is a bit delayed. No, it's fine.
Can you please speed up?
Okay. This was my first approach to the catalysis. So I tried with the nature and then going into the plants or the microorganism. Then with the sunlight, we received this photosynthesis. And then the case studies. Okay. The most direct case study within the field of biodigital architecture and synthetic landscape concerned the phenomenon of photosynthesis is the project by Ecologic Studios SuperTree, in which a photocatalytic reaction occurs caused by sunlight or wide spectrum grow light that allows cyanobacteria to be able to carry out the reaction and release oxygen, feeding on high amounts CO2 present in the air, or even additionally due to visitor exhaling and blowing into the algae culture via pipe. SuperTree is an artificial tree that is able to produce 10 times more oxygen than the leaves of a tree of similar size. On the right side, we can see how schematic these catalysis work by this project and the main points. Metabolic material is a photosensitive protocells, engineered to be light averse. Protocell is a group of chemistries that have a very simple metabolism that allows them to perform as if they were alive. The photobiotic metabolism of the protocells works by light-breaking chemical bonds, which propels the body forward, so these protocells will move into a dark place and gradually mineral shells will aggregate. Rachel Armstrong in Future Venice used these characteristics of the photosensitive protocells, where light serves to trigger the breakdown of the protocells, activating an enzymatic catalysis process so that it can reach a point in the water where there is no sunlight, and it starts to creating these mineral shells, growing an artificial limestone underneath Venice, and stop the city sinking into the soft mode by reinforcing the wood piles on which it's built. As before, on the right side, the catalysis features and the main points. TX active is a photocatalytic cement that eats smogs. This material reaches new frontiers in terms of environmental and architectural performance. Photocatalysis is an accelerator of oxidation process that already exists in nature. It favors a more rapid decomposition of pollutants, avoiding their accumulation by capturing them and transforming into inert salts, thus freeing the air from smog. It eliminates pollution by exploiting oxidation process triggered by sunlight. The titanium oxide present had accelerated the oxidation of pollutants in the air, making them harmless for the environment and for humans. Studies show that TX active cement reduced the amount of nitrogen oxide present in the air by 70%. In case of the Milan city, the application of biocement per 1,000 square meters would be equivalent to planting 80 evergreen trees or eliminating the pollution caused by 30 petrol vehicles. On the bottom part, we have a diagram how this works on the concrete surface. And here, two examples of buildings that are built with TX active. This one is in Rome, is a church. And in Milan, the Expo Palazzo Italia of 2015. The last case is biocement, a cement with dormant bacteria inside. The trigger is the water, which when it penetrates the cracks in the material activates the bacteria that create lime and in doing so repair the damage. In the University of Delft, Professor Henk Jonkers created a self-heating cement through the use of bacteria. In this way, construction and microbiology have met. It took 3 years to find the solution. He invented a cement which a mixture of sand, water, and debris. Some dormant bacteria are inserted, which if activated by the water that penetrates the material in the event of cracks are activated, producing lime able to self-repair the cracks created in the concrete. To create this biocement, Jonkers needed to find bacteria that survived in alkaline and extremely dry environment, such as concrete, and that could remain inactive even for many years before being activated by water. For this, he chose Bacillus bacteria, which can thrive alkaline environments, producing spores that can survive decades without food or water. But it was also necessary for the bacteria to have a food in terms of surviving and to produce lime. The best idea was to mix bacteria with calcium lactate, inserting the bacteria and calcium in the biodegradable plastic capsule inside the wet cement mixture. In this way, if cracks come into concrete and water penetrates into them, it will dissolve the plastic, activating bacteria in contact with water, and the bacteria will then germinate and their metabolism will convert the calcium lactate into calcium carbonate, creating lime, which will act on the structure by repairing the cracks. At the end, I have done this scheme of all the case study where I make a comparison one with the other, which material has done or which environment with which catalysis is the trigger and the result. And the conclusion of the research leads to the knowledge that catalysis in architecture is caused by different factors, which in turn give different results, as can be seen from the case studies, and it's always heterogeneous catalysis, given that enzymatic catalysis practically always occurs in biochemical reaction. Specifically in future Venice, catalysis plays a role in combating climate change, preventing the city from sinking, while in the context of pollution in cities, supertree and the TX active clean the air from polluting particles, and biocement contribute to a longer service of life of concrete of concrete structure that will make the material not only more durable, but also more sustainable. And that was my presentation for today.
Thank you.
Hey, this was a lot of progress from last time I saw you guys. I think it was very good to see this this coming together in the last couple of weeks. Again, it's kind of fun also to see the two together somehow, one after the other, because there are always kind of unexpected correlations. And I was wondering, maybe Joy, if the examples of Mirko in which category would fall, maybe the inclusive impurities or something like that. What would you say?
Yeah, I would definitely say inclusive, because it's also innovative and there's a lot of new steps. Yeah.
The idea, what you're claiming, is that impurity can be inclusive. Like exactly. The concept of impurity, it's not necessarily related to a kind of a traumatic event or an event that essentially has negative consequences on the communities, but that actually has the possibility to become an element of inclusiveness. It depends on how it is deployed, I suppose. How would you draw the kind of difference between them, or is it really black and white?
No, it's not black and white. It always depends from which perspective you see it. If you see it from the perspective of the whole history of the Earth, there is no impurity, there is no purity, because things are changing all the time, and the composition of air is not stable, and also the temperature. But if you see it from the perspective of human, we can see at which temperature and at which composition which work best for us. So from our perspective, we can somehow define purity and impurity, but I defined it just in general that -1 degree would be the best temperature for us to live, because there's, of course, not so much natural extremes, and also glaciers are not melting. So what we need these glaciers and everything. So yeah, -1 degree and less greenhouse gases would be closer to purity in that case for us humans.
From human perspective.
Yeah, exactly.
Probably.
There is a question of defining purity and impurity from the human or non-human perspective, which I think is clear and is interesting. There is another aspect that maybe has not been so much discussed in terms of purity and impurity, but in terms of definition has got a relevance, which is the cultural aspect. There are cultural here, like the Romanticism, that sees impurity as a quality in the arts, and there are other times, such as Positivism or Illuminism, that define impurity as a problematic. So while in common term we can see purity and impurity from a human perspective or a non-human perspective, in cultural term as well, there has been different position, or they have been seen as something that has a positive connotation or a negative one, depending from the cultural framework in which they are embedded.
From the point of view of architecture, I think that's also quite obvious, let's say with the modern movement being, rather adverse, I guess, to the idea of impurity, and perhaps this is something quite evident also in the examples of Mirko, no? You kind of created a, actually, I think the way you presented the examples was very clear. But in that sense, you could, your final matrix could be a little more explicit in terms of addressing the differences, perhaps, as Claudia was mentioning, also kind of cultural differences from the examples. You have Richard Mayer on one side that appears to, let's say, include this let's say, active or you know, catalytic substance on the surface of his architecture in a way that is invisible versus and in a way that it doesn't affect its architecture in any visible way or discernible way. Whereas on the other hand, you can see for example, the project in Venice from Rachel Armstrong, which of course it's a more conceptual project in a way, but that clearly seeks to materialize or to embody, these impurities, if you want, or the heterogeneity of the process and in its actual appearance and morphology and etc. So in that sense, when we talk about inclusive or exclusive, you know, we can also perhaps read it in that way. I mean, when the process is invisible or is not in a way embodied in the language of the architecture, then it becomes automatically exclusive in a sense that it doesn't encourage any forms of interaction or cultural acknowledgement of what is happening. Whereas, and you know, and from there you could also be a little bit more direct and see it as a form of greenwashing to a certain extent. And on the other hand, when it kind of materializes it in such an explicit way, then perhaps we could define it as inclusive, at least from this perspective. I mean, again, of course, inclusive, exclusive also have several meanings, but I think from the conversation we are trying to establish here, I think this appears to me as a quite clear way to, for example, engage with all of these narratives that are obviously becoming you know, very, very popular, also in the press, in the architectural conversation, in terms of different methods and different models of engaging with the issues of climate change or pollution. So, yeah, I mean, I think this, again, of course, there is a lot more that can be said, but I think in principle, these two work, I think they are, in that sense, very good in beginning to cut through these, and especially I think, which is the purpose of this course in my mind, is to develop also critical thinking, critical eye towards you know, what the discipline is proposing, you know, because again, you know, like you guys are developing your own contribution, and I think you need to do it critically. I think this work will help you in that.
I also wanted to add on that regarding inclusiveness, exclusiveness, and impurity, now there is, beside the cultural perspective, I think there is like a geological perspective, because Joy was referring to the last images when you are comparing, for example, if I'm not mistaken, Bosnia and Iceland in terms of energy production, or Nigeria, if I'm not mistaken, and Norway regarding the deforestation. And I hardly can say that there is something is inclusive or exclusive, because I think that we need to, beside the cultural perspective, that these are two different cultures. No, Claudia was mentioning the change of the culture within the time, but there is still a change of the culture between the different regions. But there is also different geological perspective, and these regions have a different resources and different aspects to consider. So this becomes absolutely relative. And of course, we cannot talk about this kind of deforestation in Norway as in Africa, or Iceland, which is basically grown on the hydro energy, cannot be compared with Bosnia, and I don't remember the third case. So I think it's also interesting kind of perspective to consider the geological and think about the planetary intelligence in this case.
Yeah, thank you.
Yeah, what I appreciate in the comparison that Joy did was also the sort of morphological comparison, the visual language that emerged. And I think I'm even more convinced that this is something that should be more introduced in a theory course. Like, for example, in the case of Mirko, I appreciate the fact that it unveils a way of interacting with the atmosphere of the planet through different elements that can be biological, chemicals, and that they are in the press a lot, and often they are quite critical to be understood. On the other hand, I think it could have almost remained on, just presented the final chart, but then speculate to draw in more in depth in some of the case studies to understand also the design implication that characterize the different projects, and in my view, point to a one solution rather than the other. So one solution is maybe about, development of a morphology and then correction of the morphology to interact with the environment. And other of the solutions that have been presented are more about morphogenetic processes. Now architecture can become part of it. So, but I think some of these elements can be unveiled or understood only by looking more carefully also at the design process and maybe repeating it or testing it. So it's something that I think we should reflect on and really try to integrate more.
Yeah, this is the last conclusion I wanted to do. Thank you, Joy, for adding all the time. It was very interesting to see your presentations. Every time there was new stuff coming, and even the comparisons that you did. Of course, we could speculate about them, no doubt, but I'm really, really happy to see them because it's something new we haven't seen even last week. And it just adds on to the discussion. In terms of Mirko, presentation-wise, content, I understand you studied a lot the topic, but presentation-wise, I would really suggest in future to look always at the presentation as something that, is adjustable, adaptable. Your presentation over time did not much change, just add on a little bit of content, but there could have been a bit more progress regarding the implications. And for example, also I personally really would avoid reading the text that we see on the screen, but also when you start narrating and think about presentation as a narration of some sort of story or narrative, then you eliminate things when you talk about a certain project that has implication of reducing pollution I think quantity-wise for me is interesting as, let's say, 80 trees largely grown, but then we see the project only 3 slides later. So when you start actually writing the text you say per slide, the slides suddenly start to change and evolve, and the narration gets a bit more dynamic rather than static. But that is just suggestions for future. Anyway, thank you. It was really beautiful also to see the presentations together. We will move on to next project.
Thank you.
Thank you.
Thank you.
I think we have 2 bachelor's projects now, correct, Teresa?
Yeah.
Yeah. So I just would like to make a very brief introduction for Apostolos that yesterday wasn't with us. So with year 2, we have been working on a site close to Innsbruck, which is called the Burgruin Tower, where it's like a sort of ruin of an ancient castle. And we were particularly interested because of how, the location, which is beautiful, but also like the very close bond created by the plants kind of regrowing on the ruin and kind of reacquiring the man-made. And we work on the basis of scans, as you can see at my background, and the other students and Matthias as well, they have part of this work with them, and particularly plants and trees, and how we could learn basically organizational logic and growth logic from these to kind of develop a conceptual proposal that we call ForestHUTS. Yeah. So I think the next 2 people presenting are, where is my
Fabienne and Alisa. And next one will be Marina and Cecile.
Yes, hi. Okay,
So our project is called Evergreen because we worked with plants that stay green the whole year around. And when we went to the site, which is the Burgruine in Tower, as said before, we were kind of fascinated by the plants growing directly on the walls, on the bare rock, out of the cracks and sucking their nutritions out of the rock. So here on the right, you can see the first plant that we scanned. It's a small kind of fern called Asplenium trichomanes. It is a non-flowering vascular plant which reproduces by spores and prefers shady, moist areas. And as I said before, it is wintergreen. So here you can see the result of my scan, the point cloud. And here you can see it from different perspectives and in comparison to the photos. And as you can see, it turned out quite detailed. So then we created a structure of this fern to understand it better, to see how the branches are connected to each other and how the leaves are connected to each other, and understand how it works really. And finally here you can see the structure overlaid onto the point cloud.
Right, so our second plant, which you can see here, the rectangle on the right picture marks the spot so you can actually see it a bit better, is a creeping sprout, and it's called Euphorbia mesynthesis. It's flowering yellow and it reproduces by seeds. It prefers areas with full sun so it can survive in winter, and well, yeah, it's wintergreen. Then two important aspects about the plant are the helical leaf position, which implicates that the plant is phyllotactic, and it has a succulent stem and succulent leaves, which it's a kind of water storing system for plants that grow in dry areas. And here you can see the point cloud, which we got out of the photogrammetry we did, and then yeah, we overlaid it with the algorithm, which is the shortest walk algorithm, and it kind of created cocoons with the point cloud because it's empty inside. So we tried to recreate one branch, so you can actually see the succulent branch and the leaves. And then we researched about the root, which is a taproot, which means it has one primary root, and then on that primary root there are secondary and tertiary roots, which grow into like smaller cracks. And here you can see it recreated with lines because the algorithm didn't really work on the point cloud, so we tried to understand it with the lines, and I think it turned out really good.
So for our concept, we thought we would make a water supply system, as this would reflect the characteristics of our plants the best. So we read a lot about global warming and how it affects our region, because the temperature rise in the Alps was twice as high in the last decades than the average global temperature rise was. So this means we will be facing longer heat periods and also long heavy rain periods in the future, and they will be alternating. So this will be a problem for forest animals because they won't have their natural and consistent water supply anymore.
So we were thinking how we could use our plants or our structure to face that problem. And well, in heat periods, we were thinking about a pumping system, which gets the water out of the ground. And in heavy rain periods, we would use the structure as a storing system or a saving system, like the creeping sprout does with its succulent parts.
Yes, so to start with, we did some growth studies on the small kind of fern. And we piped the algorithm to make working with it easier. Here you can see the different stages of its life cycle. At first, it's kind of detached, and as it grows bigger, it becomes more attached and connected. So we did a growth study on the wall. This is how it could spread.
And then we tried to apply our studies on the site. Here you can see the Burgerinen Tower. We used the whole area. And to understand the area better, we colored our contours. So the highest points are red and the lowest points are blue. So you can actually see how it changes or where the valleys are. And then to highlight the valleys, or actually where the water accumulates when it rains, we use the flow lines, which you can see here. And yeah, so where they are the thickest, that's where most of the water accumulates. And then we kind of thought about the site as a wall and placed the farms into kind of the valleys, which are the cracks that we kind of thought about it like that. Yeah.
So with this, we decided on a spot, which you can see here. And we thought this would be a good area because there the flow lines are really thick. Yes. And so here you can see a close-up of the structure and how the system would work. In heat periods, the roots could get the water from the ground into the troughs on the ground and the troughs on top. And in heavy rain periods, it can simply get collected in the troughs to assure that the animals always have a secure water supply.
Right, and here you can see a view where how it could look in the valley where we placed it, and how we imagine it to be used, right? And yeah, thank you for your attention.
Thank you very much. Anita, do we run two presentations in a row, or we
I think we thought to comment now, yeah, and then to the other one later, if that's okay.
Perfect. So I invite everybody to jump into the discussion.
Well, I'll just jump in. I think it's a beautiful project. Like it really, like from the beginning, from all the analysis and so on, to the idea how you want to apply it, like for the water storage and water absorption. I think that is really successful. The only thing that I didn't really understand, that you just scaling up the whole thing to make it for the human scale, or to make it kind of usable for a larger scale environment. And I think in a lot of cases, the way that plants work, they always have like these capillary effects and so on to transport the water and so on, that many of these effects don't work if you just scale it up in the relationship with the water and so on. So it would have been quite cool to still have the same effects of the plant and kind of apply it on a larger scale without just scaling it up, just if it makes sense what I'm saying. But I like the overall idea, like how to absorb the water and deal with these new situations due climate change and so on.
Yeah,
so a really nice project.
Be fractal. In fact, I think the project is, the 3D scanning is really beautiful. The type of plants you choose is also very interesting. I think in the moment you move, I think we probably discussed already this in the midterm, you move from the systems, so this plan with different systems, to what you call the spot, so the single unit. I think there is a problem in transition there, because eventually there could be a fractal condition where a certain element of capillarity are then reproposed because they work at a specific scale, but they work fractally inside of the structure. While when you scale, you seem to lose some of this quality that you have, both in terms of drawing, but also in terms of property in the previous one. So I think there is a little bit of an issue. It's a good project, but there is this issue in the translation. I think when you concentrate on the single unit, that becomes a little bit of an object in the sense and lose the characteristic of the system. This would be something to avoid.
Can you just go back a few images? There is one moment, yeah, a little bit back, when you start working with the site. If you can go backward. Yeah, exactly. This is a really nice image that has a resolution. That is really good for what is trying to show, but it's very, very large scale in a way, no? And then whereas before you have the image in which you 3D scan and map your plants and you draw the path system on your plants, that is also very, very beautiful and high resolution, but a very small scale. And then you combine the two in a way, no? Which is what happens in the next slide. If you go next. Yeah, exactly. So this is where you have a little bit of the problem, I think, and you know, in terms of the scaling, no? Which again is completely understandable because it's really challenging to go from the territorial scale to the scale of a plant, and you know, so it is obvious that you would find it difficult. But you know, I think it's a great experiment, the one that you have done, and you know, maybe when you come at this point and you see that to achieve the resolution that you want, you have to combine, let's say, several plants together, then maybe that's where you could have, you know, start to think, oh, maybe I needed to find a description of the territory, of the terrain that kind of works with the resolution of my model, and vice versa. And that's where, you know, maybe there is this kind of extra level of development that is necessary. But then again, you know, it's really something that you know, you can take on in the next courses, in the next adventures. And I think the idea of transcalarity, it's really important, and you have engaged with it really well. And again, to articulate this transcalarity in a way that there are these kind of nested levels, and you know, and that you can manage the continuity between them. It's definitely an exploration that will probably need several studios for you to unpack, you know? So, but it's perfect that you already have engaged with this journey. Maybe, I don't know, your background image, no, that you have here on Zoom is a 3D scan, but at the landscape scale, no? So, yes. If I read it correctly. So maybe that is another element that could have been interesting to introduce, like when you were translating to the landscape scale, rather than using, let's say, the contour lines, which are in a way quite low resolution compared to your model, trying to use a 3D scan of the landscape scale so that you could have applied the same logic of algorithm to that point cloud, and then therefore, you know, using it as a kind of a scaling element. But again, these are just kind of ideas and reactions, so that you may bring them forward in the future. Otherwise, the project is lovely. The narrative makes total sense. You have engaged with the plants beautifully. You have engaged with the landscape, mapping it very, very well. And you know, and I think that's pretty much the maximum that we can ask, I think, at this stage.
Thank you.
Thank you.
Also from my side, congratulations on how you have been proceeding from back before Christmas, when we saw your last presentation. I remember back then you had plans which were sparsely populated all over the area. Now you try to find a better narrative on how these plants could interact with the surrounding, with the area. I saw you in the picture before. I think you tried to place some plants into the wall, and all of a sudden, can you go back some images? Yeah, over here. You tried to place all of these plants in the wall, and all of a sudden you jumped over to, like you tried two different things, right? So on one side you tried to make them grow on the wall, or to place them on the wall. On the other side, you place them on the landscape, and depending on the water flow. Now, this is, of course, a big choice you had to make, and probably it's quite hard to choose on which way to proceed, whether to go on with this type of your plants growing on the wall, or to proceed on with the flow lines on the landscape. Now, I like the one with the flow lines on the landscape more. It takes a bigger scale, and I would love to see how the plant interacts with the water flow, because I'm not sure how you choose where to place each plant on the flow lines, on the streamlines. And maybe you should find a factor that is going to influence where these plants are growing. For all the rest, the presentation is great. I love the images, and I saw how you proceeded over time. So really great.
Thank you.
Yeah, I wanted to add, I don't know if this is the question of a scale or not, because are you really studying the vascular system of a plant? Because I think the simulation is trying to reinterpret the plant, but I don't know if it's exactly the vascular system. I think maybe like it depends on what you're trying to discover within your analysis and research on this type of plants. The adaptability to the water, the vascular system, the idea of the adaptation to the, I don't know, some conditions, maybe environmental. So it really depends on what are you aiming at, no? Or maybe you're just trying to create some visual narrative that you perfectly managed to do. So of course, if we say that like a structure of the cell of the plant is not working, like is working on a different scale, and then when you're scaling up, it doesn't work same way, true, but maybe some other aspects are actually working perfectly. The only thing for me, honestly, which is missing in the project is in the last images, and maybe in some plans when you're starting to develop the more spatial proposals, the relation with the ground, the relation with the surrounding, maybe a bit more what I would push here. Because if you think on the plant, I think the smartest system is under the ground, is the root of the plant as well. And maybe I would start thinking on the, I don't remember who was mentioning now, the relation of the water flow and the plant and the maybe a root system, or how does it also one plant relate to another one? How do they coexist together? So I think that that would be also very interesting to investigate, but probably it goes to the next project in the next years. I think for this step, that's a great result and beautiful project. Thank you very much. Can I cut with our comments, or anybody want to comment else?
Can I just very quickly jump in? But it's not just, sure. I'd be super fast. Just to say that I think that, I mean, first of all, well done, because I think from what we saw in Christmas till now, your project really kind of developed significantly, and it's so much more strong. But it's a bit of a pity that you kind of, it still seems to go back and forward a little bit, where you kind of present this village of fern, and then all of a sudden we have only one. So if you know, and I think you should kind of fix a little bit before handing in the, you know, the final. I would totally try to kind of fix that, because you have a very nice you know, village of fern, and you could easily kind of add them both in the three-dimensional views and not have this single object there sitting in the landscape. It will make it much, much stronger. Yeah, so that's just a note. But overall, I mean, it's I think you have very, very nice moments in the overall presentation. So, I mean, well done on that. And there is a bit more to kind of, you know, do and develop like a three-dimensional representation of that, but that's probably skills that are under development, they will come. So, I mean, well done.
Thank you very much for the presentation. Thank you very much, everybody, for the comments. I invite Marina and Cecile to continue our quiz.
Yes, so hello.
All good with the presentation, hear you properly.
Okay, perfect. So our project is called The Social Beach, but in the beginning we had two projects. So I started off with the dogwood, which you can see here in a matrix. I like the idea of the color of the dogwood. That's why I chose it at side. Yeah, here you can see it in a close-up. But as we figured out that we were teaming up, we started to think about which aspects of our plans that we chose would be the most interesting to work on in an architectural context. And so we chose the beach, which Marina is going to explain now.
Yes, so this is the red beach we decided to focus on. It's located in front of the Burgruine Tower. And the red beech in general is a quite common tree in Austria, as it makes up to 10% of the deciduous trees. It has egg-shaped leaves with an wavy edge, and at the age of 30 to 50, it gets blossoms. Quite interesting is that there are male and female in one tree. And at the age of 40 to 80, it gets the fruit called the beech nuts. But the most interesting fact we wanted to focus on was the growing behavior of the beech, as it is very dependent on its surroundings.
Yes, as already mentioned, the growing behavior differs very interesting. So if it grows on its own, it gets a really huge crown, as you can see here. But as soon as it grows in a forest, it changes completely. It starts to build something that's called climax vegetation, which means that all the trees that are in the forest together form something like a roof, and it's always closed. So that means if an old beech dies, a young beech is going to take its place and to kind of fix the roof. And therefore the young beeches stay, if they start to grow, they grow until something like 2 meters and then kind of wait until they are supposed to fix a roof in the gap in the roof. Yes, and that is what we thought would be really interesting to work with, because that kind of teamwork is pretty impressive. Yes.
Yes, so we wanted to apply this behavior on our structure. So the idea was to place 3 trees on the side, observe their growth and see what tree top they would create. And in 3D, we created a structure like this. We used the cocoon algorithm on the ends of the flow lines, and also integrated a surface to calm the flow line structure down.
Yes, as we figured out our geometry, not our geometry, but the concept we were wanting to use, we started to think about where it would make sense to place these 3 trees we were wanting to use. So we started with an analysis of the site by looking where the trees around are, and we found that there's something like a forest around, but the ruin itself is something like a gap in between. To understand the density of the forest better, we used something that's called, used this proximity network, and as you can see, it's pretty dense, except here. So we thought it might be a good idea to place our trees directly inside of the ruin to form something like a bridge between the two sides of the forest, which then could be used by, for example, squirrels or other animals to cross the forest without having to touch the ground or go a huge round to get to the other side.
So here you can see the final project on the site. We have 2 entrances for humans to enter, and also we created 4 platforms inside of the flowline structure for people to use. Also in this view, you can quite clearly see the connection between the 2 parts of the forest we wanted to create. In the perspectives here, you can quite nicely see the basic structure of the flow lines. And this view might be a bit confusing because of the many flow lines, but we wanted to show the inside of our structure and also the platforms we mentioned before for humans to use. And the last view is a section. We also thought about the material of our structure. We wanted to leave it a bit open, but also, but we thought maybe steel might be a good material as it works with nature and gets rusty throughout the years. And as our project is inspired by nature, we thought a material that is shaped by nature and works with nature could be fitting, and you could use rust-proof steel for the flow or for the pipes humans would use to climb on the structure, and rusting steel for the other parts. Also in this view, you can see that our structure creates kind of an in-between of the human-built ruin and the trees that are created by nature, as our structure is inspired by nature but built by humans. And we also, here you can see the vision of the vision we had for our place. We wanted to create a place for humans to come out of the city into nature, to relax, regain energy, get inspired by nature, but also use it as a social space where people can meet each other and get in contact. We also thought of non-human inhabitation, which in our case are squirrels, using the structure as a bridge to come from one side of the forest to the other, or birds who can build their nests in the structure or land on the flow lines. Yes, all in all, it's a place for humans and animals to come together and interact. So yes, I hope you enjoyed the presentation and thank you for your attention.
Yes, thank you.
I like birds interacting with flow lines. It could be a new concept for them. No, but I think that actually this proposal for me, it's probably the most convincing I've seen so far in terms of actually proposing an architectural actualization of the concept. I think it's very clever to use the ruin as a kind of wall and ground in a way. And then basically introduce your structure as a kind of roof that is not just a roof. Of course, it creates a much more much more three-dimensional matrix for use as you are suggesting with this section. I think the section is very nice. I also appreciate that. And finally, you have used the 3D scan as to actually depict the vegetation in the background and so on. So it's kind of, again, bringing that language through to almost through to the end, which is also very interesting. I wonder why you didn't actually use the 3D scan from the other plants that I thought also was very beautiful in terms of this color and nuances, etc., as, let's say, the skin, for example, because this rendering suggests that you have a sort of membrane that kind of encloses or wraps this structure, which I think it's an interesting solution. It would have been nice perhaps to try to borrow that study you have done on that kind of plants, which I forgot the name, and kind of deploy it as a sort of the depiction of a membrane, of a very light, gentle membrane, maybe to wrap the tubular structure. So in that sense, maybe that's the only thing that it would have been great to see, and probably you can actually do it very quickly, even now, just in the next day, to wrap up your portfolio, and I think it's in that sense it would also reinforce the collaboration between the two of you, which I think it's also demonstrates a certain maturity in the way you actually brought together your personal investigation, but then kind of resolved it into a new structure together. I think that's really clever way of working as well. So yeah, I think overall it's probably the best project of the studio I've seen so far, from my perspective at least.
Hello, congratulations from me as well. I completely agree with Marco. The project and the presentation was very good. It actually reminded me of these trees in Pakistan that are enclosed with the spider silk. And what I found it interesting was that you are dealing with different layers of users within the space that could actually be part of the enclosure's materiality, let's say. So maybe the birds or maybe another animal that lives in the area can help enclose this structure that you're proposing.
Okay. I also really love the project, and I loved it during the midterm as well. I remember your development, and I think now you're at a very good stage. I think that's just very smart, this analysis on how does the tree actually develop its morphology according to the depending on the relation with other plants. I think that's very smart and interesting research on the for the form finding. So, and I agree that it would be nice to see first analysis of the color in maybe a skin that you are developing. I would maybe, if you push these projects further, I would maybe suggest you to think more on the resolution, because if you take your 3D scan and start to redescribe the point cloud with this branching system that you are proposing, but in a different resolution, a different scale, I think you can just achieve even more impressive results, because then you will not just imitate the tree, but you can actually study the relation of these points within the point cloud through this branching system. I think that you can come to the very complex structure, which will also suggest you not only now you are developing overall morphology, but you're not thinking on the, for example, structural mesh of your proposal, but you could achieve that resolution, which will already suggest the mesh and the grid of different branches intersecting and creating structural grid for the proposal. So yeah, but thank you very much for presentation. It's an excellent result.
Thank you. Thank you.
Hey. I love this picture, this last one, and most of them were just as beautiful as this one, but not all of them. I love how you integrated the point cloud structure into the vegetation of some of your images. Now, I would love to see all point clouds, because sometimes you had the terrain which was shown like a mesh or something like that. I wish the graphics were more, they showed more point clouds, even maybe for the Burgruine itself. Now, for the project itself, I like it a lot. You did progress and the results are, I think, excellent. So the only thing I'm not sure of is whether the structure should be out of steel or some other materials, but there's nothing else to say. Really good.
Thank you.
I completely agree with Matthias. It's a very good project. The others already pointed out on this, and I think the studio was very successful in general. But I think retaining more element of the point cloud, not only the color that Maria mentioned, but also the point cloud in itself, would actually allow you to connect to the second point that Matthias made, which is about the steel, because I think representation is not only representation, it's also about speculation and design. So if something is represented as a solid element, then you start to connect it with the material that you know and that you've seen before, and visually steel or some of the Miralles project comes to mind, and of course this becomes steel. But if this will be represented as a point cloud and with color, then immediately you start to think about more deconstructed material, more porous material that may be changed in time and space more gradually, and then you will need to speculate about other technique of production as well. So the drawing is not only a drawing that represents, but is an instrument of investigation that is really important. And that I think is something to reflect on the next step of the course, how we do this step further, how the drawing really allows us to not only open up a new scenario and brief of the relationship between natural and artificial system, but also open up a new material system itself that we couldn't imagine before. And because we draw them in a certain manner, we need to think them different and construct them differently. So it's the drawing that leads the transformation of the idea or that suggests new idea about material, and not the other way around. We think of the material and we draw it. No? So I think that is some sort of step that needs to come, and that is very important for me. Really, in the moment you then maybe you end up prototyping or developing one-to-one of this element, then how they get materialized, how they connect to natural system also for their behavior and materiality, I think it's really important. But other than that, I think the studio and the project has been very successful. Thank you.
Okay, thank you.
I have just one last thing to say to both of you. Well, not both of you, but to Marina, Cecile, but also Fabienne and Elisa. Well, you're talking about like, this is the point cloud, this is what I did. For the future, try to see those as techniques, as instruments that you use to develop your project, okay? It's, I don't like how you place this technique, okay? It's not just a point cloud. It's a technique. It's a way of doing things, okay? And it's a special technique that you've learned during this course. So please try to see further than just the point cloud. See it as an instrument, the technique that you use to elaborate everything. Thanks.
Just one thing that I wanted to add, besides all the drawings that are absolutely stunning, and also that you integrated all the drawings that you did and you placed them quite nicely into the point cloud. So it always, like, all the drawings are really consistent, I think, and merged together quite well. And also, because the last time when I saw it before Christmas, you had this cocoons and then your shortest walks kind of wrapped around it. So you had this empty space inside, which was not really convincing. And I wanted to add that you made like a really nice step of making it a convincing project in the end, which is actually looks inhabitable for natural and human beings as well. So congratulations from my side as well.
Thank you.
Maybe just a brief comment from my side. Hello at first, and congratulations to your technically very fascinating projects. I think you deployed the toolset very extensive, and the deductive approach, how you did the project, was convincing for me as well. But I do not really believe the narrative at the end. This is just maybe an important point, because you're talking about the social intelligence and the social beaches, and the narrative that animals and humans are sitting on the branches and everything. Maybe that point is a little bit forced and a little bit arty. So you could easily quit it, because it rather weakens the overall narrative than that it is strengthening it, I think. And the project, of course, is very convincing, and your approach and the drawings as well.
Yeah, I absolutely agree with Stefan. I would just leave it, for me, I would just leave it for the birds and the animals to inhabit and see what is the relation in the forest through this kind of bridging or any other proposals. But I agree that maybe the final conclusion was not the strongest point, that we just probably missed that in our ears, like let it go. But I think that it's nice that you're including different types of agencies, like involving in the design proposals. But yeah, I need to cut our discussion because we're taking too long. Thank you very much again for the project presentation, for your work, and everybody for the comments. So I propose to come back to the virtual rooms and see some other cool stuff of our master students. And I would invite Catherine and Melvin to present their work. Somewhere in our chat, I already sent the link. I resend it once again. Yeah, so let's meet there. And again, we stay with our voice in Zoom, but our presence will be virtual.
Okay, so welcome to our Mozilla Hub room and to our project, the geothermal energy potential of Stromboli Island. We are located across the Tyrrhenian Sea, and Stromboli is one of the 7 small islands just to the north of Sicily in Italy. Our project is about taking advantage of the power of the Earth interior. Volcanoes are one of the most evident manifestations of the Earth's energy and the main source of geothermal energy. We used algorithmic drawing techniques to distinguish between 5 areas: vegetation, population, rock, sand area, and burnt ground. We used this technique to define the lava flow in order to record risk potential and specific regions, such as the village of Ginostra in the southwest of the island. The lava flow analysis helps us to position our power plants efficiently. Now let's start our journey and explore Stromboli and the geothermal energy potential on the island more deeply. And we can start at the first stop at number 1, down on the right. And you can press G to fly down.
On Stromboli Island, about 450 residents live directly under one of the world's most active volcanoes, spread in 2 main villages on the island. The villages are located on the right now. The village are located on the right now is also called Stromboli with around 400 inhabitants, and the other village is called Ginostra on the opposite side with around 50 inhabitants. Both villages have a port with boat connection to the other islands and to the west coast of Italy. The villages are quite protected as the active craters of the volcano are on the opposite flank of the mountain. Stromboli is also one of the world's most visited volcanoes, and tourists will often embark on a 3-hour hike to see the spectacular lava firework. So let's follow on the road up to the top of the mountain to see the craters.
That's it. Point number 2. So here we are at the very top of the volcano at about 930 meters in height, but the volcano itself reaches down to 2,000 meters under sea level. The volcano of Stromboli has 3 craters, and as already mentioned, it is a very active volcano. There are up to 3 eruptions an hour, even if they are very small. The volcano's activities are being observed from 11 measurement stations situated on the island with different instruments, such as, for example, seismographs or tilt meters. On this side of the mountain, we can see the Schiera del Fuoco, which means stream of fire, and it is a steep channel where molten lava flows down from the summit to the sea, and sometimes it can also cause small tsunamis. Now we can go to the point number 3, which is down there and located in Ginostra.
So one of the interesting facts about volcanoes is that they are an incredible source of energy. Since this volcanic island still didn't try to produce any geothermal power yet, we tried to focus on designing a geothermal technology to produce green energy for the people living on Stromboli. What we see here is a design of a modernized power plant. For the design process of these plants, we focus on the word power plant itself, so that they get the structure of a very simplified tree. Geothermal power plants are used in order to generate electricity by the use of geothermal energy. They essentially work the same as a coal or nuclear power plant, with the main difference being the heat source. A power plant needs a steam turbine and generators, which are all placed inside the trunk. In the top part of the plant is the cooling tower. To produce even more electricity, we placed several power plants rather than one big one. The analysis of the lava flow shows us where it is the safest place to the whole power station. Now, if you follow us, we can go through the surface under the volcano and meet at the vent in the middle.
Okay, so we are now inside of the volcano in the magma chamber. We focused on the question how magma plays a role in geothermal energy. The conventional geothermal power generators use the steam from the earth for generating electric power. In the magma power system, high temperature heats from magma around 1000 degrees Celsius and can be used to generate strong steam for driving the steam turbine in the power plant. We did a field of point clouds to show how the energy and the heat is distributed inside of the volcano. So now to the process of geothermal energy and the path that distributes it. First, hot water is pumped from deep underground through a well under high pressure. Then the water reaches the surface and the pressure is dropped, which causes the water to turn into steam. The white energy pipes that we can see are for the steam to spin a turbine, which is connected to a generator that produces electricity. The steam cools off in a cooling tower and condenses back to water. This cooled water is pumped back into the earth through the blue pipes to begin the process again. To continue the presentation, we can go to the other side through the surface again at point number 4. You can just follow. Yeah.
We have another power extraction station on this side of the island, which works exactly the same as on the other side. But considering both villages are on the opposite sides from each other, it's easier to provide both villages with enough energy. One small power plant extracting the energy from the volcano can produce 1 megawatt of thermal power, which is enough to provide electricity for a land field of 16 square kilometers. 25 megawatts of thermal power can provide a land field of 400 square kilometers with electricity. Since Stromboli is only about 12 square kilometers and much more electricity is produced for the use of the island, it can be transferred to the other 6 islands around or to the west coast of Italy. As a last step on the output of the geothermal energy process, you can follow, if you want, the yellow flow lines to see the electricity distribution from the power plant station to the houses with the shortest walk algorithm. Thank you for your attention.
Thank you guys for the presentation. So I invite everybody to comment.
Ja, bitte. Beides.
Now I'm starting to feel better in the VHR rooms. Just to, for the sake of my understanding, what is the aim? Is the aim to, what are you aiming exactly at? I mean, you show how you extract or how you produce electricity through through the heat of the volcano. So what is the real goal in this project, apart from transferring the energy to the house and to the islands? What are you trying to show exactly?
We want to show, or the aim was to, because it is a volcanic island, and the forces of the volcano to extract energy out of it was not used in Stromboli. And we wanted to make it possible that the island can actually make use of this force of the volcano to produce electricity for the house on this island, and even produce more electricity to transfer to other islands.
And as a volcano is such an incredible energy source, and apparently only 67% of global geothermal power potential has been tapped until now.
Okay.
So, yeah, that was to work with this volcano, with this incredible energy source.
Okay, so at the moment, the whole area isn't using this thermal energy, and you're showing the way how it could be, how the energy produced by the volcano and could be used to transform it into electricity. First off, it was easier to understand your VR room, easier than the one before. It's quite clear, and it shows even getting underneath the volcano, where you show how you extract the heat and you transform it into electricity. It was very clear. So for the understanding of the whole project, it works quite well, I find. And well, I need to hear some other comments to understand more of the project, maybe.
Well, I think the brief is really interesting, and well, we discussed it also together. It's also something that Marco, myself, also with Maria, we've been discussing various times, how to work eventually with volcano and harvest some of the energy and not only the disruptive energy of the volcano itself, which is what usually get most of the news. one of the aspects that I think, despite element maybe of a presentation that we can discuss more in detail later, one of the aspects that I think is a little bit critical of the project and didn't come true as I was hoping is the controversy of the subject. Volcanoes are generator of terrible disaster still. They've been, of course, in the past, if you think about not so far volcano from this one, the Vesuvio, which cover Pompeii, but there's been also recently in many parts of the world, they are still called one of the major causes of natural disaster that are not caused by man-made infrastructure, but actually from geological forces. And in fact, when you visit area where there are volcanoes, there is always a mix of science and mythology that is inherent part of the fascination of this type of territory, even the less dangerous one. They always generate a conflictual feeling. I would say that reminds me of the conversation we had with Joy about impurity. Even if the landscape, and I've been many times on this specific volcano, so I know the landscape is really beautiful, it's never just beautiful. There's always something of it that is quite, I don't know, quite scary in a way, or awkward, or strange. You always find the sign of where the volcano, even 1,000 years ago, maybe cover half of the settlement that were there, and and destroy part of the landscape, and you see what it could potentially happen, and that's, of course, from the very human point of view, cause a controversial reaction. And I would have hoped that some aspect of this controversial feeling that you have when immersed in this type of landscape could be explored through the VR. The project makes total sense, and I think it's a good step to revert this idea of the volcano not being either a touristic resort or something to escape. But on the other hand, I think there should be something more that underline the characteristic itself of the landscape, because it's a very peculiar one. And this is something maybe to bring forward in the future, but I think it's something that is a bit missing for me at the moment from the project. So,
for example, I was thinking about the form, the shape of this, almost a sculptural element that you are proposing as the kind of visible manifestation of these power plants, right? And I mean, they are, first of all, they are huge. Like if I have to believe their scale, they are really massive, and they are very sculptural. And you haven't said a word about why they look the way they are, how big they are, how they fit into the landscape on a by the way, on a very black special kind of landscape. There you are really at the edge of the Sciara del Fuoco. It's like completely black lava. Again, I think that's a little bit of a missed opportunity, because I think this was a really interesting element. I mean, we are used to think about power stations as something that are completely and purely functional. Whereas in your case, you are suggesting and implying with this that actually a power plant can become an element, a feature of the landscape with really strong sculptural qualities, and perhaps also, as Claudia was saying, with symbolic, almost mythical qualities, if you want, manifestation of the spirit of the volcano, which even has a name for the locals. They call it Idu, and on the other hand, maybe even become part of the memory of the people, for instance, that lost their lives in the years in several instances, and even recently, just a couple of years ago. So, you know, I think there is a whole dimension there that I think your project in a way captures, but that you haven't been kind of exploring, at least in this presentation with your narrative, but that I think are really a big part of the potential of this project. You know, even the way you locate these two power stations in, you know, at the kind of edge of the Shara on a very visible area, you know, connected to the two villages, but at the same time also separate and very symbolic. I don't know. I think there is a dimension there that, as Claudia mentions, it's part of the project in my mind. I think you somehow have it there, maybe even just intuitively. But it would be really great to hear more about it.
Marco ist viel am Reden. Ich bin jetzt von der Sekunde rein, ich habe keine Ahnung.
I think we hear Ben.
Hello.
You want to jump into the discussion?
No, sorry. Just was unmuted.
Okay. So that's okay. Yeah, I think that's it's a good development, and really the site and the topic is very particular. I really hope that one day we develop the whole studio around this topic, and I think that would be very interesting, and your project could become one of the good examples of the first steps on the platform for further development. So I think also you guys found lots of different options and instruments to describe your projects and to develop your projects in the virtual reality. I really like this possibility of traveling through the volcano, and I think that should be developed even further. So it's a great work during the semester. Thanks a lot for your project. If we don't have any other comments, I propose to move on, since we are, as always, late with our schedule. Okay, so thanks a lot. Let's continue with our schedule, and I would like to invite for the next presentation students of the theory course, Fabian and Felix.
Okay, so thank you. Then I will start. So my keyword was sorting mechanisms or natural sorting mechanism. But to understand the keyword, I wanted to begin by explaining the opposite of it. So let's just do that. Because every natural system strives towards chaos and disorder, described as entropy. It requires only two principles: a system where no absolute chaos is reached yet, and time. It is important to note that entropy is one of the few concepts in which time is specifically described as an asymmetric measurement, called the error of time, where there is no turning back and only one direction to go towards absolute chaos. So to understand the meaning of sorting, then, I'm looking at it from the perspective of avoidance of chaos. Therefore, entropy must be cancelled by different kinds of strategies, no matter what sorting mechanism is integrated. This avoidance of entropy can happen through applied forces into a system or onto each particle inside that system. This would imply a sum of forces in the system that is equal to zero. Another way to counter the natural need for chaos is by decision-making following common rules rather than random decisions. This would require forces and a sort of intelligence, which can apply those forces accordingly to the decisions made. The outcome is a system of constant change, yet the re-establishing of the initial state is just a term of random occurrence in such system. For that to happen, first, the intelligence must be given the ability to store and to access stored information. Second, it must form a decision-making algorithm to apply forces spontaneously, but in a way that they work towards the goal to reach the initial state. This basically describes the concept of problem solving and abstract thinking of a system or of each individual particle inside. A network of constant change would be the artificial life program of BOIDs, which stands for Bird-Oid Objects, developed by Craig Reynolds in 1968, which describes the flocking behavior of birds. There, every particle is given the ability to decide based on 3 factors. Coherence attracts each particle of a discrete grouping to another. This translates to a separation of unequal organizations. Separation describes the avoidance of the particle inside that system to prevent clipping or particles crashing into each other. And alignment that determines the synchronization of velocity, direction, and acceleration to its ejected particles. Following these 3 common rules, a flock of birds can form randomly shaped figures in the sky. They are randomly shaped, but they are in order. The flock is a conglomerate of sorted aggregates. Take away one rule and you end up with either birds crashing into each other or a rip of the flock. So complexity involves the fusion of multiple different systems into an assemblage which behaves as a singularity while remaining irreducible to any single organization. To put this into architectonical terms, Greg Lynn's embryological house shall serve as an example. Greg Lynn invented the embryological house to be a seminal project in the field of digital architectural design. Architecture in which the computer's capacities took it far beyond the status of mere drawing tools. The house, like Greg's other works, evokes the parametrically developed flows of force-become architecture that the design refers to as animate form, or as he calls it, blobitecture. For Lynn and others, such architecture resonates the contemporary cultural and technological conditions. In this case, those conditions demanded a rethinking of both the means of production and the typology of the house as an architectural concept. Through Lynn's production and through Lynn's experimentation with mass customization. Attempting to move beyond classical and modern ideas of the module, Lynn proposed instead the manipulation of an organic, flexible, generic prototype or primitive that provides a set of number of rules from which an infinite number of iterations could be generated, like a flock of birds. As a testing of principles and a play of possibilities, there is no single or final version of the embryological house, nor was there ever intended to be one. Multiplicity and open-endedness. To step into a non-life-based sorting mechanism, we shall investigate the sorting by size, as done in riverbeds solely based on water resistance and gravity. River dunes, alternate bars, and shore beaches are often characterized by a downscaled dune-like landscape, defined by the angle of repose of the lee face of the dune. Transport of mixed-size sediment over the bottom of such bed form results in grain size-selective deposition of particles over the lee face. First, sediment settles from the bed load downstream of the brink point. Most of the sediment deposits there, but a smaller amount, notably the finer grade, settles further downstream. This sediment may be preserved as a new sediment bed. In this setting process, the deposit is fining downstream and along the lee slope. In the second step, when the static angle of repose is exceeded, the slope fails and the sediment avalanches down the slope as grain flow. During this process, the larger grain deposits further down the lee slope and smaller grains deposit near the top of the dune. In a third step, this sorting process gets more defined by the low pressure zone emerging on the lee side, which pushes the smaller and lighter grains upwards, where they meet their other small friends. Result is a dune sorted in 3 zones based on its grain size. As those 3 steps happen simultaneously, the dune migrates downstream. To scale the size of the sorted aggregates even further, our journey final stop is microbiology. There, a quite recent case study from 2018 is the spatial self-organization of Escherichia coli bacteria, which resolves conflicts between individual and collective migration. Collective behavior can spontaneously emerge when individuals follow common rules of interaction, as said earlier. However, the behavior of each individual differs due to existing genetic and non-genetic variation within a system of living particles or organisms. Like birds, where they move together in union when they are joined in a flock, bacteria can act in the same way. The Escherichia coli bacteria is triggered by a placed source of nutrition. At the head of the group, food is plentiful, behind it, nothing is left. In a process called chemotaxis, cells detect this difference and move accordingly, forming a framework of rules that result in collective migration. By reducing the amount of food provided, fewer slow-moving cells can keep up. So the minimum speed required to stay with the group and survive increases. But not all slow-moving cells are left behind and die. While the fastest cells swim to the front where food is plenty, information where to go next is scarce. For the bacteria in the back, it is obvious where to go next. Few food sources are there for the taking. So by, let's see, yeah. By matching the swimming ability to the strength of the cues allowed, the diverse cells to migrate together at the same speed, rather becoming a homogeneous organism. My internet seems to, okay, yeah, no. That's the experiment, and there you can see how the Escherichia coli bacteria is moving in quite a defined arc, rather than flowing all around the place. Yeah. So if individual differs are sacrificed, then the colony might not survive in new circumstances. But if unchecked, individualism dominates and critical collective behavior necessary for survival breaks down. Thank you.
Thank you very much. So we run two presentations. No, we do one presentation, no? Or
we do, in this case, we do two and then comment at the same time. So we can have Felix present.
Yeah, Felix,
the
please.
Keyword fuzzy. Felix? Ah, okay.
Ah, now you can hear me.
Yes.
So, hi, my name is Felix, and I want to welcome you as well to my lecture in Synthetic Landscape Lab Theory. In the beginning, I want to show you what I chose from the start. I chose fuzzy. In that table we had. And first I checked the definition of my main word and its domains, fuzzy, aesthetic, and morphology. The definition of fuzzy is an image or an object having shapes that do not have clear edges. The definition of aesthetic is the beauty and art of something, and the definition of morphology is shape, form, and affiliation to something. In this process, I ran into a problem because the definition of shape and form is the external form, contours, or outline of someone or something, which means it's exactly the opposite of the definition of fuzzy. That's why I came up with that chart, and the decision, it all connects to each other, but only in one small part. Yes. Another thing which defines fuzzy are these two words and their definition. It's shapeness, which is the definition of hue, saturation and lightness, and acutance, which is the clearness of an edge. So what I try to build is a connection between the words who are upcoming and the compilation and the architecture itself. First, I went after the words and I used fuzzy as a starting point. My second step was to look after the closest synonyms of fuzzy. As third step, I went further and searched after all the next related words to fuzzy. And as last step, I looked after the furthest related words. And so I came up with the spider net chart. After that, I checked out their compilation to each other by relationship to fuzzy, which we just saw in the left column, the meaning in the middle, and just after the alphabet on the right side. And I went after the meaning, and I split them into groups by same words, same meaning, different usage, and figurative meaning. And after I did that, I went, I asked myself some questions, and that's what I wrote down. What do these words mean now for and in architecture? Does the object related to the words, or are the words related to the object? Do we consider only the words or the object and have the words related to it? And if so, only the shell, or only the interior, or its division, or both? Or do you look at the object and its surroundings and how they fit together? Does this matching then only refer to the form, or must the material also be harmonized? Or is it enough if only the material harmonize? Or does the use of the object play a role in this? What kind of object is created when the object refers to the world? Can you associate an object which use one of these words, or do you need many? And if so, how many and which ones exactly? Or is it just the name of the object that contains one of these words? And with this in my mind, I started my research, and on the top right, named some information about the building, and below the words that the architects themselves used for their object as to describe them. Here is the fuzzy house, which has that name, fuzzy, which is fuzzily sits between privacy and public. So you don't know where you want to go and not. Then I found the blurry house, which is clear from the outside, but inside you're very blurry. I found the garden center in South Korea, whereas inside very clear and outside the shell is very dull. I had the Philharmonica Hall in China, which has a dull facade and an indefinite feeling inside. From Arne Quince, the Ochronia building, it's the melt facade with nature and perplexing walls. The UK Pavilion by Thomas Heatherwick. The Septon Gallery in Britain, in London, which is very puzzling, and hieroglyphic dimensions inside. And the Croatian Pavilion in Venice for the Biennale 2010. This one had the nickname Fata Morgana, which is also a good name for fuzzy. And that's it. Thanks for your attention.
Thank you, Felix, for your presentation. Maybe you can leave one of the images in the... you already finished.
Okay, wait, hold on.
No worries, we will just see us. At least it's also nice to see everybody for the discussion.
Yeah, which one?
It's okay, we can just stay here. And I will leave the space for the discussion if anyone wants to comment. I have to say I admire or I appreciate, better say, the research that you pushed forward to really unpack all these all these words and synonyms that you discovered from the whole chart, and bring quite a large complexity or collection of case studies, which is a little bit different approach that we were doing with other students, because there we focused more on looking at one specific example more in depth. But with you, we realized that to define the keyword and the meaning of fuzziness within architecture, we need a larger scope of examples, and so you come up with this sort of network of synonyms, which is quite nice.
Yeah.
But I will leave the discussion to continue.
I mean, just to kind of add upon what you were just saying, Teresa. I mean, I really appreciate this presentation because it was different from the others in a way. I mean, they were both very interesting presentations, I would like to say, and I thought they were both kind of going quite in depth in the discussion. But just going back quickly to this presentation, I thought it was a very very, very intriguing way of approaching the meaning, no, of this word by just looking at relationship with words that are similar and so on, and creating this network to try to kind of make some sense out of general meanings. I thought that, you know, if you were continuing this, I thought at this point where you're kind of asking yourself, you know, all these questions, that's very much linked to, you know, philosophical ideas. So it was just kind of, you know, you're talking about the ontology, you're talking about epistemology there, and you're talking about what is actually the essence and the being of these notions, right? So ultimately for me, I think, you know, when you think about fuzziness, is it like a question mark? Is it linked about perception, for instance, right? Is it linked to how do we actually perceive space and these sort of things, or is it a quality that is independent from our perception of space? So I think, I mean, I don't have a reference just off the top of my brain, but I would just try to think that it would totally be about trying to relate to some theory of spatial experience, if it makes sense what I'm trying to say, because then in that case you would kind of be able, out of this big cloud where you are kind of making some sort of sense of the different interpretation of the word, what is it, your fuzziness? I think that would be your next big question here. How do you think this is kind of is it like this blurriness of the you know, the screens like fundamental to your way of thinking architecture, or is it like what type of possibility does this idea open up to design and to create meaning, and which one of all these categories that you are presenting here is the one that is type of relevant for you, no? Because when you kind of show me like the fuzzy house, the very first one, and I look at it and I see nothing like fuzziness there. I see like something that is, you know, a sharp concrete sort of edge, and you know, and probably it refers to some type of organizational logic and these, you know, but I mean, calling this a fuzzy house for me is very hard to understand, right? But again, right? So you're kind of discussing before this like morphology and the difference, the fact that morphology and fuzziness, they're kind of the opposite. And I think that's a very, very strong intuition and a very strong statement. So would that mean that this house is it really fuzzy, or is it more like a branding of it, right? So I think there is a need in this research to establish like some sort of truth, if it makes sense, or non-truth, or some sort of, or understanding what the boundaries of this concept could be. Yeah, but very nice, very nice approach, very fresh.
Thanks for the presentation. I appreciate in the first presentation that there was a coherent visual language, and also the fact that sorting became interwoven with the biological element. In the second case, I think the case studies could have been diagram. I would not put a case studies full page like this without discussing through diagram what we extract out of it. Otherwise, the case studies might defeat what you were trying to discuss, because fuzzy can be, of course, discussed on different level, and it's not about necessarily, I think, truth or not truth, but about framing where you locate yourself in the definition of fuzzy. And then diagram and the way you structure the presentation could enable you to do so. And maybe there are certain definitions that are not necessarily part of your discussion. Like, for example, the Fata Morgana doesn't refer to fuzzy, it's a mirage effect, right? So a mirage is not a neat image, but then it's totally different from the idea of fuzzy logic. So we need to be, maybe frame the point of view from which we look at this, and also the way we have case studies, not just collect case study that connect or resonate with that, but frame how we want to look at that. I think that is an important aspect.
It's kind of interesting again to see the two presentations together, because I think that where the first one offers a really, let's say, quite precise and diagrammatic approach to the process and the unpacking of the process, how the sorting mechanism effectively actualizes in different realms of life, and organic and inorganic life. And I really appreciated that, because in particular kind of brings to the forefront the vitality of some of these inorganic systems like dunes, and again, kind of breaks a little bit the boundaries that we often refer to in terms of landscape architecture, what is biological, what is not biological, etc. Like vitality, it's broader than that. And I think in that sense, the concept of fuzzy, as understood, in the architectural scene, or through this kind of linguistic experiment that you have done in the second presentation, I think it also can benefit, let's say, from the approach of the first presentation, cutting across these different domains. So I don't know, this image, it is in a way funny, to call it fuzzy, but on the other hand, if we accept that there is some truth to the naming, maybe the architects were really trying to express maybe a level of a programmatic fuzziness, or another element of the vitality of the building that goes beyond the sort of form of the envelope. Whereas on the other extreme, for example, the blur building of Dile Scofidio that you haven't shown here, strangely, which is basically made of this cloud of fog, kind of artificially created cloud of fog, represents the kind of extreme manifestation of this sort of concept of the envelope becoming, absolutely enmeshed into a dynamic process like the one of fog, so transient and blurred by definition. So in that sense, I think perhaps if we consider the two presentation as one, there is really shows the possibility of how we could on one side look at concept, diagram them, unpack them in terms of the mechanism, and then on the second kind of begin to deploy these to redefine architecture from this new perspective. So in this case, it could have been interesting to diagram these case studies to unpack the actual mechanism of let's say of blurriness, of fuzziness, you know, which in some cases it's a mechanism that perhaps has to do with the refraction of light through glass or through a specific material. In other cases, may have to do with the actual transformation of the microclimate around and the humidity, and in other cases may have to do with more the transformation, if you want, of the behavior of the people who inhabit it, which are you know, kind of you know, which materialize a pattern of use that blur the inside and outside in some way, you know. So I think that's you know, again, I enjoyed a lot both presentation. I think that they also show how we could keep evolving this format of let's say kind of design-oriented theory course in a way that can become even more specific and sharp in unpacking architecture from the perspective of a synthetic landscape and from the perspective of this particular concept.
Okay, thank you.
I enjoyed both presentations. One thing both presentations made me think of was the resolution. Well, when I was thinking of fuzzy, those images showed a fuzziness from our side, from the human side. But if you zoom in or zoom out, it would have a totally different meaning, probably. That was just a consideration that I wanted to make.
Yeah, to answer that, there was also my thinking in this question. I asked myself, there was like in the fuzzy house. I think the fuzzy house, you don't see it's fuzzy because of the edges. It's like a normal house, or a normal building. Don't say house, building, and the difference, or the how to say, I missed the word, sorry. Now, yeah, you're absolutely right of the scale. If you zoom out, you don't see the edge of that house. It's like it belongs to everything else. But if you go closer, you see the opposite. So.
Makes sense. Thanks.
It's a bit like when you work with your point clouds, no, Matthias?
Exactly. I'm totally into resolution.
Okay, thank you. I think we could move on to the next presentation.
Yeah, and next we have again bachelor presentations, first by Tiago and then by Francisco and Ben.
It's one big group.
So Tiago, you start first.
It's one big group. We are three.
It's one big group. Sorry. Yeah, so all together in this case.
Yeah.
So, hello everybody. So today we are going to show you our Chrysalis Pulse project. For everybody who doesn't know what Chrysalis means, it's just another word for cocoon. And we choose Pulse because our project is all about growth and all about life. So going on, we want to show you where our project started. We visit the Burgruine Tower, which is located in Innsbruck. It's 250 meters above the valley floor and 812 meters above sea level. The environment and location was interesting, just like the plants we found by the ruin.
One of the 3 plants we had to choose from when moving into groups is this one, the branch of a sycamore or mountain maple, which is located in almost all higher altitudes all over the globe and can grow up to 30 to 40 meters high. Not to be confused with the normal maple, but you can keep them apart by the softer leaf edges. Because the plant didn't have much leaf anymore and the outcome of the short walk algorithm wasn't that good and interesting to proceed with the plant, we chose another one.
So the plant I found was a gnaphalium, which is a genus of flowering plants in the sunflower family. They are widespread and common in temperate regions, although some are found on tropical mountains or in subtropical regions of the world. Unfortunately, my plant was small and had weak roots, so we decided to go on with Shardo's plant.
So when we formed our group, we decided to work on with this elderflower, which was growing out of the wall of the ruin. The elderflower is nearly 60 by 60 centimeters, but it could grow up to 11 meters high. So this one is really young. We especially liked the interaction between the wall and the elderflower, which was really interesting to go on with. By making this point cloud, we tried to get knowledge about how the elderflower grows, which came even better out when we used the shortest walk algorithm. You see how the leaves are formed and that everything is kind of hanging down.
To understand the plant a bit more, we have here a matrix, which shows the leaves, just like the fact that the plant consists of 3 roots. Together we have a bush-like structure, which we can see better on the next page. As you can see here, the roots are really big and strong. That's the main reason we choose this plant, and this is going to help us with our project. So going on, we want to show you our inhabitants. The honeybee weighs 50 to 300 milligrams and can be 80 millimeters big, while the mason bee weighs 50 to 90 milligrams and can get to 12 millimeters big, since they don't have a queen. Both prefer sunny areas and are located worldwide, but since the mason bee can also fly in winter, they are preferred by farmers for dusting. Here you also can see the variety of nests. Some are on trees and some can be on walls.
In one of our first course meeting, we talked about the process that is happening at the ruin in general, which is the nature takes over, or in most cases takes back, a human-built structure, most noticeable in the flora. But there's obviously another very important part in ecology, the animals. We were thinking about turning the normal way of architecture, which is mostly humans building something for humans in the nature, into humans building something for the nature on a previous human-built structure. And our project could become a part of this overtaking process. And we found a way to support at least one of the smallest but very important part of wildlife, the bees. To make the mind behind our project more clear, let me explain the bee pollination process first with this graphic. So the bees collect pollen while searching for nectar and carries them around to another plant. And this pollinated plant, the seed production starts, and the seed can grow another plant. And that's what our project builds up to. So the principle behind our project is quite easy and simple to explain. We thought of building a home for bees, which you can see at the very left of our graphic. The bees pollinate plants, which will spread to much more plants and will give the bees and other animals more living space. At this point, the process starts again. So theoretically, it's an exponential growth, which is obviously a great thing, not only for the bee population, but also for the environmental future based on the pollination process.
In the next step, we tried to design a cocoon where our bees can live in. So first we designed the primary holding structure, which is like the which is grown like the elderflower before. Then by adding a thread with, covered by beeswax, it attracts the bees to grow their nest inside. And by some time, the nest gets bigger and bigger, and the whole cocoon will be filled up. In the section, you can see that we also added a shell on the outside, which is covering the real bee nest before wind and snow and rain and direct sunlight.
We also made a sun study to see where the sun shines more often, since the bees prefer sunny, warm areas. As you can see, the two walls on the front get more sunlight over 1 year. That's the main reason we choose this place.
In the next step, we analyzed the root system the elderflower had on the wall before. So since the elderflower is growing out of this gap in the wall, we wanted to discover a root system which could take over the whole ruin. So we made a negative model out of the wall and tried to have the roots by the shortest walk algorithm just in the gaps. And then we scaled it up and made a negative model out of the whole wall. We wanted to place our structure and discovered this, you can see on the right.
In the top view of the ruin, you can see where our plant and the root structure is directly located. You can also see the root system we created, which is taking over the cracks between the stones of the wall we choose to build our structure on. Beside the topographic lines, you can also see the walking path around the ruin, marked by the dotted lines.
In this perspective view, you can see the view of a bee heading home to his cocoon and the whole structure over the whole ruin.
So to complete our presentation, we have a section. This one is not just giving you a look inside the cocoon where you can see the comb again, but also a look inside the wall where you can see the wall cracks the roots of the plant used to stabilize and grow, which is a great concluding overview of our project. Thank you for your attention.
Thank you, guys. So I invite everybody to jump into the conversation.
Yeah, also really cool project and good development also from the last midterm. It looks like you have a really sophisticated technique, like where you were mentioning where you inverted the image of the wall and then you just let the shortest walk path grow kind of in the cracks of the wall. Is that right?
Yeah, we tried to make a 3D model just out of the cracks. So we cut the rocks out and then made a point cloud out of it to let the shortest walk run on it.
Yeah, I think that totally makes sense. But for me, it kind of gets lost in these final images that you were showing. Like I don't see where it's growing in the cracks or how it's kind of connected to the wall. And as you were mentioning, that's kind of the key aspect of your project, that it's kind of integrated in the wall. So that's a little bit unfortunate that it's kind of getting lost in these final images, even though I think it's like a super cool approach of using just the cracks for letting it grow. So that would be my main comment, but really cool project as well.
Well, I mean, let's say from my perspective, I have to say that I find this project less accomplished than the previous ones, I have to say. Not that you didn't work. I mean, I'm sure I can see there is work, there is development, there is the model of this cocoon that you have certainly took quite a lot of effort to produce. And as Corbinian is mentioning, this strategy of let's say trying to colonize the wall, etc., is interesting. But I think that it feels like, you know, overall you haven't quite managed to reconceptualize what you were doing beyond, let's say, the tools or the techniques that you were applying, or the, let's say, literal metaphor of the plant, right? And I think that's a little bit of a problem because, you know, as an architect, I think you have to absorb new tools, transform them into techniques, and then use these techniques to understand, interpret the site, and transform it through your proposal. And it's not clear to me that you were able to do that. I mean, let's say your initial scans, I think you did a few of them, and they were actually, I thought, pretty interesting in themselves. But in your presentation, you dismissed them very quickly as failures. And, you know, again, we don't understand why they are failures. You just say, oh, one is too long, one is too short, one means this is that, but, you know, you just dismiss them. And I think that's the first main problem, because actually those techniques were, in a way, pretty sophisticated in themselves. And they held a lot of potential, not only in terms of basically redrawing a plant, but really in terms of creating a medium for you to basically understand a site which has these complexities, a site where architecture and nature blur. And again, maybe we go back to the concept of fuzziness. I think, you know, this is a very interesting concept for you, for this studio, in a way. Because you actually had the perfect technique to deal and to engage with the fuzziness of the site. And so, yeah, again, so I thought, you know, basically you dismiss these techniques. And in that sense, you kind of shut down a possibility for you to engage with your designer sensibility with this topic. And then, in a way, in terms of narrative, you kind of touch upon a very interesting theme, which is the idea of regreening or rewilding, which is, again, a very popular topic these days. And everybody seems to think that regreening and rewilding means just, you know, letting nature take over again. But actually, it takes a lot of design, a lot of management for a proper rewilding process to take place. So the way I see your proposal is really perhaps in this direction, to show how architects, landscape architects, can effectively engage in processes of rewilding through design, through digital technologies as well, through these techniques that allow us to capture the fuzziness and the vitality of a site and of its systems, and to translate them into design vision for a rewild site that is no longer, of course, natural, but it's a synthetic landscape in that sense, right? So, you know, again, a lot of good elements, and but I think also a lot of missed opportunities. And in my mind, the missed opportunities are really due to a lack of maybe patience or sensibility on your side to actually stick with the beautiful techniques and you know, starting points you had, and you know, kind of follow them through until they would, you know, reveal to you the possibilities. And that's I think my main critique anyway. Also, my main suggestion for the future is that, you know, when you go along into a new design process like this, you need to have the patience, the constant application to engage with it until it actually reveals its potential beyond what you already know or what you can imagine, and you know, and essentially open up a new world of possibilities, of visions and interpretations that go beyond the literal. And so that's, I think it's probably what you need to look at for the future.
Now, looking back at the presentation before Christmas, there is some things that got better and some things that got worse. I'm not sure which ones exactly, but I have the impression that you tried to reduce and also to simplify some concepts. On the other hand, I had the impression that you tried to rewrite the narrative, even if I'm not sure if your narrative was better before than now. I mean, I remember your cocoon spreading all over the wall, and now you just reduced it to a part. I have the impression that you really worked a lot with 3D scanning the wall probably, and maybe it wasn't that easy. But what I miss is that you further developed the narrative from last time we saw your presentation, you know? I mean, you were at a quite good point back then. In general, I have to say, I miss the point clouds. I mean, you can do such beautiful drawings with point clouds, and I know it's hard to work with them, I know, but I really miss point clouds, using them as a representative instrument, you know?
All right. Thank you guys for the presentation. I would also say, just agree with the comments. I think it's a good work. I'm missing resolution of the point cloud reflected in the development, but thanks for the presentation. I propose to...
I have a short comment. Sorry,
Yeah.
Maria, I didn't comment.
Yeah, sure.
Yeah. No, I did appreciate the project. I think one element to try and develop further in the future is the relationship between the biological element and the structure that you have been proposing, because the two at the moment don't seem so connected, nor behavioral nor morphological. So I think the brief has got an interest, some of the 3D scanning as well, but then this relationship between these two could have been evolved further. That is my main comment. Thank you anyway. Good. Maria, who do we have next?
Next, we have again theory presentation by Catherine and Carlo. Catherine, Carlo, please start.
Yeah,
Sharing your screen. Okay, super.
I just will share our screen.
Okay, perfect.
Okay, we chose 3 keywords because we were a group of 3 people. We're now just 2, so we go furthermore into 2 of the keywords, which are self-organization and superimposition. And lastly, we'll explain the keyword voxel, because it's we have a project who will combine these 3.
Yeah, so we start with the word self-organization. By definition, self-organization is a process that happens through the interaction of either similar or different components, resulting in a new system created only based on information from those specific components, without being influenced by any outer circumstances. The most relevant part is the interaction, creating a new organization with a different form arising from the individual initially disordered parts. The work can be used in many different domains like politics, social environment, social activities, and many more. But in architecture, self-organization is closely related to the concept of emergence, which is generally understood to mean that the whole is greater than the sum of its parts, a phrase credited to Aristotle, meaning that the single parts result in a new form only through cooperation that they could never have attempted by themselves. According to Michael Hensel, Achim Menges, and Michael Weinstock, the principles of self-organization on buildings can be seen as systems, maybe even ecosystems, influenced by their tectonic and thermodynamic aspects. Achim Menges applies the theories of self-organizing systems to structural design, form finding, and research on physical materials, for example, in the pavilion from 2015 till 16, built in the Institute for Computational Design and Construction in Stuttgart.
More of the keyword of superimposition, and it means to impose, place, or set over, above, or on something else. In architecture, can provide a method which is based on creating different aspects in theoretical and practical terms at the same time. Making an overlay in design process can refer to putting images on top of each other, creating masks, and furthermore, in consideration that all of the layers should be evident. In Parc de la Villette, Bernard Tschumi creates an overlay of many actions, structures, and plans on top of each other. The project works by the principle of not just forms follows function, but also vice versa. And the Parc de la Villette as illustration for superimposition bridges different domains and brings multiple layers of concept together as a whole. The same principle correlates with a self-organizing system considered by small, similar units, but what emerges can be heterogeneous and doesn't only apply to monofunctional systems. The emergent capacity of the Parc de la Villette is the result of different layers in something new, bigger than a single layer itself. However, they may interact with each other, either through overlay in opposition to each other, or maybe even not in a relation at all. Still, they result in an interrelated and continuous superimposition as a whole.
Yeah, now the last keyword, voxel. By definition, a voxel represents a value on a regular grid in three-dimensional space and can also be used to describe the resolution of volumetric displays. The word itself originated analogously in the word pixel, with VO representing volume and EL representing element. Common uses of voxels include volumetric imaging in medicine like X-rays, MRI, or ultrasound, and representation of terrain in games and simulations where voxel terrain can be used instead of a heat map.
And for the design process of Biopolis from the UM lab and USL, a procedural approach of form was used. A math growth algorithm contributed to the design of the project at a prototypical architectural and urban scale by following the basic logic of gross moth growth. And the photographic screening point clouds of the growing branches result in a synthetic landscape constituted by the moss voxel as units. Here I can also see the Biopolis over the city. And thank you for your attention.
Thank you. So Teresa, we have just one presentation, right?
Yes, now we have just one presentation. Your presentation actually could be a little bit expanded because you are working with more keywords and took same time as one person in the end. But I appreciate you tried to be compact because you are the only one who can compactness seriously and really compact and compress, which is really good. So thank you. I'll leave the discussion open if anyone wants to comment.
Well, thanks for the presentation. I appreciate the compactness. Again, as I made the comment with other, I think it was clear. I also like the possible correlation that can emerge between self-organization and voxel for different reasons that I will explain in a second. I think that again, the case studies would have been better organized in a diagram that showed the relationship between them rather than one per page that seems more you are presenting a design project. Is really about unveiling some of the relationship. In terms of voxels and self-organization, I think the two have been paired quite a lot. And there is also a quite controversial discussion about that emerge from the pairing of the two related to how we see digital architecture today. So whether digital architecture is a continuous system or a discretized one. And maybe it would have been appropriate to touch on some of these theory and the controversy that can emerge from that. So this is something that, I mean, these two terms nearby, I think it would have been a direction to maybe explore. Other than that, I think the first part of the presentation was clear.
Yeah.
don't know if there is anyone who want to join. I also wanted to comment one more time that I really appreciate the visual language that you have chosen, the projects and the way your presentation was developing throughout the whole semester. Also the way you are framing the arguments and create a connection. Yeah, maybe in some cases we already learned, as Claudia was saying, that it would be interesting to see it more of a diagram somehow, how and which element of each keyword is connecting to the other and how, and in which scale. But again, this is maybe some steps for further development.
Yeah, I mean, I haven't seen much change or progress, to be honest, from our last conversation. So I don't know, maybe, yeah, like you said, you try to be very concise, and in that sense, that didn't help. But I mean, yeah, for me, it's fine. I mean, I already comment most of the point before, I guess, with you. So I don't have much else to add. So it's okay. Thank you.
Thanks. We can move on to next presentation.
Yeah, I think we have one presentation left, right?
Are we going again to a VR room? Or?
But not least, exactly. We are coming back to the VR, and we invite Manpreet to present his project. Manpreet, could you please share a link to the hub as well here in the chat?
Yes, for sure. I will post a link.
So, and we need to finalize this day with some energy. So, Manpreet,
already posted.
you should give us some energy, because I think we are losing power.
Yes, I will do. Yeah. Okay.
Okay. So again, we stay with the sound here, and we go to the room to see the space. Cool. So I think we can start, Manfred.
Okay. Did my audio already started? No, nothing. Okay, sorry. Welcome to my hub room. My name is Manfred and I did my bachelor's in Liechtenstein. Today, I want to present you my project, which is called Water Roots. First, I will tell you short about my concept and my inspiration. Then I will continue to show you my work progress of my proposal. As you see, the source of my inspiration was the IV plant, which was growing through space and climbing on walls. So my first step was to take an IV leaf because its structure and growing and its environmental advantages were inspiring me. To analyze it in more detail, I finally focused on the microscopic structure of the leaf. So the first pictures, which are you seeing now, is an IV plant. Oh, sorry, which is an IV plant, which is going up a wall. Please focus on the growing pattern of the plant. Now you see the microscopic patterns, microscopic sections of an IV leaf. The purple and the yellow parts are the channels where the water is distributed through the leaves. Please follow me to reach my main presentation room by go through the ground floor below you. Just go down. Okay. Sorry, something happened. I don't see anything. Ah, so sorry. Besides of the inner structure of an IV plant, I also thought about location where IV is growing. And secondly, would be an environmental problem to solve. I ended up in Almeria, which is a city in Spain. Below us, you see the city. Almeria is a place where vegetables for Europe are grown and exported. For this, a lot of water is needed. All the white surfaces.
Welcome to my hub room. My name is Krier. Can I leave my badge?
I'm really sorry, something happened. I'm kicked out. Sorry, it's a problem, I don't know. It's never happened before. So sorry, I'm back again. Almeria is a place where vegetables for Europe are grown and exported. For this, a lot of water is needed. All the white surfaces, which are you seeing here, are the tents of the greenhouses for their cultivation. In the near future, there will be too less water to still distribute to plants because the weather is getting drier and rain is more seldom. So my concept is to reorganize the distribution system based on the realization of an IV leaf. To do so, I split the area into these 3 red frames, which you can see on the map. These areas are chosen by the main groundwater resources based on my research, which will be in the nearest future one of the only constant water supplier. To my progress, I decided to concentrate just on the 3rd frame, which is an opposite side to where we are standing now. Due to my progress, I started to analyze these 3 frames with landscape analyzation methods, which will you see to the next flow below that one. So please fly to the next floor. This one is the result of the second frame. Here you see the already built water distribution system of the Roman Empire and some rainwater retention basins in a color cyan. Over the whole plan, you see the white-height contour lines of the area. As you see by these lines, the mountains are starting in north, and there you see the flow lines too, which led to the coast to the south. These flow lines ending up in a purple diagram, which I will explain in the next floor below. Please meet me at the highlighted frame below. So let's go downwards to the next layer. The purple diagram is the result of my calculation where the groundwater could be collected. It is a drawing based on a connection between the endpoints of the flow lines. There, where the most density accumulation of the curves are, is the best location to collect the water. In the next step, I projected these results on the original landscape of Almeria, which you see on the next floor below us. So let's go to the next one. Just past this frame where you see the tents with the heights of 10 meters and the flow lines, which are passing them. Meet me at the ground model below that one. On this model, you see on the one hand, the satellite picture of the area in black and white. The black regions are the lakes, which were already used to collect the water. And on the other hand, my groundwater calculation, which are in the same location as the lakes. Through the whole area, the main groundwater regions are meeting up in the middle of the site. This will be better seen in the next layers below that one. We will meet us on the next highlighted frame. Below that model. Now you see my progress since the midterm presentation. There we discussed that I should try to analyze some area with my groundwater calculation by using the displaced script and find inspiration for a distribution system. So I changed my groundwater diagram into a black and white plan. To the whitest surfaces are the most density regions of the diagrams. I decided that the script should read these parts as the lowest points below the terrain surface. So the result was that a lot of water pools were formed through the whole area. So when we go to the model, you see to the ground marker on the model, you see the result of the water pools. To get then now we can go to the next layer below. Below that model, yeah. To get an actual idea of a distribution organization, I used a macroscopic cell plan of an IV leaf where the main veins were highlighted. Furthermore, I used that plan and the satellite picture of that area for the cyclogram 2D to get a result how a distribution would look like. Here you see the cyclogram 2D result in that frame. Please go to the next level below. Based on the macroscopic plan source, the brown surfaces are the main veins of the leaf, and the tents are all reorganized as the microscopic cells. I interpreted these main veins as roots, which are growing over the greenhouses like an IV plant is climbing up the walls. So I made again a black and white plan to use this for this placer script. But this time the white areas are the highest points of the surface. So we can go to the mesh, to the model below. The result is a model which shows us the different heights of the main veins and how they grow through the area. I used the model further to develop a point cloud for my main proposal. For that, we should go to the next level below. Based on the fact that the curves are highlighting the groundwater regions, I projected the points of these curves on the main distribution veins, which have been built up in a model above us. So I got points with different heights and locations, which could be seen in a point cloud below. Furthermore, you see in the next level the input plan for the CycleGAN 3D. So we can go down. Here you see this, the input for a CycleGAN 3D. And if you go below that level, you see the point cloud, which was built up by the groundwater analyzation. Please fly to the right side of the frame to get a better view for the whole model below us. My quite radical first draft proposes an underground distribution system which pools are protected from evaporation by a static structure where IV can be growing. Because of the IV's environmental advantages, the air will have a better air quality, which will be supported by an air filter, which was a result of the CycleGAN 3D. The air filter was developed by the data of the cell structure of an IV plant and the environment. So when you go to the pool directly in the frame, we can go a more detailed view about everything. Above us, you see the static structure in black with the IV growing on it. The structure is directly connected with the air filter, which is in purple. There it is really nice to follow the black particles through the air filter and see how it's working. And below the terrain, and you can flow below it, you see how each pool is connected with the channels to distribute the whole area. Please take your time and fly around the model below the terrain and over the terrain and outside the frame. So thank you for my attention. This was my project, Water Roots.
Thank you very much, Manfred, for your presentation. I like to maybe go a bit up the surface and some middle steps. It has been a long trip, I need to say, from the very way up to down.
Okay, but you know, the progress you made, Manpreet, is astonishing. I mean, I have to say, I haven't seen, I wasn't expecting this. And, you know, although there are several things that I could comment on in terms of how it could be improved, I think that I have to say that your progress is pretty exceptional. And so that really shows that you went for it. So that I think I really applaud that in you. And I also kind of, there are a couple of things that are pretty cool that you've done. I mean, like, for example, this idea of starting in a sort of black chamber where you sort of gave this kind of initial introduction. That's a kind of nice trick, for example, to start. I think I quite like that. And again, I think the idea of kind of using the layers, which we have seen, for instance, in Thole yesterday, I think it's also well executed. I think, and again, I think also there is I think a pretty clear narrative going through it, and you know, the correlation between the data. Where is not as successful, I think, if we compare it to Thole's one, for example, is that in a way, when the way you talk us through it, it almost feels like you are doing a sort of 3D PowerPoint. You know, like you are kind of talking about these layers one after the other, as if you are not really, you know, bringing us through it for real, but you are kind of showing us slides of it. You know, simply that the slides are not just you know, in 2D, but they are in some kind of 3D. And you know, obviously that in itself brings an extra dimension, but on the other hand, it doesn't quite comes all together in a way that is a sort of a believable experience in a sense, right? Like you have the feeling that you kind of don't have the feeling that you are inhabiting this proposal as a coherent whole, but rather that you're literally going through a series of data layers. You know, in a way that could be fine. You know, like I think maybe your proposal could be more in the category of, let's say, augmented platform for planning, you know, at that level. I think it could work well at that level with some adjustments. But yeah, I think maybe the thing that needs to be improved the most, I think it's really your narrative or the way you kind of drive us through it, which kind of needs to lose the sort of temporal sequence of what you have done in the studio or the actual tools that you're using, and needs to become much more actualized in terms of how do you see, you know, us or the community or, you know, the stakeholders that the project engages with, how they can use it. Now, how can this become operational as such, you know? You know, remember, this is real. It's not like a fake. It's a real public platform. I mean, you could bring people in, all kind of people. It's really about shifting the mind frame from, you know, the studio being like a place where we do our thing and then, you know, we do our PowerPoint and then, you know, we go home, to actually be able to create an open forum where data and research is shared collectively and can become directly operational in, you know, in affecting the way territories are transformed. And so in that sense, I think you could basically just hear yourself speaking and you know, realize that that wouldn't be very effective if you had a bunch of stakeholders around, you know, wanting to hear from you as a sort of expert, let's say, in, you know, open data manipulation, if you want. So, you know, again, I think for me, the biggest element here is you trying to shift your perspective, that now you're not just like a student, but you are a professional, a design innovator that is able to build open platforms for, you know, transforming territories through a completely different set of instruments than before. And, you know, I think that's really a kind of realization that I couldn't see in your presentation, but, you know, maybe it's also something that we haven't fully realized collectively as a studio. Maybe it's because, you know, we're just engaging with it, everything is so new. But I think in your project it's probably more evident than in others that you know, maybe because of your you know, the journey that you had to do from, you know, acquiring techniques and you know, becoming proficient with them and so on. Maybe it was a lot, you know, harder than for others. But again, I mean, I think I really want to congratulate for what you achieved in this relatively short amount of time, and you know, and I think you should definitely consider taking this further in the future.
I absolutely agree. I'm very happy with the progress. I'm very happy that, like, in some weeks back, you just took all the work that you've done during the semester and organized it. And yeah, there are still steps to do, but I think you're almost there. I really like your work with gun techniques. I think those drawings are very successful. And if we give them more attention, I think that would be better. Maybe this kind of post-production of the gun drawings could have higher resolution. And I think that here is a moment when we lost the step. No, maybe we needed to stay there a bit longer, develop some techniques to translate the information from two-dimensional drawing into the 3D, and then all the other layers down would become even like more successful and more clear. So maybe the moments where we are lacking some development is actually the final proposal, where I think that this structure that you are proposing into the whole narrative, it works. It just needs more time, more resolution, and more attention to that. Some kind of distribution system for the water supply, the different types of the pooling system, this reorganization of the existing agricultural land, I think that perfectly works. And the idea is actually quite smart. But yeah, since we were not there yet to develop it, maybe that's the part which we are missing, and it's becoming a bit unclear when as your middle layers for me are the most successful. So thank you very much for your work during the whole semester and for the presentation today. Anybody else wants to join the comments?
Yeah, thanks for the presentation. I think in a way it would be good, and this anticipates something I will discuss later with all the students still present, to craft or discuss this path better. It was clear, or it was somehow appearing from the presentation, maybe some of the development were last minute, because you were presenting them maybe in a not just so edited manner, and at some point we were losing the connection between the introduction, the relationship with the biological reference, and the proposal, because I guess there has been a lot of development in the last period, and this is there needs to be a connection with the narrative and the way you present it that is a little bit more streamlined. So maybe this is something you can do in the next couple of days, and then edit your submission so that we can review it with the rest of the faculty for the final grading of the project. I think that will be good, and will be good in general for the project to summarize and the effort and complete it.
Yes, thanks.
I think in general for all the projects, now as we were discussing, that it would be good to sum up all the materials together in some in the final submission, maybe in a booklet. We will inform you guys about that later on, but just expect that there will be some submission after.
Do we have more comment on Manpreet project from the guest? If not, maybe thank you, Manpreet. Maybe you can, we can stop sharing, whoever is sharing at the moment. Thank you. So thanks everybody, thanks the students that are still here. I don't think we have everybody, but we will also write to the other. If the student have any question or comment that they want to voice us now, please let us know, otherwise later. I would like to congratulate to everybody, but also ask you not to disappear, because we would like to check the material that has been submitted until now. And because of the format about the jury are at the moment, it's important that we sit with the rest of the faculty and see calmly the material before we send you our final comment and grade. So we will probably ask to all the group from second to here studio to theory to master design and pre-diploma a short submission that will come in different format depending from the course. So there is no point of summarizing that here. So watch out for the email of one of the faculty of the different course. We will ask for a submission probably by the 3rd of February, and then review that we have all the material, and then let you know if we need something more. Otherwise, from there, you are free and possibly completed of this course. I would say it's been a pleasure, really enriching the conversation, having these different courses together. At time also disoriented, but that's, I guess, is part of creating culture, has always been. So we will eventually streamline the format, but it's been a pleasure to be able to cross-reference development on the theoretical level as well as on the design and technological level. Thank you. If student or faculty have other comments.
I just wanted to add myself, I enjoyed it a lot. Especially I like these kind of, you know, peels of theory or kind of a conceptual development of keywords like being disseminated in the middle of the project, because like kind of almost automatically you make kind of associations between those and different aspects of the project. I think that is a quite intriguing thing to do. Maybe can improve the style, of course, but I think it was kind of fun. And also to see a cross section of the curriculum just opposed in this way, it's fascinating. So I mean, thank you everyone for the contribution and for the great work. At least from my perspective, I enjoyed it a lot.
Yeah, I also want just to add like a couple of notes. I thought it was a fantastic format, because to be able to see the work, like after having worked a semester with a group, to see like the breadth and to kind of be able to also like position the different level of the students. And I think it's very inspiring for me as a tutor, but also like I'm sure for the students to kind of be able to see this whole thing together, and the pro and the different stages and the different thoughts. It was very enriching. But I have to say, the thing I liked the best of all were the virtual room. They were so disorienting, and my computer was just not able to take them at all. I mean, now I figure out what the issue is, but I thought they were fantastic. And there's so much like room for growth, and they kind of open up so many very, very interesting questions about what can be done in that environment. So, I mean, really well done for picking the challenge up to the whole team and to the students that work on those projects. But
Marco is Maria's fault. They always try to disorient me. I tend to resist most of the time, but
we do our best to disorient everybody.
I need to accept the challenge.
Yeah,
maybe we should also, in that sense, I just also want to thank Irene, which has been a little bit in the background today, but essentially she was really instrumental also in making this happen, because obviously there were several challenges to overcome, and no one is really expert in this yet. I would say it's such a new field, but definitely she contributed heavily on that too.
Yeah. No, I think we have a great result from all the courses, and I agree that it was interesting to see and more dynamic to see different projects. I don't know what students think, but for us, I think it was a bit easier to concentrate, to connect, and see the projects at the different levels. So yeah, thank you very much for all the faculty, for all the guests, and for all the students for presentations, comments, and great discussion. Great pleasure to spend together 2 days, fully online, but almost, I don't know, I feel that I almost felt your physical presence in my room, not only virtual, but physical as well. So let's keep in contact, and let's continue working together next semester. So, and for this, with these words, I think we need to close the session, no? If anybody wants to add anything? Okay, we are good.
We look forward to see next project from all of you.
Yeah. So. Thanks a lot.
Yeah, I'm also sure we will finally going to meet again soon. I'm optimistic, but at the same time, yeah, let's push the avatar design as much as we can, so that our virtual sessions will become closer and closer to the reality, or maybe even more, because we are inside of these extraordinary creations of yours. So yeah, it was a pleasure again.
I like that we have, like, I don't know, I think the Synthetic Landscape Lab, we have a really great a feeling within the team, and within the team the students. So I really believe that guys, for example, who is now in bachelor, that you come back to us in master, we will be very happy to see you and continue your beginnings, which are now in a really, really great level. So I think, yeah, I kind of call you back in some semesters. So we close the session. Thank you.
So there is
Bye.
Bye, thanks.
Bye.
See each other soon.
Bye, everybody. Bye-bye.